All right. I suppose people will keep on pouring in, but we will have to start this second day of Heapcon. Thank you for being here once again for another keynote session, this time by Ted Newward. A couple of service information before we kick off. So we sent out an announcement that there may be some water shortages. For now, we are fine, but Svetogorska Street, for example, parts of it don't have water, and parts, of course, of city center also. And they announced that all works will be done by noon, so I hope it keeps us all together. Also, you saw some donation boxes up the stairs by Heapcon booth. Our speaker, Nemanja, after his session at 11 a.m. will be doing a brief solo concert to encourage all of you to join the small party and donate, and he will also match your donations until he goes bankrupt. So yeah, it's two organizations that donate to child healthcare, children who battle with cancer. So it's a really great cause, and we would appreciate if you helped it. Ted, welcome to Heapcon. Ted was also a big part of our unconference event, which we are also trying to promote because we liked it that much. Ted, what were your impressions?
It was terrible.
Okay.
No, it was fun. It was fun.
Killing it.
Yeah. You know, there's always kind of there's a change in dynamic when you come down off the stage, so to speak, and it's fun just being one of a group of people sitting around with opinions. So yeah, I'm a fan of the whole format. Yeah, so great. Yeah, it was good.
Keynote speech is on the whole other side of that. So yeah,
exactly.
We let you have it both ways. Ted is originally based in the US, but he's a global speaker and currently works for Quicken Loans, but I will just have him his hour now. And Ted, good luck.
Thank you. So, for most of you, I imagine the first question that's going across your mind is, what the hell do I mean by polytechnical careering? This is not the English that you were taught in school. What I mean specifically about polytechnical, a few years ago, a colleague of mine by the name of Neil Ford started going around and talking to people about being a polyglot. And polyglot, of course, means multiple languages. Anybody know what you call somebody who can only speak one language? American. Just thought I'd throw that out there. But it's more than just multiple programming languages that you really want to be aware of, because when you really start thinking about it, you really also want to be very familiar with different forms of storage, right? You want to understand how the various NoSQLs behave, whether it's a graph database, whether it's a document database, whether it's a key value store, whether it's a more non-traditional relational database. They all have different implications, and you kind of want to be up to speed on a bunch of those as well. And when you start thinking about where do I put all of this code, where do I put the data, well, we have a series of different foundations, platforms, upon which we do this, right? Obviously, we've got several cloud players in mind: Amazon, Microsoft Azure, Google Cloud, etc. There's smaller platforms as well, Heroku and App Harbor and so forth. And then there's also, of course, the platform that we all started with, which is to say your company's platform, which in some cases may just be a PC tucked away under a desk somewhere, and please, please, please don't kick the power cord, right? By the way, if you're still doing that today, please stop. Please stop. That's a terrible platform. And so you really want to be familiar with all three of these kinds of things. You really want to have a very broad skill set. Because when you are, in fact, polytechnical, when you have this breadth, you understand a variety of things that a number of people don't. If you describe yourself as a Java developer, and you've never, ever, ever looked at C# or F# or Scala or Haskell or Go or Rust or any of those other things. What you're doing is you're limiting your viewpoint. You're limiting your perception. You have only just this narrow view through the keyhole that you understand. You don't see value in any of those other technologies. How could you? You've never looked at them. And you don't, you start becoming victim to this notion that there can be a one size that fits everybody. When you start examining these different technologies, you see the differences and you realize that there is no such thing as a one-size-fits-all. You realize that there is no technology that can solve all of your problems. More importantly, you also begin to understand that there is significant overlap between all of these technologies, and that in fact, if I go to you and say, hey, I want you to build for me a website, and you say, great, do you care what technology it is? Because Java could do it, .NET could do it, Perl could maybe do it. Nah, never mind, Perl couldn't do it. What ends up happening, and it's particularly fun that I'm doing this here in Yugoslavia, you find yourself identifying with Karl Marx. From each technology according to its abilities, to each project according to its needs. The other stuff, right, the whole communist, yeah, it's because Karl was misquoted. This is what he actually said in the Communist Manifesto so many years ago. But this begs the question, why on earth would you want to do this? Because very frankly, this is hard. This is not easy. To sit down and learn new programming languages, to sit down and learn new storage technologies, this all takes time. I mean, let's be clear, if you want to study Go, you're probably going to have to spend 6 months serious study time. Now, not necessarily full time. You can do this weekends and evenings and whatnot, but you start consuming time that is potentially useful for other things like, I don't know, sleep. And, where does this really leave you? Because if you spend so much time studying all these different things, I personally know probably about 36 different programming languages, which means that I could start writing code, and I would probably have to go back to a cheat sheet every so often to remember certain syntax. And you run the risk of becoming, in what we say in English, a jack of all trades, master of none. You're not great in any of them. You're okay in all of them. And let's assume for the moment that you convince yourself that that's okay, that it's all right to not be really super incredibly powerful on any one language. It's okay to actually have a broad swath of knowledge. But then we start talking about, if I actually use multiples of these technologies on the same project, well, then I have to figure out how I'm going to talk back and forth to one another. If I look at Python, for example, and I say, wow, Python is great, it's amazing for data science, I want to do all this data science work in Python, and we currently run on top of the Java virtual machine, somehow I have to figure out how to get Python to run on top of the JVM, or I have to figure out how to get my Python code to talk to the JVM. I'm absolutely introducing some additional complexity into the project, and it's a fair question to ask, does it really need to be there? The other thing that we run into is as you study more of these languages, you start discovering that the way in which we think changes. The way that a Python developer approaches a problem is actually going to be somewhat different from the way that a Java developer does, or the way that a .NET C# developer does. And is it really worth the pain of two people sitting in a room arguing over which approach that we're going to use? Many of you work for various companies, and you may have run across certain problems that show up inside your various projects. For example, you may have a particular project where the logic, the business logic, changes on a regular basis. You may find that there are certain problems that are complex permutations, Classic example here, for example, is if I have, say, 27 different possibilities, and I need to figure out which one yields the best result, or which one even yields a result that's possible. Think about, for example, when you buy a new computer, and there are all these different options, but if you select one particular option, if you select the supernuclear graphics card for your laptop, then you cannot have the second hard drive. Or if you take the second hard drive, then you cannot have the extended battery. You think about having to code all of those possible permutations in a traditional language, and it just makes your skin crawl. In some cases, the logic that we want to work with is best done by domain experts. I work for a company that does mortgage lending. We literally lend billions of dollars every year to people in the United States so they can buy a house. There's no way in hell that I'm a mortgage banker. I have no idea all of the different products, all of the different tweaks, the various points and APR and percentage rates, and that's not me. So now, on this particular project, if we are talking about trying to rebuild our website that will allow people to come in, sign up, and start the process to get a mortgage, and I want to present to them all of the possible options, I have to become a mortgage banker, or I have to have a mortgage banker sitting with me the entire time, looking over my shoulder, constantly chatting back and forth. Now, maybe you work for a company where a business analyst will do all of that work for you. Yeah, sure you do. I'm sure the business analyst knows everything about mortgage banking because they chose to be a business analyst instead of a mortgage banker who can make like 5 times as much money. How do we get that domain logic out of people's heads and into code? Or in some scenarios, we run into particular cases where the requirements that we are trying to build, they don't fit a particular paradigm. This was actually a major problem in the Java world for a number of years in the late 90s, early 2000s. And a lot of the Java technology moved into the financial space, where a lot of the financial space is built around transactions. Tell me, how do you model transactions in objects, particularly if you're trying to do a domain-driven design? Where are the nouns in a transaction? We struggled with this for quite some time. Sun tried to give us a transactional technology. It was called Enterprise Java Beans. And quite frankly, so many of the developers who were trying to use EJB didn't understand that it was about transactions, it was not about objects. That EJB was effectively poisoned on a technology, not because it was terrible, well, no, it was, but because we didn't understand what it was trying to accomplish for us. The last scenario that you may run across is you have a disparate team. You've basically decided to go do some volunteer work. And here are a bunch of volunteers that are working with you, and none of you share the same programming language. One of you is a .NET, one of you is Python, one of you is Java, one of you is Perl, one of you is C++. Any of these sounding familiar? These are problems that routinely show up in a lot of the projects that I've been on, quite frankly. How do you solve them? Well, if the logic changes on a regular basis, one of the things that we as software developers really stress is the idea that when we release something to production, it is tested, it is solid, it is good. We make sure that it in fact works. And as a result, historically, we have deliberately, in some cases, introduced delays. Now, the whole DevOps movement, I understand, the whole idea is that we will eventually, get to a point where we can ship code on, say, a daily basis. Just real quick show of hands, how many people ship code on a daily basis? I see 5 hands out of maybe 50, 100 people. Okay, cool, that's great for you guys. The rest of us, however, in many cases, we move too slowly for the business. And the business, in many cases, the changes that they want to make are pure business logic changes. In theory, there's no change to anything in storage. There's no change to any of the actual processing that takes place. Or worse, they want to change the logic, or they have to change the logic because of external factors. If the government decides tomorrow that it is no longer legal to lend to people in certain parts of the country, we have to implement that regardless of where we are in the sprint cycle. Now, hopefully the government gives us a little bit more of a heads up, but sometimes things happen. And we have to figure out a way to change that logic on a dime. Answer: what if we, in fact, create an engine, if you will, inside of the application that allows end users, that is to say the business folks, to be able to make their own changes? Think about this. It's an e-commerce platform that you're building, and the marketing department wants to stand up a special because suddenly the Rambo movie is taking off, and they want to offer a special deal. Anybody buying the Rambo movie also gets a Rambo t-shirt for free. If they wait for the standard week or 2 weeks, we might miss this window. And so you give them a scripting engine, whether it's something that's built in JavaScript or Lua even, which is a language that is frequently used to script video games. Because when you're a video game, you build your engine, and then you build the levels in a scripting language around the engine so that the level designers can tweak and tune and create new downloadable content, new skins, new themes, new characters, etc., without having to modify the core engine. Same principle, different industry. Or you've got that problem of complex permutations. The laptop design problem I mentioned earlier. How many people here have done Sudoku? Right? The number problem? Yeah, a fair number of us. How many of you would write a Sudoku solver in your favorite programming language, Java? I got like maybe one hand, and then he looked around and went, oh shit, nobody else is raising their hand, and he quickly put it back down again. This is not easy when you think about it, particularly if you're using the wrong programming language. See, that particular kind of problem, Sudoku, is what's known as a constrained logic problem. And there are actually programming languages, Prolog, that are specifically designed for that kind of problem. If you've ever worked with a formal rules engine, a ready graph engine, you're also in the same space. And a lot of the original rules engines were designed to support expert systems when we were doing artificial intelligence back in the 80s. Yeah, by the way, kids, for those of you who haven't lived through one of the 3 cycles of AI hype, we've been here before. So take your machine learning and just hold on to it, because it doesn't mean that now AI is going to be great. Everything I hear about machine learning, I heard about expert systems back in the late 80s, and everything about that, we heard about natural language processing back in the 60s, so just cool your jets a little bit with the whole AI thing, all right? Constrained logic is definitely a solvable problem if you've got the right tool. What happens when we talk about domain experts? Well, in some cases, what we really should be thinking about is, how do we create something that is intrinsically the language of mortgage? When I go and sit and talk to a mortgage banker and I start thinking and I start talking and I start listening, and they're talking about points and percentages and so forth, is there a way for me to generalize this, not necessarily into a Turing-complete programming language? That's not the point. The world has enough Turing-complete general programming languages. But can I build something that allows them to express their ideas, their products, their initiatives, etc., in a syntax that is comfortable to them? We see domain-specific languages all over the place. If you've ever been to Starbucks and ordered a coffee, you walk into Starbucks and say, I'll have a large coffee, right? No, that's not what they do. What is it? It's a venti grande, double shot, no whip. The hell is that? I'm not a coffee guy. I don't order from Starbucks, right? Now, if we want to talk about Diet Coke, that's a whole different story. Starbucks has a domain-specific language so that you can get exactly what you're interested in drinking. If you've ever been to the United States, particularly the southern part of the United States, you understand that there is this institution called Waffle House. Waffle House, ladies and gentlemen, if you've never been, it is best experienced at 2 in the morning while drunk. But they have a whole variety of different ways that you can get your potatoes. You can get them scattered, smothered, covered, I forget all of it. There's like 47 different ways that you can get your Waffle House grits. Or if you're not really a late night drunk breakfast kind of person, there is a fast food chain in the US called In-N-Out. All they do is hamburgers. And they have a secret menu. They won't actually show you. It's never printed there. But if you know, you walk into an In-N-Out and say, I'll have a double-double, animal style. What that means is you get it with grilled onions. And they've got it protein style, and they've got all kinds of different ways to do this, right? Protein style is where you get the patties, but it's in lettuce as opposed to a bun. Worst idea ever, quite frankly. But hey, these are all domain-specific languages. Why wouldn't we, as developers, create tools that our domain experts can utilize directly in order to best express the ideas that they want to convey, as opposed to trying to bounce it through our heads and into code? Why don't we take those concepts, create a tool around those concepts, and give it over to them and say, have fun, party. And you can do all of these things without my involvement whatsoever. And in some scenarios, we have relationships that just don't fit. How many people have done that ancestry thing where you like swab your DNA and send it off to God knows who and they track your ancestry, right? This is becoming a really popular thing in the US. And as a matter of fact, if you really want to see all of your family relationships, the place you really want to be, believe it or not, is Salt Lake City, Utah. The Mormon Church has actually made a business out of tracing all of your genealogical roots as far back as they can go. Now think about that for a moment from a data modeling perspective. Think about a genealogy, a family tree, with the fact that, obviously you have a biological mother and a father, each of whom has been divorced 3 times, right? And then they, of course, also have siblings, some of whom have been divorced, some of whom were born and died, and so forth. And remember that, particularly if you're from the American South, not only is it okay to marry the same person twice, because, the first time it didn't work, and then, you got divorced, and then one day you ran into each other in the grocery store and you hooked up, and suddenly now you're getting married again. But it's even more fun when she's your sister. How are you going to model this? How are you going to store this data? Seriously, if you really think of yourself as a relational database expert, this is a hell of a challenge. How are you going to store this? Because remember, we have these individuals, and we can have not only a relationship with another individual, but we can have that relationship multiple times. And we can have multiple relationships. It's even more interesting when you try to do this to the royalty of Europe. Because you think marrying your sister is a joke, it wasn't for the royalty of Europe. There it was necessary for various reasons of state. Now, a relational database, despite the fact that it's all about relationships, will fail miserably when trying to do this kind of problem. But you know what does it really, really well? Graph database. Graph database, each individual forms nodes, and then we can have arcs between the nodes where the arcs are in fact their own atomic data element, where we in fact can attach data to those arcs. So if I get married to Charlotte, we can actually attach a starting date and an ending date, and we can actually attach arcs from myself and my wife to our two kids who are grown now. And if all of these just become this huge graph of arcs, you know who's made a business out of a graph database? Facebook. Fundamentally, Facebook is one giant ass graph database. That's all they really are. Everything else is window dressing. And if you've got that disparate team that's got all these wide variety of skills, well, you can already start to figure out where I'm going with this. Let each contribute as they can from each technology according to its abilities to each project according to its needs. So you let the Python guy work on all of the data science type stuff if that's their particular background. Or you let them build a web front end that's talking over HTTP to the Java backend where she's really accustomed to working with relational databases. And then you let the person who's really comfortable with, say, .NET store some of this stuff into, say, Azure Cosmos DB, from each according to their abilities, to each according to its needs. There's a fair number of you who are listening to this who are probably sitting there with their arms folded and their legs crossed and glaring at me. This could never work. This could never work. There's no possible way this could ever work. Bah, humbug. Right? Come on, show of hands if you're one of those. Yeah, nobody wants to admit it. That's fair. No, that's totally fair. Tell that to the Republican Party in the US. Back in Obama's, I believe it was his first election campaign, they took American election campaigns, it's basically all volunteer driven. There are a number of professionals at the highest levels of management within the team, but after that, it's all volunteers. And Obama in particular wanted to try to harness the power of technology and the internet and so forth. And so he said, hey, if you're in IT and you want to volunteer for my campaign, here's where you email. And they got a huge collection of people with zero in common with respect to technology. What they ended up building was a system that processed 4 gigabytes per second, 10,000 requests per second, consisting of 2,000 nodes, 3 data centers, 180 terabytes of data, 8.5 billion requests. The whole thing was built, deployed, and dismantled in a year and a half. And there was no overarching architectural document. They were literally folding things in. If you want to get right down to it, it was a glorious hack from start to finish. And it worked. So, practically speaking, how many people are familiar with Haskell? A couple of hands. Cool. That's about par for the course. This is a Haskell list. I'm going to teach you a little bit of Haskell, just so that you feel like you learned something out of this keynote. It's a pretty straightforward concept. Notice the square brackets, kind of makes it look like a standard array in like C++ or C# or Java, etc. But this is actually a linked list under the hood. Pretty straightforward, yeah? List of 3 elements. And Haskell is a functional programming language, so we don't have objects. We have functions that know how to operate on various data elements. And so, for example, there are several functions in Haskell. By the way, this syntax here, that's their comment syntax. So here, when I take the head of that list, what I'm getting is the first element out of that list, which was the number 1. That makes sense, right? And when I say I want the last, that gives me the last element of the list, which in that case was 3. Now notice that this is different than asking for everything except the head, which is tail. The tail of a list says strip off the head and give me everything else that remains. So in this particular case, when I say tail on numbers, what I get back is a list consisting of 2 and 3. And if I were to ask a tail of that, I would get a list of 3. And if I were to ask of a tail of that, I would get an empty list. Does all make sense? Notice also there is a take function that says I want to take the first two of this list, which in itself will be a list, so I'll get the numbers 1 and 2 in a list out of that original list of 1, 2, 3. So far, pretty straightforward stuff? Yeah? Cool. Now, one of the other things that Haskell allows us to do is to create a range of values without having to specify them all individually. So here, from 1 to 100, so that means 1 to 100 inclusive, so we've got 100 numbers in that list. Notice the double dots there, that indicates the range. And if we want to do something other than just simple sequential, we can indicate a pattern before using the range to indicate the remainder. So here, 2, 4, this is enough to say we want to get just the even numbers up through 100. So far, so good? Now, one of the things we frequently want to do is we want to do operations on this list. This is where we start using what Haskell calls list comprehensions. This is where we take a particular function and we apply it to each element on the list, which will give us some kind of result. Frequently, it'll be another list. So here, basically, I'm saying, give me the values 1 through 10 and put them into X, and in this case, I'm just going to keep that. Here, though, give me the values 1 through 10, put that into X, and then I'm going to ask X to multiply itself. So that's going to give me a list of the squares of 1 through 10. Anybody ever done FizzBuzz? The whole FizzBuzz program, right? You know, let me go through a list of numbers. If the number is divisible by 3, print fizz. If it's divisible by 5, print buzz. If it's divisible by both, print FizzBuzz. Yeah, that's basically one long list comprehension in Haskell. And notice the if-else, this actually returns a value. So here, when I say if x mod 5 is equal to 0, then print out both, else print out buzz. In this case, I'm just doing a variation of FizzBuzz, where if it's divisible by 5, divisible by 3, or divisible by 4. And then, of course, take the values 1 through 25, plug it into X, and run it through this little 3-part if statement over and over and over and over and over again until I get a list out the other end. We can also create an infinite list. An infinite list is one that, as its name implies, never ends. So that forever list up there will, in fact, never terminate. If I try to print the contents of that list, I will be sitting at my laptop for a very, very, very long time. Now think about this for just a second. How do you do an infinite list in Java? Because in Java, we always think about lists as collections. Each of those values exists in memory. And if I try to have an infinite-sized collection in memory, well, we have a problem. Notice we can also do this off of a single element. So here, cycle, love, that means basically that I'm going to infinitely spin on top of the contents of that list, which in this case is one element. So when I try to, however many elements I want to take from that forever love, it will always just continue to give love. Pun intended. That's really bizarre. I mean, what possible use do you have for the concept of an infinite list? One that never terminates. I mean, forget the implications of how do we actually make this work. Obviously, Haskell does some kind of weird magic under the scenes, but what would you use this for? Haskell, by the way, refers to these as streams. They don't call them infinite lists, they call them streams. Several other functional languages have the same concept, and they use the same terminology. But if you think about it, what's at work here is the notion that everything in the collection, everything in the stream, has to be realized, has to exist before we start working with it. Think about this for a moment. if you were going to write a program that were going to print out the lines in a file, and the file was still being written to, would you ever print anything? Well, no, not if we try to do the canonical naive thing in Java or in C#, where we say load all of the lines into a collection, into a list, and then iterate over that list. What we would do is we would approach the problem differently. We would read characters up until we hit a carriage return, and then print that, and then go back and read the next set of characters until we hit a carriage return and print that. And there, we're not really working off the concept of a traditional collection. What we're saying is we are building a thing, an iterator, dare I say, that knows how to go get the next element in the sequence. I don't want to call it a collection because it's not a collection. It's a sequence of values, though, some of which haven't been created yet. And we can do this certainly in Java, for example, using the Java collections syntax. So here, I'm creating something, an iterable, that knows how to produce an iterator that in this case will constantly continue to give me even numbers, and the only termination condition is right here in has next. As a matter of fact, I could have this thing give me even numbers all the way up until we rotate into negative numbers just by always returning true and letting integer overflow just happen. Now, using it in Java, here I'm just creating one of those evens iterator. And again, if this is infinite, we're going to have the same basic problem as the infinite list in Haskell. But the key thing is the iterator understands where to go get the value next. So here I can create a file iterator that will do exactly as I just described. Let me go to the file, get a line, hand it back, and when you ask for the next line, I'll go get that line and hand it back. We don't slurp the entire file into memory. Heavens no, that would be inefficient. But we can still use the iterable concept and the iterator logic to walk through the contents of a file so that from the perspective of the person using this code, it looks like a collection, it feels like a collection. And if, for example, we block waiting for additional lines to be written to this file, so what? We would want to do that if we were waiting for new lines to be written anyway. Start entertaining this notion, and you start getting down some really, really interesting ideas. Now, I can't claim credit for any of this. I didn't invent any of this. All of this was largely done by functional languages long before I discovered them. Again, Haskell has had this concept in place for quite some time. But the people who worked on the Guava library over at Google, they knew about them too. And they captured a lot of these concepts in the iterables and iterators class in the Guava library. Brian Getz is no fool either. He said, hey, I'm standing up here at the top of the Java pyramid as I sit here and think about what we should do with the language and libraries next. And so he led the group that actually created Java Util Stream. If you're a .NET developer, well, this was basically Anders Hallsberg and Eric Meyer before him, and they implemented a lot of this in LINQ, the language integrated query. And other languages have since followed suit in a variety of different ways. But go back to that thought of infinite lists for a second. Is there really an infinite stream? Is there really an infinite sequence? As long as you think about it in purely numeric terms, no. Because, I mean, whether it's a 32, 64, 128, 256-bit platform, eventually you'll run out of numbers. But what if we cast our net a little bit wider? What if we start thinking about things that just haven't happened yet, as a sequence of events? What if we think about time as a sequence? User input. Literally, will the world ever run out of mouse clicks? Will the world ever run out of character events, people typing on a keyboard, or mouse movement? These are all effectively infinite streams. Well, I mean, technically, at some point, somebody will turn off the computer, and at that point, the user input stream will end, but so will your program. These are infinite streams for all intents and purposes. Push notifications from the server are also an infinite stream. Matter of fact, data being fed from the server is an infinite stream. If you work at a space agency, the satellite imagery that comes down from several miles above us, or from the Mars rover, that's all an infinite stream of data. It's a constant sequence of data that's always hitting us. Those are infinite streams. And when you start going down this path, you find yourself basically a half step away from fully understanding the notion of reactive programming. And all of this started with a Haskell list. See, there are all these amazing ideas out there on all these different languages, on all these different platforms, that you don't know are there unless you deliberately go out and cultivate a polytechnical mindset. So how do you do this? Assuming I've convinced you, how do you do this as an individual? Well, one of the things we have to bear in mind is there's a practical reality that you have to be able to have a job. And that the place that you work at may not share some of your polytechnical beliefs. And that's quite all right, because as I said, once you understand some of these concepts, as you saw with the Java iterators, it's possible to pull those ideas over without having to actually embrace said other language. The whole reactive world was built around concepts that the functional guys have been wrestling with for many, many years. And reactive programming is definitely something that you can do in a variety of environments. As a matter of fact, you can build an entire user interface concept around it. And thus do we have React, or more recently Flutter, which is the cross-platform mobile toolkit that Google now offers for doing both iOS and Android. Your goal, in many respects, is to become what the recruiters will often refer to as the T-shaped individual, where you have some depth in a variety of topics, but you also have some breadth across a variety of topics. So in some cases, you may say, you know what, my company, who I don't want to leave, is very, very invested into the Java ecosystem. So I will understand Java and the JVM and so forth. Those are going to be my deep topics. But I'm also going to spend some time learning about other programming languages, some of which may run on top of the JVM, some of which may not. And we may be heavily invested in relational databases, but I will also learn about graph databases and document store databases and so on and so forth. Because those ideas will filter into your code as you go. Your goal is to become this T-shaped individual for some breadth and some depth. Now, the only way you're going to get there, very bluntly, is with your own feet. Your company will not pay you to learn these things. I mean, if you happen to work at one of those companies that does, that's awesome. That is so cool, and more companies should do that. But even then, the company will be making some decisions about what they will train you on that may or may not fit with your particular T-shape. If the company I work at, for example, decides to host a class on introductory functional programming, yeah, that's great for everybody else, but I've actually done a bunch of functional programming, so that class doesn't really help me. I would actually rather take a class, if possible, on constrained logic programming, Prolog and so forth, which they might not even realize they need to offer as a class. So ultimately, it's going to be you who's going to have to do this. Now, congratulations, you've already started because you're here. So you're already, at least at some level, bought into this idea. But the next thing you need to do is, as you embrace each of these new things, you need to figure them out, but without having to spend 6 months to become an expert in this. You need to create your own classification system. What exactly is a graph database, and why should I care? What exactly is Go, and why should I care? What is Rust, and how is Rust different from Go, and why should I care? For me personally, what I will do is I will play around with the technology. My goal is to get, at least in the early stage, when I first see a thing, is try to figure it out so I can sum it up in 2 sentences, like I did a few minutes ago with Flutter. It's a cross-platform mobile development toolkit developed by Google that utilizes functional UI concepts similar to that of React. Now, if you've never looked at Flutter, congratulations, you now have a brief but fairly straightforward idea of how Flutter works, of how Flutter, where it fits in the overall space of things. It's a native implementation, it's not a web-based implementation, et cetera, et cetera. These are things you can get from the Flutter homepage. And then when somebody comes to you and says, hey, we really, really need to build a new mobile app, and we need it to work across both iOS and Android. And we don't really want to take the time to try and write 2 separate code bases, but the whole idea of doing this as a web application running inside of the mobile space, also not. You're thinking in your head, this sounds like this Flutter would be a good case for this. And then at that point, you start diving more deeply into Flutter. Whether or not you bring it up to your boss, your peer, whomever brought this project up, that's up to you. I'm personally okay with saying, you know what, I've heard of this thing, I don't know if it's right, but I'm willing to take a couple of weeks to figure it out. And when I take that couple of weeks to figure it out, I literally want to build a small but non-trivial application. Hello world? Pfft, everybody can do a hello world. They have bots that can do hello world at this point. Build something that has meaning to you, but that isn't just an existing sample. So for example, for Flutter, my family, we like to play cards. We like to play hearts and we like to play spades. And for whatever reason, I'm the one that's always keeping score. So after every round, I have to sit down, grab the pad of paper, ask everybody what they got, total things up, et cetera, et cetera. This is a perfect mobile app. So I'm building a hearts scorer and a spades scorer in Flutter. And I've discovered some things about Flutter. For example, doing UI layout is very, very different in Flutter than it is in any of the other mobile technologies, which I wouldn't have gotten just by reading their website, but by actually trying to do something, trying to build something non-trivial. It's like, oh, wow. This is kind of different. And I know how I'd do it in an MVC traditional toolkit, but this is not what Flutter does. So how do I do this in Flutter? I'm building my own ontology. I'm building my own categorization scheme for where Flutter fits in the giant picture. The other thing I will advocate to you is, if you are a traditionally classical object-oriented developer, don't study another traditionally object-oriented language. If you're a Java dev, don't learn C#. I mean, there's some interesting things that Microsoft is doing with C#, but most of them are things that are at least being discussed in the Java world anyway. That's boring. That's just boring. Go learn Scala. Go learn Clojure. Go learn Yeti. This is actually a programming language that is very heavily inspired by ML, the programming language ML, the functional language ML, not machine learning. Or if you really, really, really have it just, I've got to do something that lets me put AI and machine learning on my resume, go Google probabilistic programming languages. Programming languages that intrinsically take probability into account, generally used for simulation and so forth. Go do something completely different. It will feel good to go learn a new language that is exactly like the one you're already using. But feeling good is only going to last for a little while. You're not going to get any huge revelations. The goal here is to broaden your scope, to widen your vision, to go visit places you've never been, like Waffle House. Now, generally speaking, what I will suggest to people is create your own evaluation function. What I mean by that is, let's assume that I want to study this particular language. What can I build with it? Well, if I'm currently not feeling at all inspired, like the Hearts and Spades score, my fallback will be a gaming convention registration website. Because for a couple of years, I was involved in the technology around a gaming convention in Seattle called Dragonflight. And this was an actual problem we had to solve. And in some respects, it's a straight-up CRUD problem. I need to take submissions in, store it to a database. If you want to host a game, we need to figure out the game title, the description, who you are, how many people it can play, etc. We need to display all of those. It sounds very much like a traditional CRUD app. So it's not too far from a traditional CRUD app. That's a good thing. But it has some interesting quirks to it. Like certain games are longer than others, and so when we schedule, this is actually something of a constrained logic problem. And so if the language is particularly built well for constrained logic, then great, this lets me have that flexibility. Or if I want to see somehow about trying to connect the various attendees with the people who are hosting games and so forth, that's actually more of a graph-oriented problem. Does not matter what I think, it's a problem. The evaluation function is a problem of your creation, so that you are the domain expert, so that you don't have to ask anybody any questions. You can just start working on this. And truthfully, you may get a couple of days into learning Prolog and go, this is not at all what I thought this was. And that's okay. Put it down, walk away, go learn something else. There's no shame in turning away from learning something if it doesn't start exciting you or if it doesn't start giving you answers. But what if you're the boss? What if you're the manager in charge of this team and you want your team to become more polytechnical? Because in many respects, that's what we as managers should be doing. We should be encouraging our people to grow. Well, for starters, go find people who are polytechnical within your company and encourage them. Just because you're using Java doesn't mean that everything you do should be Java-centric. Find somebody who's got some experience with Haskell and say, hey, would you mind giving us a brown bag? This is a term we use in the US to refer to a bring your lunch and somebody will stand up during the lunch hour and talk about a particular topic. Company I worked at prior to this, we did a brown bag every Thursday. Every Thursday, somebody had a new topic that they were discussing. Now, technically, we wanted to encourage people to go to these, so we didn't require you to bring your lunch. We bought pizza. And we got pretty good turnout. And a lot of people learned a lot of new, interesting ideas through those. But the other thing is, establish a culture of dissent. One of the things that companies really stress is we've got to make sure everybody agrees before we move forward. That's bullshit. Everybody doesn't have to agree. Everybody has to simply do what has been decided. Quite honestly, I've had people that I've worked for in the past make decisions that I thought were entirely wrong, but once the decision was made, professional ethics said, okay, now I will support that decision to the best of my ability. Because one of the things about dissent is it will call out any flaws in the conversation. Currently, I am a director at Quicken Loans. And if I get my team and a variety of teams into a room and I say, hey, this is a plan, everybody in the room will go, okay, this is the plan. Great plan, boss, great plan. Because inside they're thinking, I'm not sure about that, but he's the boss. I don't want to say anything. There's a power imbalance. There's a dynamic there when you're the boss and everybody else is not. So one of the things that I will do is I will put up a plan and I will say, tell me what's wrong with this plan. Tell me all the things I'm not thinking about. Tell me all the things that I've forgotten. Tell me the places where it's not going to work. Dissent. Tell me out loud in front of the room why this might not work. Because I would rather find that out now than 6 to 9 months from now when it blows up gloriously on the launch pad. Build a culture of dissent for your team. In some cases, set some non-business goals that are technology focused. For the engineering team I built, these were a bunch of first, second year engineering folks. In other words, these were new developers, brand new to the industry. In some cases, we hired them directly out of a code camp. Many of them needed to level up their technical skills, and we knew it. My boss, who was the senior vice president at the time, we both knew it, that if we hired these people, if we were looking for juniors, we were going to have to level them up ourselves. So we literally started a book club. Everybody on my team, I bought them copies of a book on JavaScript, modern JavaScript, and we literally, every Wednesday, I think it was, every week, we went out, we went to wherever they wanted to go. They all selected for a pizza place because programmers and pizza, it's this wild addiction. And we sat there for an hour and a half in this pizza parlor, going over chapter by chapter every topic in this book. Make learning a formal part of the company's business. Set technical goals. By the end of next month, we will all have finished Venkat Subramaniam's JavaScript book. And by the end of the month after that, everybody will have completed 6 JavaScript puzzles on one of your favorite coding websites. And at the end of the month after that, we will start learning something different. But the other thing that you need to do as the boss is you need to figure out what your company does. What is your company's core business? What are the things that you actually sell? If this went away tomorrow, your company would start to go bankrupt. And understand that sometimes for these bigger companies, there isn't just one core business. But for example, if you're at Amazon, your core business used to be the big e-commerce website. Now, their core business is AWS. Their core business is technology. You could argue that Amazon's core business is actually logistics. Amazon knows how to put a package on your doorstep within 24 hours, 48 hours at the most. That's actually what they have built the strength of their company on. But if you were watching Amazon's recent announcements regarding Alexa in everything, they're putting them in earbuds, they're putting it in microphones, they're putting it in every possible electronic device you can imagine, it's pretty clear that Bezos wants to take over the world. I mean, he wants to enable technology for everybody out there. Their core business is changing. And if you work for them, then you want to understand how that change is happening so that you can adjust your team to change with it. The last thing you really need to do if you're running that team is you need to accept and embrace the idea that these are people, these are not cogs. One of the first things that I do when I start hiring for a team is I start looking at the current team and I start asking myself, what's the biggest weakness? So the team that I'm building at Quicken Loans, right now it consists of me. What's my biggest weakness? I don't know mortgage. I don't know mortgage. I've only been with the company for a month. I don't really know the company well, but the biggest problem is I don't know mortgage. So the first 2 people, ideally, that I use to staff up this team will be internal transfers, people coming from other parts of the company that do understand what we do and how we do it. And as a matter of fact, one of the guys, basically once the paperwork goes through, he will start working for me. Now, what's my next biggest weakness? Well, the company is large enough that we actually are fairly insulated. We are pretty inward looking. The company as a whole doesn't do a great job looking to the outside, looking at technologies and so forth that are coming from the outside. So how do I fight that within my team? I make sure to hire people who are broad thinkers, who are polytechnical from the outside. Data is a very, very big concern for what we do. So I really want to have somebody on my team who's really strong with understanding data, data access, data relationships, all of that stuff. Somebody who's spent a fair amount of time. In this case, this is a .NET shop. So somebody who spent a fair amount of time with SQL Server. And actually, he'll start on Monday. You need to build your team based on individualism, letting each individual bring their disparate skills to bear, rather than saying, I want people who are 5 years Java, 7 years Oracle, 3 years Angular. Yeah, you're just going to get a bunch of people that look exactly the same. And it may be great in the beginning, but over time, there's a whole bunch of breadth that you're missing because you didn't hire a diverse team to begin with. This is not easy. I'm not going to stand here and tell you that, you could do this in your sleep. This is hard, both as an individual and as a manager. But it's worth it. Because in the end, you will see things that others do not see. You will know things that others do not know. And that will make you infinitely more valuable than the people who are classic Java full stack developers. Enjoy the rest of the conference. Peace out. Oh, you can set him up first. Get him wired up first.
Hi everyone. Before we start off, I will just remind you once again that a small solistic concert done by our speaker Nemanja will begin at 11 a.m. upstairs by the Heapspace booth. It is to support the cause of children who fight against cancer. So there are 2 donation boxes. We'd like you to join and help out as much as you can. Nemanja will also match your donations until he goes bankrupt. Okay, we have Kaz Sato here with us. He is from Google Cloud. He's a developer advocate. Kaz, what is a developer advocate exactly?
It's like an evangelist for developers. Evangelist. So we advocate for the developer community.
Beautiful. Okay, so we will hear more about deep learning and its real life application, real business applications, that is.
Yeah.
So take it away. Thank you very much.
Thank you. Thank you for taking your time for my session, Real World Machine Learning with TensorFlow and Cloud ML. And this is my introduction. So I'm developer advocate. So as I mentioned, it's like an evangelist for developers. I usually attending many meetups and events like this one, talking about the products and technologies from Google, focusing on the machine learning technologies from Google Cloud Platform, GCP. I have been working at Google Tokyo office for over 8 years and working as a developer advocate for like 4 or 5 years. So before get into the details of the technologies, I usually start with the what's the meaning of the AI or ML or the neural network. How many people actually using machine learning already? Not so many, like less than 5 people. Thank you. Yeah, this is the maybe the great introduction for you who haven't tried machine learning yet and wondering what's the AI and what does it for you. So I usually say that the AI stands for the artificial intelligence, but AI doesn't have any intelligence for you. Because usually if you hear the word intelligence, you may expect something like the common sense or self-consciousness running in the human brain. But current AI technologies haven't achieved that level of technology yet. It's not an intelligence. It's actually a function that converts one data into another, that's all. But we are trying to make this smarter IT system. So until now, the IT development has been all controlled and managed by the human brains. The human defines the specifications and human writes all the logics. But now we are seeing totally a new programming paradigm that let computer decide what's the rules, what's the patterns to process the data. And we are using machine learning to do that. Machine learning has been out there for like 30 or 40 years already, but recently we are seeing the booming or the breakthrough of the machine learning, especially in the area of the neural network. As you might heard about deep learning, that means the deep neural networks. The neural network has here more than 3 layers as the hidden layers. So at around 2012, we are seeing a breakthrough of the deep learning or deep neural networks happen in the area of machine learning. And that could be used for the building your so-called artificial intelligence or AI applications. But I always say AI is just the subset of the all applicable applications for the machine learning. So even for the traditional web developers or any programmers could use the machine learning for their everyday programming, where you are not building any AI applications, but machine learning is still a very powerful new programming paradigm for you. Why is that? Let me use some example. In this case, the developer is trying to define rules or business logic for detect the activities of the user. The user may be carrying some smartphone applications so that you can detect the movement speed of that user. So you can define the specification like if that person's movement speed is less than 4 kilometers per hour, maybe he or she is walking. If it's more than that, maybe the user is running. If it's over 12 kilometers per hour, maybe the user must be biking. But if you have the new user who is doing this, how your program code will respond? your program code doesn't expect this kind of the activities because it's not defined in the specifications or requirement. So in this case, your system doesn't work and not flexible enough to adopt the new data pattern you're finding in the new user. Instead, at Google, we are changing the way of the programming or defining the business logic. Rather than having humans define all the specs, we're letting computers to find what's the best possible rules or patterns or definitions or specifications based on these patterns we can find from the training data. So rather than starting with the writing our own program code, we are gathering tons of data, the big data, like all the positions data from GPS or the data from the motion sensors or any possible data, and let the computer find what's the different patterns you can see in walking, running, biking, and golfing. So this is not about the artificial intelligence. This is more about the paradigm shift of your way of programming. This is another example. Usually, if you want to make a converter that converts from the Fahrenheit degree to the Celsius, from the Celsius degree to Fahrenheit degree, usually you have to define this kind of the specification and write it down with the Java or the Python or Go language. But with machine learning, you don't have to do that. You don't have to define the exact specifications. Instead, you can just dump all the training data to the machine learning algorithms so that computers works for you, just like in the calculator in your office environment. So you can say that machine learning is a new calculator for the web programmers or any programmers in 21st century. So with the machine learning, you can also do things like this. These are all the different images of the mops. But if you're carefully looking at that, this is not a mop. Actually, this is a dog called sheepdog. And this one, this is hard one, but actually, this is a dog. Even humans cannot tell the difference between the dogs and mops in these examples. And it's impossible to define a specification of your IT systems. That tells the difference. What are the rules to classify these images? But deep learning can do. Actually, by using the Cloud Vision API provided by Google Cloud, you can easily tell the difference at high accuracy, but not 100% accuracy. Just like humans, the AI does make mistakes. So you have to think about, well, this machine learning model could make a mistakes like a few times for 1,000 images, but this can definitely increase the productivity of the workers if you apply these technologies to a certain the use cases, things like that. So you always have to think about the trade-offs of the productivity or business benefit you could get with the machine learning versus the error rate or the accuracy you would get from the actual production system. How the machine learning works, especially the neural network. As I mentioned, there's no intelligence inside it. It's not a magic. It's just a function. But it's the function that can learn from the training data you put. So with the tens of thousands of images of cats and dogs, somehow the functions can extract the patterns from the pixel images to output some vectors with the labels such as dog or cat or human, so that you can use the function to predict to classify whether the image is a cat or dog. And inside it, it's actually doing a very simple mathematics. Actually, it's just a bunch of multiplication and summations, and that's it. This neural network algorithm is invented in the 1940s, and that is inspired by the behavior of biological human neurons. We have like I don't know how many is it? It's like 20 billion neurons inside the human brain. I don't know. Anyway, it's just a cell that takes the electric signals from the other cells, and we have massive neural networks inside between those neurons. And the original idea is trying to simulate the behavior of the neurons by multiplying the weights, the so-called parameters, with the input data, and take a summation. And if the summation overs a certain threshold, then that cells, that neurons could be excited. Just like humans do. You know, all humans have many neurons to make a decision. For example, if you're watching some light fire, and if you're smelling any the smokes, and if you're hearing some noises that fire makes, you can make a decision that, oh, it's fire, your house is on the fire. This is just like that. So the neural networks can make decisions based on the input data that is filtered by those different weights. So some data would be ignored, and some data would be used for making a decision. So for example, by using the neural network in the machine learning, it can easily be trained to classify these data points as blue points, or in a blue group or the orange group. It's a so-called double spiral data pattern. So let's take a look at the video. So this is the neural networks. It has 1, 2, 3, 4 layers. This is the final neuron. And now it starts training by taking all the existing training data. This was blue, this was orange, this was blue, and things like that. So by keep training the neural networks, it tries to find the best combination of those different weights to extract the patterns that can classify new data points could be in a blue or orange pattern. So as you can see, it is trying to achieve the same accuracy as humans provide. And actually, each cells, the neuron, is doing very simple things. This particular neuron just draw a straight line here and classify whether a new dot is in the upper layer or lower. This neuron is dedicated to classify whether a new data point is in a left or right. So each neuron does a very simple things. But just like the humans' neurons, if you have millions or billions of neurons in a single neural network, then it can provide very complex, sophisticated information processing inside it. And you can apply the neural network algorithms to any kind of the data you have. For example, image is the most famous use cases. You can take the pixel images and convert them into a matrix like this, from 0 to 1.0, they're all represented in the real numbers. And let the neural network, what are the important pixels you have to watch for to classify those images as the digit 1 or digit 8 or digit 4. Obviously, there's the irrelevant pixels. For example, the images right here, those can be ignored. So the weights for those pixels could be something like somewhere around 0. So instead, by training the neural networks, you can let the neural networks understand what could be the important features out of those data. So that you can train the neural networks to get the high accuracy on the handwritten image recognition. This is another animation that tells you how the neural networks works for the image recognition. So you can actually understand that without any mathematical formula, actually. As this animation tells, it's just a matching between the parameters, sets of parameters, or you can call it as a filter for pixels, making a matchmaking between the filters and input data. And if you get the best set of parameters that fits with the input data, then that must be the result. That must be the prediction result for this image recognition. So it's very simple mechanics working inside the machine learning. But if you have like tens of the layers inside it, very interesting thing it can be happening inside it. For example, this is a so-called Inception version 3 that is developed by Google for the image recognition system. And that is trained to recognize the edges and patterns of the objects or colors in a picture for the lower layers. In the middle layers, those neurons are trained to recognize the animal eyes or animal nose. And if you go to the higher layers, it got much smarter and smarter. some neurons can recognize there's a dog snout here or cat leg here. And eventually, you would have neurons that as smart as humans. So it can recognize Labrador retriever is here or tiger cat is here. But everything is just a conversion or a transformation of the information, not intelligence, actually. It's just a function, one big function that converts the pixel images to the labels. This is another video that tells how the deep learning models is recognizing the world. So by clicking one of those, the bunch of the neurons, you can visualize why this particular neurons is excited by watching a part of those the input data. For example, this neuron is looking at those the hairy, curly hairs, and these neurons decide that it's the head of the Labrador retriever because it has the curly hair and this shaped as the dog's the head. So that's how it works. It's just trying to extract the certain different features from the input data. So we have been using these technologies for implementing our different services, including those smart devices, or the Google search have introduced the deep learning-based algorithms for the ranking of the search result since 2015, and almost all Google services has been using deep learning for productions, including Google Photos, or Gmail has now the smart reply features. So there will be 3 options to reply each email thread. That is working with the neural networks as for the natural language processing. And also smart compose feature lets you suggest you the sentence that you would write in the email with that person or that the thread. And Google Translate, as you know, has increased its accuracy by using the neural machine translation. And now we are trying to share this power of the machine learning with developers with the Google Cloud Platform. So we have provided the many different APIs or services or solutions that powered with the Google's AI technologies already. And for example, Google's AI building blocks, those are all the APIs that pre-made for the visual recognition or voice recognition or translation and so on. So for using those building blocks or APIs, you don't have to learn anything about machine learning at all. So if your problems or business requirements could be solved with those APIs, then you can just go there and use it. That's the easiest way. For example, if you have any images you want to recognize, you can just go to the product page of the Cloud API, Cloud Vision API, where anybody can try out the Vision API without any sign up or paying any money or credit card registration. You can just upload the image of the sheepdog, then you get the labels such as dog or mammal. Or there are some other interesting APIs that allows you to try out the speech recognitions on the fly. You can choose any language you want and speak to your laptop so that it should return the recognized result within like a 0.5 second. It's real-time recognition using the Android devices and so on. And if you got the converted text, you can copy and paste it to another API called Natural Language API that allows you to deep dive into the meanings of those natural languages and sentences. Press the Analyze button, so you would get the entity analysis results that shows any name of the entities like locations or companies or human, or the sentiment analysis just that shows the sentiment scores, or the syntactic analysis to get the part of speech in a sentence and the relationship between those words. But these are all the APIs and pre-built machine learning model. So not all the problems could be solved with those pre-made things. But before we having the new product called Cloud AutoML, there was a huge gap between those APIs and building your own machine learning from scratch. Because to build customized machine learning model, you have to hire some data scientists, ML engineers who understands all the mathematical formulas, equations, and build an IT systems with another group with the DevOps people. We call it as a ML Ops, the DevOps for ML. For understanding machine learning, still can build the best platform, scalable platform, the machine learning models and the inferences. It takes tens of thousands of dollars or millions of dollars instantly. So we wanted to fill that gap and wanted to automate a major part of the machine learning development process. That is the Cloud AutoML project. So in the past, you have to go through all the different phases of the machine learning development. Like you have to collect all the training data. With that training data, we can do anything with machine learning. So training data collection and pre-processing. You have to design how many layers, or maybe you should use anything other than the neural network. Maybe you could use the random forest or the GBDT or any other the algorithms could fit to the solution. Anyway, you have to define the model design, and you have to do the hyperparameter tuning. This is one of the hardest part. And also, you have to evaluate the model performance continuously. You have to deploy on your the scalable machine learning DevOps environment, and keep updating the model by continuous training. So this is expensive process. So we wanted to automate everything. All you have to do with the Cloud AutoML is to upload all the training data with labels uploaded to the Google Cloud Storage and press the training button and wait for 12 hours or 24 hours. Let me show you some example video to show how the automated vision can work for you. So it provides the training and deployment, and also it provides the API, scalable API for the prediction for using your trained machine learning model. And all you have to do is collect all the data. For example, if it's just tens of thousands of images, you can package them as a zip file and upload it on the UI of automated vision. Or if you have many of them, you can upload to the Google Cloud Storage and check out those images on the UI with those thumbnails. Then you can go to the Train tab and press the Train button. And in this case, it has selected the Edge model. That means the model can be downloaded to your smartphones applications or the embedded systems like a Raspberry Pi. And after the training, you would get the report that says the accuracy or performance of your model. For example, suit pictures should get the 97% accuracy. And then you can download the model for the edge devices. You can export the data, the .tf-lite file, to the Google Cloud Storage and download it. And all you have to do is to build the edge device that runs that model at the edge side. So for build the Raspberry Pi, you could use the Raspberry Pi 3 or Raspberry Pi 4. And the important thing is to use these USB things that is called HTPU accelerator. This is an AI process Google has developed. So by putting those HTPUs, it can accelerate the performance of the inference for like 20 to 40 times faster than the usual Raspberry Pi CPU. And then go to the HTTP website and downloading the SDK. That should be finished within like 15 minutes. And the API is very simple. With Python, you can load all the library and load the model file and pass the images, and that's it. So you would get the prediction result within a very short time period. So these are the labels. That means Paul shirt at 84% score. So in this case, I have built my own self-checkout systems for the dry cleaners. I have used about 50,000 images of different clothes and wares. And actually, it took a couple of days, like 2 or 3 days. Actually, I have spent many days for building this UI with the old Python API. So it's so easy to build your own customized model by using the AutoML. And some the hackers were playing with the AutoML vision for a while. This is a ramen bowls you can see. And actually, this is a ramen bowl from the shop called Ramen Jiro. It's one of the most popular ramen franchise in Tokyo. They have 41 different branches in Tokyo area. And actually, these pictures are coming from the different branches. And the automated vision model can tell the difference of these ramen bowls by looking at those vegetables, toppings, or the way they cut the meats. At 95% accuracy, there are 45 different branches. By looking at those bowls, you can see that the shape of the bowl or the color of the table are the same because they are in the same franchise. So only the features the deep learning model is the toppings and meats. But still, the automated vision can get the 95 accuracy for whether this particular bowl is made at this particular shop or things like that. This is impossible by humans already. And Mercari is the most popular setting up in Japan. They are just like the eBay in Japan. They are trying out the automated vision for the brand suggestion for the sellers. So if the sellers upload any product images, it can show, oh, it must be a Gucci bag, or it must be the Chanel bag, or something like that. Another latest products we provided with the AutoML is the automated tables that works for the structured data, tables in the databases. And again, you have to, in the past, you have to go through all the different processes with data scientists. Exporting the data from the database table and build your own model, and that takes a long time. But we have automated that. For example, this is another, this is an Kaggle competition, the problem where they let the human data scientists to build a model for predicting the selling price for the Mercari, Mercari setting app. Based on the features such as the name of the product or item conditions or item descriptions with natural language processing. And what the performance of those AutoML tables versus human data scientists. These are all the scores or error rates from all the over 1,500 the teams who have participated in this particular competition. And this is the top #1 winner of the competition. So this is the lowest error rate they got. And AutoML tables couldn't get the highest result for this competition. But it wasn't so bad. By spending 12 hours for the training with the training data, they were able to get like the score that is in the top 500 teams. So it's just like a senior data scientist you have hired just by clicking the training button. And this costed only like $300. So by spending $300, you can hire the senior data scientist. Yeah, there's any other things, more things you have to solve with the human data scientist, but particularly the building the model, training the model, those kind of things could be replaced with the AutoML for major part. GNP Seguros is one of the most traditional major insurance company in South America. They have tried out AutoML with their existing database system. They wanted to decrease the payment for the healthcare fraudulent. And they have been using their own existing algorithms to detect whether on some not invoice, it's a payment request from those patients could be a fraud or not. And by trying out the AutoML tables, they were able to get the 20% to 30% the effectivity improvement compared with the older algorithms. And this is really a huge impact for the business because they are paying like over $680 million per year for the insurance payment. So even the 1%, the improvement could be significant, the benefit you could get. So those AutoML technologies has been developed for the new machine learning users, people who haven't machine learning the expertise but want to get the power of the machine learning. TensorFlow, maybe I suppose many of you have heard of the name. It's a design for the machine learning, the specialist, the data scientist that has open sourced in 2015. It's developed by the Google AI team for developing our internal the AI products, and also used by the many different enterprise customers. And the latest news about the TensorFlow is the TensorFlow Lite, which is the the subset, small version of TensorFlow that is the optimized for the smartphone applications or embedded systems. For example, recently we have supported the GPUs in the smartphones with the TensorFlow Lite. So rather than using the CPUs in smartphones, it gets much faster by using the GPUs. You can get 5.5 times faster performance. Actually, it's 15 milliseconds for the classifying an image with the mobile net model. And recently, we have announced the much faster options, that is for the DSP, or digital signal processor. Digital signal processor is a kind of traditional circuitry you have in the every smartphones. And Qualcomm's DSP is in the Pixel phones and the any phones with the Qualcomm Snapdragon chipset. And that has been used for the audio signal processing or vision processing traditionally. And by using the DSP, you can even get the better performance than the GPU. It provides the 13.8 times faster inference speed. So let me show some example of this kind of the TensorFlow Lite acceleration. This is a sample application called Dance-like, where the application shows the dancers playing, and it's a very simple game. The player will be dancing the same dance as the professional dancer. It's a very simple game, but the technology inside it is very sophisticated and advanced because it does the real-time segmentations on the body images. As you can see, there's different colors on the head and body and arms. It is so-called segmentation, and one of the latest the technology you got with the deep learning research. And usually researchers are using the huge desktop GPU machines to do this kind of segmentations. But now you can use the GPU inside the smartphones to do that in real time. And another application is the smart mirror for the cosmetic the products. This is not an application. This is a physical mirrors product. And mirror has a Linux called Care OS inside it, with the TensorFlow Lite model running inside it. So the model can recognize the human face and the direction and all the landmark points. And also it does the segmentation as well. So you can easily change the color of your hair in real time by looking at the smart mirror. And these are the use cases of the GPUs inside smartphones or the Raspberry Pi or Linux, embedded Linux. And another interesting technology is HGPU. As I mentioned, this is an AI processor built by the Google. With HGPU, you can get 42 times faster classification speed compared with the usual GPU. So that this could be applied for the real-time use cases where people really wanted to identify some object in the images in real time, 40 frames per second, like pedestrians and cars or signals. Those could be identified within like 5 milliseconds or 10 milliseconds. It's real time. Okay, lastly, let's look at the interesting use cases of the machine learning APIs, TensorFlow, and the AutoMLs. QP is one of the major food manufacturers in Japan. They have been using the TensorFlow in productions for finding the bad potato cubes on the belt conveyors. They have launched the production systems for over 1 year. So those baby foods with the potato cubes with their factories are all checked by the deep learning models with the TensorFlow. And also 20th Century Fox, they have been using the deep learning TensorFlow model for the marketing research. They have many movie trailers for different new movies, and they are extracting the different features from the trailers by using the image models, recognition models for the video. So the result is that you can get the high accuracy on predicting what set of movies could be seen by a certain kind of the users. I think these green ones are the actually matched result. And the left list is the actual movies seen by our user. And the right one is the predicted list of the movies. So they are using this kind of the predictions for the marketing analysis. Nissan is the largest mail order service in Japan. They have been using the ordinary the collaborative filtering recommendation for their website, but they have changed to deep learning model to recommendations. That actually takes the visual features, colors or styles or shapes of the actual the clothing and wares, and also the language features from the product description. So the model understands what the products looks like and how the products should be used in different use cases or the situations. Whether it's a formal wear that could be fitted, suitable for the ceremonies or the wedding and so on, or some items could be used by the women's or men's, rather than taking a look at the purchase history in the past. This is a project for Global Fishing Watch that is tracking the GPS positioning of all the vessels or ships in different oceans. They are gathering 200,000 the GPS positions of the different ships in real time and collecting them, uploading them onto the Google Cloud storage, and using TensorFlow to extract certain movement patterns. And by watching the movement patterns, they can tell whether it is doing some fishing or not, troll fishing or long line fishing or pulse seine fishing, so that you can prevent the overfishing in certain area of each ocean. Lastly, I'd like to show a video of the use case of the TensorFlow by the dry cleaning shop owner. This man in Japan, he is the owner of like 3 or 4 small dry cleaning shops in a very small town in Japan. And he had no experience on programming at all. But because his town is so small, all the people he can hire for his store is senior people or people who doesn't know much about the ITs. So he started learning the Python programming from scratch 5 or 6 years ago, and to automate everything for the senior people operators. And then he also started learning about TensorFlow from scratch and spent like 2 or 3 years and collected over 50,000 images of those different clothes and wares. Actually, the demonstrations I have shown for the AutoML visions, that was using the training data provided by him. But that was before we got the AutoML tape or AutoML vision, so he learned the TensorFlow. He used TensorFlow by himself and got no help from the systems integrator or vendor at all. So it costed so low. He only spent like hundreds of dollars. So the point here is that any single developers or even hobbyists or individuals can get started with the TensorFlow open source based free technologies for learning the machine learning or AI. And maybe you can pay a small amount of money for the Google Cloud technologies, for you can expedite or shorten the time for the development. But anyway, the Google really wanted to empower the developers with the paradigm shift of the programming with machine learning. So that's it. Thank you so much.
not yet in English. She will have, we will do a presentation talk about Kanban and Scrum in Warsaw. And this is a conference dedicated for kids. And I had a talk with the guy who is organizing everything, and he told us, Sebastian, maybe you can take care and maybe you can talk about something. So we had a chat. We are ready. Half of the slides ready. Yeah. And we will see. And yeah, next time maybe.
Ja, i zamku je. Ja ne mogu da reći.
To je ne Heapcon.
Da. Stavila sam minut da ima.
All right. So, have you guys seen the concert upstairs? Has it started already? Okay. Sebastian is here, Sebastian Malaka. He will talk about event-driven architecture. He has an awesome audience today. Where are they now? Where did they go? Where is Isabel? She was just here on the stage.
She's on the very end.
Okay, yeah, she's chasing all around. So if you see a small
She
child,
already heard that few times.
yeah, okay. she got bored. So if you see a small child running around, that's his daughter learning to be the next speaker at Heapcon. So Sebastian, take it away. Thank you very much.
Okay. Hi everyone. Hope you enjoy Heapcon. I just came here, so after the talk I have to walk around and see how everything goes. As I said, today I will tell you about event-driven architecture, about events. Why is that? This is somehow related with my passion. I'm a person who really loves the quality of the software, but not only the quality in the understanding of the code. Of course, it's also important, but I'm talking about quality at all. So starting from user through the BAs, project managers, till the developers and testers. If all those people are happy, that's what I'm calling quality. That means that our written application by us has a high quality. Code is one of the items in it. And why events? Because events helps me with keeping this quality. Why is that? Developers start using events, but they were there before even we thought about them. In business, they were using business events, business flows. They all rely on events. And after some time, developers decide to use this approach because we mostly cooperate with business. We mostly try to fulfill their requirements. And then we grab those events. They were always talking about those processes, flows, and so on, the activities where money are, and we put that into the code. That's the first thing that I like in events, because in the code, I've got a business, I've got the understanding, I've got the knowledge. Everything that my customers are talking about, I can look at my code and it's there. There is a flow, there are the names, there are all the things that really happens. Second thing, if you are building event-driven architecture, then most of your activities are triggered by events. What does it mean? The items are extremely tiny and not coupled with other functionalities. They are oriented on one thing. You really fast can find out what is triggering particular action and what is the result on this action. This is small, so it's extremely easy to refactor, even if the code is shitty. It's extremely easy to do. And also you can find what is triggering this action, what is the output of the, what is the end of this behavior. You can going through the events, you can build the flow, build the business, understand the business your customer are talking about. Even before you will start to talk with them. Code is enough. That's why look at the events, and I started to use them. Except that, I'm blogger, speaker, I'm trainer and consultant, I'm software developer, tech lead, architect. I'm helping people to, whenever there is no quality in the code, I'm happy to help. Okay, before we will go to the event-driven architecture, unfortunately there will be no code, because to understand the code you need to know the theory and the library itself. But seems just theory is, from my experience, it's not enough. So I will use some domain, hopefully you are more or less aware of. So we will talk about some continuous integration tool. So there are a few concepts, pull request or merge. So whenever we are creating a new pull request, whenever we are merging the code to existing pull request, this is our entry event. This is something that triggers our action. This is from where our talks, our conversation will start. Okay, few definition you need to know. So build is any executed job that completes eventually, and the result of it is either success. So we got it here, green. Oh. Okay, it doesn't work. So it's either green or failure, red. Builds can be various, so static analysis, unit test, system test, integration test, and so on and so on. Except that we've got a pipeline. What the pipeline is? Pipeline is the set of builds of the various categories. So you can understand it as build that runs static analysis, then build that runs unit test, integration test, and system test. This is our pipeline. Also, I will use the shortcut builds. What builds means, this is a set of execution of one particular build and the result of it. So that's mean for each pull request, I've got static analysis that was green. Then after another merge into this pull request, I've got static analysis that becomes red. And after another commit, I'm seeing I didn't fix it, so it's still the red. Builds are one category of the builds with a history of the statuses. Okay. One feature that I will talk about a bit, I will only refer to, is performance analysis, and we will look at the situation when build is not completed. Thanks to this short, tiny domain, hopefully I will be able to explain you how events works. Also, there will be some events related to notifications. What will happen when build is failing, performance degrading, and we have a dashboard. What dashboard is? This is the functionality that will show us the status of the particular pipeline, whether it's fine or not. Okay. What event processing is? In the essence, there are three things that happens in event processing. This is consumption of the event. So I'm consuming all the events that triggering my functionality. Another thing is operating over the event. So whenever I have to send a notification, this operate is building an email, for example. What is triggering sending a notification? I would like to let know developer who create the pull request each time when his builds are red. So my trigger is build failed. Okay, I'm consuming this event, and based on that, I'm creating this email. I'm sending this email to the author of the code. Also, to consume something, there have to be some other component that will publish this event. From time to time, consumer is publisher as well. So whenever I'm consuming an event, I will also publish something. It's not always the case, because on the very end, we will have a consumer that will be end of the flow. But in many cases, this is the situation. Also, in application, we may have this initial publisher that is triggered by something and then publishing an event. What event-driven architecture is? So events, we need a couple of things to talk about event-driven architecture. First are events. Events is everything that happened. This is already made decision, already saw activity, already noticed thing. This is an event. Event happened. I cannot modify the event. I cannot change the event. This is a past. And events are in IT, and not only in IT, in business also, are somehow visualized. Those are, and the name of visualizing the event is event object. Why we've got the separation between events and event object? Because we are not interested in each and every event. So whenever this is the event I don't want to react on, maybe I won't create an event object. What is event object? This is visualization of it. It can be JSON, it can be XML, it can be an object, whatever that holds data. We've got two different types of events, system and business. Business are the one that we are mostly interested in. So those are the one we are talking with business about. This is the business flows and so on. Business events are those events that exist even without our application. Business already had them. We are just helping to faster react over them and maybe do some kind of analysis, recognition, and so on and so on. But once developers start to use business events, there are also system events. What does it mean? Some exception happened, something that didn't exist without our application. So it's strictly related to the implementation itself. Event-driven, this is a way of triggering some component. We've got a couple of popular triggers. So this is a request. I'm the user, I'm sending the request, and functionality is triggered by my request. Another, clock, timer, so something like cron job. And also we've got event-driven, event-triggered functionality, like the notification I mentioned before. And what is event-driven architecture? This is an application that mostly rely on components that are triggered by events. So it's not like everything is triggered by events, because there is this UI that users are talking with. There are some cron jobs eventually, and there are various services not triggered by events, but if all the most important business activities are covered within event-driven components, then we are talking about event-driven architecture. Okay, there are a couple of principles of event-driven architecture. The most important, so this is the list. As an essence, is like event is not aware of what will pick this event. Event is only aware of situation that happened. So I'm publishing an event. Organizers of Heapcon have an idea to organize a Heapcon. Yeah. So they create call for papers. So we've got an event, call for papers created. Did they know that Sebastian will send his speech to them? No, they weren't. To be honest, they are not interested in particular people, particular consumers of this event. They will just publish the event. So call for papers was created. That also means that event doesn't give you information about what will gonna happen with it. Referring to this call for paper is created. There are couples of activities. So maybe some volunteers starts to publish some posts on Twitter, Facebook. This is an activity that was triggered by this call for papers created event. Speakers will send their talks, and so on and so on. So there are various activities that will be triggered by this event, but trigger doesn't tell you what will gonna happen. It's not like call for papers created and speakers will gonna give us some share with us their talks. Another thing. We are always reporting current events, something that already happened. We are talking about activity. And if you are publishing the event that already happens, we are also reacting over them right now. Sometimes there are windows. So I'm waiting for 10 occurrences of this event. This is not like delaying a reaction over the event. No, I'm simply interested in a couple of those events, or some calculation, averages, and so on and so on. So yeah, that happens. but this is only condition over the reaction. Okay, so some more theory. I think it's the last one. Event processing networks. So I told you that there is consumption, it happens in consumer. There is operation, it's also happening in consumer, and there is publication, yeah, and it happens in producer. But as I told you, we may have various consumer of the event. So we need to have something to which we can subscribe, and this is a channel. Producer is publishing, so you can treat it as, I don't know, topic. Producer is publishing there, and there are plenty of subscribers that can take this event and react over that, decide what they will gonna do with that. Producer is not aware of a consumer. Consumer, of course, are triggered by the event. Consumer can also consume events from various places. There is no problem with that. This decision, what they will gonna do with the event, is on their side. However, sometimes this is not as simple as this. We've got something which is called event processor. This is like a tiny component that will enrich, transform an event into something that we really want to work with. Let's assume we are receiving I don't know, XML from some external sources. They are sending the XML to us. Okay, XML, this is not a form of the events we are working with, because we made a decision that each and every event is JSON. This is the place where we can do the transformation. Also, within this XML, we can have an IDs, for example, I don't know, token of the user. And within our application, we really would like to have a username, a user login, or something like that. So we can, in this event processor, we can enrich this event, and then we are publishing it further. So this event processor doesn't have any logic in it. It's only changing this event into something, into some different form. So change one event object from external source or external publisher to the event object we want to consume. Okay, some rules about events. As I said, events are about happening. Events are about past. Events are the information about something that happened. Well, and all those things that are here are the outcome of those rules. So if it happened, it cannot be mutable. Past, we cannot change the past, at least not yet. So events are immutable. Another thing, event brings us information. There is no logic in the event. There are only information. There are only data there. So looking at that, you can treat an event as something like a combination of value object, because it's immutable, and data transfer object, because it gives you only information. Also, an event can have more information that you really need. Why is that? Because producer of the event doesn't know what consumer will gonna use. That's why it's better to publish everything that you think may be used somewhere later. One more thing. Even though it looks simple, this is the hardest part of event-driven architecture, to understand what the event really is. And the rules I will mention later about publishing the event, how many of those we should publish, the naming conventions, may help you to make a decision whether this object is really an event or I'm just naming that, naming this object like that. Two things about event names. First thing, always past tense. Pull request created, not creating pull request. Our version control system, so this is this external producer. When I was talking about our domain, I told you this is our trigger. So this is some external service that will send this event to us. It has to be something like pull request created, at least in our application, because if it's external application, they really can send, I don't know, JSON status, XML status, and it can really be named as report. But we should convert into some we should convert that into some event. Why is that? XML means nothing. If I will tell you, okay, we receive an XML, I can bet a couple of you already are consuming XML in your application. Maybe you are publishing. Does it mean you are consuming or publishing event? No, this is only a format. I can tell, okay, this is not an XML, this is a report. This is some kind of status. Okay, I can say it, but this is not enough, because this is still too blur, too white, the concept itself. Event, the name of the event, gives you business information. If we are creating continuous integration tool, and I will have something which is named pull request created, and the new joiner will join my team, I will simply tell them, okay, this is our code, those are the events we are publishing, those are consumers and publisher. You can simply don't look at the internals. Simply connect dots. This event is published here and consumed by those consumers, and so on and so on. Thanks to such naming convention, event names will tell you a story. Will tell you a story of the business. And creating pull request is misleading, because it tells you that, okay, we are in the middle of the operation. Another thing, I mentioned that before, but just to visualize that, event is about this part. Producer. Producer did something, so they publishing the event to tell us what they did. It's not that producer is aware what we are gonna do with the event, so they will tell us, okay, so build started, or start the build, or starting build, because my producer already knows that we will gonna start the build based on this event. Why is that? First, you are losing the information. You lose the information that pull request was created. Second, the story is a little bit broken. Okay, but it can be challenged. To be honest, it's moving a bit. The main disadvantage is, what if someday I will decide that after pull request is created, I won't only start a build, but I'm trying to create some statistics of the developers' productivity, of the way how they are writing the code. I want to check how projects are growing, and so on and so on. So I'm creating yet another consumers that won't only start a build, but will do something different. With the name of the event build started, I will need to know that build started really tells me what will happen here, not what happened there. Okay, another thing about the event, how many data? I had plenty of talks with my fellow developers that events should be small. It's not true. If you will read a couple of books about that, if you look at the event-driven architectures, how they are implemented, events gives you all the information you may need. Events brings all the information about happening. And there are a couple of information in the event, a couple of categories. It's event data, so if I want to publish the event that build is completed, what can be there? There are some information about the build environment itself. So what was the operation system it was running on, what type of test I was running there, what is the host IP, and so on and so on. And so on and so on. So this is some rough information. Except that we've got state data. They are not always there. So getting back to my build completed, what state I can have there? I can have an information whether the build is successful or failure. So this is a state. Over the state, I can even the data are used for some kind of analysis. I don't know. I can check how I'm utilizing my hosts. So I can collect all the information about the build. I can collect all build completed events. I can group all tests that was run on particular host, and I can tell that maybe it's not balanced appropriately. This is something that I can do only with event data. With state data, I can do something more. I can react over that. If build is failed, I can have a different reaction. So I can send a notification to the author. Hey man, you did something wrong, you should fix it. If build is green, I can either trigger another build, or I can send the information to the reviewer. This pull request is ready to review. You can take a look at that. Another thing, reference data. If you will start thinking about event-driven architecture, you have to know there will be tons of those, really a lot. When we were creating our first application, we really thought that we will end up with something around 30. It was a lot in our head. Right now, we've got, I don't know, more than 200. And it's not too much. To be honest, thanks to those events, we really can track everything. We really can understand everything. We really have all the scenarios there, on all the scenarios we are aware of, at least. So what is the reference data? Reference data are the information that allows you to connect all the events in the flow. So pull request was merged. I've got information about particular pull request there. So I don't know, pull request name. Okay, it's triggering the one build. I want to find out whether build will gonna complete it, regardless the status. Once it will be completed, I would like to check what pull request it was referring to. So there should be an information that is passed through whole flow. It's extremely great if you will debug the code, and you will, because there are situations that you will connect the dots a little bit wrong. So it will tell you where events go into the wrong direction, thanks to those reference data. You also can check how many of operation succeed. So flow was ended with success, flow was ended with failure, and so on and so on. Another thing, so those are three categories that are extremely important from the consumer perspective and the developer perspective. From producer perspective, there is fourth category. To be honest, you shouldn't, whenever you are creating an event, it's not only about looking at all consumers you will gonna have, list all the information that consumer 1 will gonna need, consumer 2 will gonna need, consumer 3 will gonna need, collect them, and put all those information into the event, and that's all. No, it's good to start from the producer perspective. What you really think is an essence there, and put those information there. And then, of course, if consumer will gonna need some additional information, and you are able to put it to the event because you know them, yeah, put it there as well. So there is no too big events. Events are gives you the information about what happens. So whatever happened, those information should be there. Okay, views, I will skip it. Okay, build completed. So there are situations when we are reacting over we are analyzing the state. So my build completed have got the status. There is some build analysis here, and based on the status from the build, I can determine whether build failed or build succeed. Another thing, state change. So I told you about those builds. So I've got a static analysis that was red, then it's red yet again. Then after the commit, it's still red. Then after another commit, it became green. So build was fixed. I can have 10 events that build failed, but from the perspective of dashboard, it doesn't bring any information. So those events are the output of some analysis of group of the event. And another type of the events are the one. So here we've got the consumer of the builds fixed. Here we've got a producer of this event. So build can be fixed if it was red and now it's green. It can be broken if it was green and now it's red. There can be no change. If I've got a green build, then green build, then green build, then green build. And those type of events are tricky because it's hard to tell whether I should publish them or not. Because those are the types of the events I'm not interested. with consumption. But the problem is I'm not interested yet. So what to do with them? I will cover that later. Okay. So now a bit about consumers and producers. Something how it's good to create them. Some rules you should follow to make your consumers and producer responsible only on one thing. Those rules also will help you to put into your code the flow. Okay, so first thing, consumers are not triggered by particular event. Consumer can be triggered by various events. Consumer is not a reaction of the particular set of data, so it's not chain of data that is driving my flow. No, this is reaction over some events, and data are in the event, but the event itself is the trigger of my consumer. And as you can see, notification service. So I can send a notification whenever build is failing, whenever build's performance degraded. Those are the information that is the essence for me, and I really don't want to lose it. I want to have an automatic alerts in such case. So notification service as a component have got one single responsibility. Whenever I would like to extend the notification, this is the place when I want to go. Whenever I want to, my reaction over the event should be a notification, this consumer should consume this particular event. Great. Thanks to that, it's really easy to extend our application with new functionality. Another information, not all events have to be consumed, not all data have to be consumed by particular consumer. In that case, of course, if in build failed, I can have any information about hosts, about particular branch name, links, and so on and so on. And to be honest, I'm interested only in branch name and the email of the user, and I want to send him an information. This build is failing. Do something with it. On the other hand, with build performance, a similar set of data. Whenever I'm creating ticketing service, then yes, I would like to have as many information there as it's possible. So I would like to have information whether all the builds were run on one particular host. Maybe builds were run on different hosts, and maybe performance degraded because this last host is something that we should get rid of or upgrade or whatever. So we are consuming one and the same event, but we are using different type of data. There are a few challenges with consumers. First, you are doing the same thing. And of course, when I'm putting a blocks like that, it's quite easy to figure it out, okay, what the solution is. But when you are creating the code, when there are plenty of teams that are working on the code, it's easy to lose the track. So what to do to know that your consumer is doing one thing? Whenever the job is done, ask yourself what happened. In that case, okay, regardless what I'm analyzing, I can say that builds were analyzed, build state was analyzed, okay, and the notification was sent. On the bottom, I can say that, I don't know, the ticket was created and notification was sent. If I'm using conjunction like and, that's mean that my consumer is doing too much. And of course, this is something you shouldn't do. This is how it's supposed to look like. So we should take out this notification service. This is not a problem that, let's assume this notification service is publishing email. This is not a problem that email is built in different way from build failed and in different ways for build performance. It's, of course, consumer is aware of the event it's consuming. This is how it works. I have to know on what I will react. However, the notification itself, the sending mechanism, and so on, the way how I will choose it, it's one and can be also a big part of functionality. Another thing, it's are if conditions. So I can have consumer that is reacting over the build completed, and I told you about status inside this build completed. It's either fail or succeed. And I can have an information there. Okay, so if it succeeds, do something. If something different, then do something different. If those are totally different operation, they are not touching a single one shared component, then we should go with something like that. And how to see such situation? Okay. Also, it's worth to ask yourself a question. Do I have an event here? Did I recognize something? Because this question doesn't have to be, in my case, in this case when I'm showing you the mistake, I'm asking whether the build was successful. So I'm recognizing, and based on those recognition, I'm doing totally different operation. But it can be something like, okay, do I have already 10 builds like that? Because I want to aggregate them and publish some aggregated events. This kind of question tells me, okay, let's do something or wait a bit more. So there is no totally different things that I'm doing. There are not two different events over which I'm reacting in totally different ways. And the same may happen in situation when we've got some kind of predicate before the consumer. It is also possible to externalize this predicate before the consumer, so the one will get only the one when status is completed. The second one will get those where status was failed. The problem, you are losing information. You don't know what we just recognized. So this guy doesn't react over the build completed anymore. It's react over something different, but there is no this information here. Also, if I would like to have another consumer that will go also this path, through this path, I have to analyze the code. I have to understand it. Of course, developers that was writing this code can be already somewhere else. So I have to dig into that and rely on my guts, my understanding. I may or may not figure out what happened here. So this is first problem. Second problem, if I've got component like that, I can have an analysis. Okay, so I'm counting all the builds completed I consumed. Let's assume there were 100 of those. How many builds succeed I produce? 10. How many builds failed? 50. Okay, so first, of course, I can do an analysis over the events itself. Okay, it's great that it's bad situation that I've got more build failed rather than succeed, but I've got 10 out of 100 completed. I recognize 10 that succeeded and 50 that failed. What happened with others? With something like that, they will be lost because there is no consumer there. Here, I can really find it extremely easy. What can happen? Build can be marked as completed. For example, with execution is done, but there was some job execution problem. So exception during the execution itself, not during the test. So build was not marked as failed. There was some technical issue. And it's not there. Okay? Great. I will see that. I can find it. And I can see that this is not a build succeed nor build failed. Another side of the coin are producer, so those that are feeding us. First thing, producer can publish various events. It's not that the same situation as with consumer. Consumer can consume many of events, different events. Producer can publish various events. The difference is that consumer can consume events totally from different area. Okay, performance degraded, build failed, review code after review rejected, and so on and so on. Those events that consumer is consuming doesn't have to be related. Those that producer is publishing are related. This is the outcome of some operation over the input that triggered the producer, regardless whether it was event, trigger, request, or clock, whatever. This is the outcome of it. Another thing, producer always creates one event within the operation, and this is how we are verifying whether my component isn't too big. If I'm doing one action, I can say, okay, this is what happened. This is not like this happened and this and eventually this. Only one thing happened. That's why producer always publishing one thing. If I have a need to publish more events, then most probably I'm in this situation. This also can be a producer. So ticket created, notification sent. In that case, if I really think it worth to send 2 events or more, that's mean that I should split it. Okay, if you will violate this rule, then it will be harder to find out this place you have to modify whenever functionality will gonna change. It will be harder to find this place with which you have to connect whenever you want to add yet another consumer, producer, whatever. And it will be harder to understand the flow because sometimes branches of the path within the producer itself will grow within a time, because for some situation I will send this notification, for some event I will send the notification only under some condition. For another type of the event I won't never send this notification because it's not applicable, and it will grow, there will be more ifs there, and it will be harder to understand it. Okay, another thing, published event can depend on the history of the event. So this is the situation with the builds. If I had a build failed, okay, builds are broken. If I'm receiving yet another build failed, builds not change. Even though the event I received is exactly the same, the difference can be only within a timestamp, I'm publishing different event. Then I'm receiving build succeed, okay, build is fixed, and yet another build succeed, and the result is build not change. So producer can analyze the history of the events, because events, thanks to events, we really can go through this history. We can analyze the past, and we can make some decision relying on it. Okay, so during the talk, I think this is quite obvious right now that most of the producers are also consumers and vice versa. Of course, there is usually this first producer that is either triggered by some external service, some request, some cron job, whatever. And also there is this last consumer that is not publishing anything or is just simply storing information into some persistence layer, because this is end of the flow. But in event-driven architecture, most of your consumers will be both producers and consumers. Also tricky part, and this is all related with it, if you will try to draw connection between consumers and producers and the events that are published, you can be really terrified when you will gonna see, because it looks like chaotic web. So it's worth to, if you would like to visualize what really happens with your application, it's better to be focused only on one thing, what the thing is. It's either business process, so I could draw a situation, what can happen with my builds when I'm receiving pull requests. Okay, I'm receiving pull request, static analysis is triggered. I'm talking about the first situation is a sunny day scenario. So static analysis succeed, another succeed, another succeed, another succeed, completed, send notification to the reviewer. And I can create another scenario, another scenario, another scenario. If you won't be focused on the scenarios and you really would like to try to put everything on one picture, it will be too huge. Okay, and challenges with the producer, the same here. So what happens when I'm starting to think similar situation that we had with consumers. So in consumer we also had this blog in the blog below, and here we've got build failed. Also there is blog below, recognize failure. We are reacting over build trigger. Here we are reacting over build completed. Here we've got some analysis, build completion, build state, and we are publishing one and the same event. When you've got two or more producers that creates the same event, that means it's wrong. That means you should. There is some logic that is maybe not written in the same way, but responsible of doing the same thing. You should take it out and put on site, like in here. So build completion means that build state analysis. Okay, so build job was completed, and I've got the status. Either is success or failure. So either it will be build fail or build succeed. Here, build completion analysis. From time to time, I can create a clock that will check whether my builds, I don't know, VMs, containers, are done with that job. Because I shouldn't allow to let my builds run infinitely. It should be, I don't know, I should have some deadlines for it. So whenever I'm finding this deadline, I'm publishing yet another event. So build not finished, build completed, and we've got build state analysis that is producing information that, yes, this particular build was failed. What does it give us? Information. We've got the flow. Okay, I'm almost done. I'm out of time, but I'm almost out of slides, so it's good. Okay, that was covered. So whenever you are publishing two events, you should also split it. If there is and conjunction here, if it's and, if I want to publish this and this, that means that two things happened, or two or more things happened. If it's this or this, then it can be fine. If those builds are operating over one and the same event, if are the part of the same story, but this is sunny day scenario, this is rainy day scenario, it's still fine. Okay. Yeah, this is the challenge. I mentioned before. What if there is an event I don't want to react on? The problem with this event is, as I told you, you don't know whether in future you wouldn't like to react on it later. If you won't publish it, you will lose all the past, all the history. You cannot rerun it anymore. In some cases, you cannot get it back. So this is a drawback of not publishing it. On the other hand, you don't have a 100% guarantee that someday you will consume that. So you can keep them somewhere. It will cost you a memory, disk space, whatever, and it can be in vain sometimes. Unfortunately, I don't have a good answer on this. What we are doing whenever we are finding an event like that, we are asking ourselves, what is the risk if I will need to consume this event? What will be a drawback of it, of not having the history? If the drawback will be too big, then okay, we are starting to collect that. But, and this is some contradiction to what I told you before, because I told you that events should have all the information there should be that we can publish. In such case, we should, during this analysis, we should find out all the information that brings a risk there. and put it into the event and then keep it. If the risk is not too big, simply don't keep it. Okay, so to be event-driven or not to be. I really would like to convince you to try it, because what you are getting for free without even thinking about that. You've got business knowledge in the code. You don't have to talk with your customer to understand the domain you are working with. You don't need to ask your colleagues that are already in the different project. The information are always there. Your communication with the business will be simplified, with consumer, product manager, and so on. Why is that? Because you will talk the same language. You will use the same language. There will be no mapping in your head. You will catch all the not known term extremely fast. Separation of concerns, this is something I mentioned. So you've got all those producer responsible only for one thing. Thanks to that, they are also lowly coupled and highly cohesive. And thanks to that, we can easily refactor them. We can easily change them. If they are not performant enough, we can grab them and rewrite, because this is small. And it's also easy to add and remove feature, because it's a matter of connecting the dot. Publishing an event and consuming it. But there are three things that, unfortunately, you have to be aware of. There will be tons of components. There will be even more events. And monitoring is something you really have to have. You need to find anomalies. You need to find when you are losing an event, you are not reacting over the event, and so on. Okay, what next? There are a couple of books I recommend you. I will send it to. I will put it on Twitter, so you can take it from there. And yeah, if you've got a question, I will be here. So thank you very much. Almost on time.
it will be around 12:55 maybe. Yeah, 12:50. All right, we're getting set up here, so invite your friends who still haven't come to please step forward. We don't want to delay.
It's all right, I have a
talk.
timer here. Okay.
All right. Okay, so welcome back. We have Steve Freeman here with us. He is a distinguished consultant in Zulke Group and also one of the pioneers of Agile in the UK. Today he will try and solve the problem of tension between product and development. And so, Steve, the floor is yours. Thank you very much.
Thank you. I'll try and keep it. It's very easy in this room with all the dark. Everyone just goes to sleep. So I'll try and keep it moving. This is some joint work that I did with, or that I've been doing with an occasional colleague of mine called Chris Matz, based in London. And it's about the problem that, so I'm talking as a technical person, and it's about the problem that we regularly face, which is, we're looking at this system and the code, and it's all really just horrible, and there's a whole bunch of things we want to fix. And we keep moaning about it, and on the business, whatever, the other side, because it's treated as another side, they're not interested. It's not a problem for them. They have lots of other problems to deal with. This is not their concern. And so it never gets prioritized. And this is how we look. We're just sort of a bunch of moaners, and we don't really understand the real world and all this kind of stuff. So this is the fundamental thing. How do we get the point across? Or what are ways of getting the point across that will attract the right kind of attention? But before I go into this, I wanted to talk a little bit about what technical debt even means. And the way it's commonly understood, talked about now, is in terms of bad code. And it wasn't the original intention, but everyone talks about it now this way. And I think that's a mistake, because bad code is a different problem. Well, maybe it's a related problem, but bad code we should just fix at some level. There's questions about how you do that. But there's a more interesting definition of technical debt, which is, it's a long quote, so I'll read it out. So how many people know about Ward Cunningham, know who Ward Cunningham is? How many people know about the wiki? Wikipedia, all that stuff? Yeah? So Ward Cunningham is, amongst his many whatever qualifications or whatever, is the chap who wrote the first wiki. And he's got a number of significant innovations. A lot of stuff you've heard about can be traced back to Ward Cunningham, but not everybody knows that. So Ward says, I'm never in favor, and he came up with the term technical debt. I'm never in favor of writing code poorly, but I am in favor of writing code to reflect your current understanding of a problem, even if that understanding is partial. In other words, the whole debt metaphor, let's say the ability to pay back debt and make the debt metaphor work for your advantage, depends on your writing code that is clean enough to be able to refactor as you come to understand your problem. And I'll come back to this, but the purpose of the debt metaphor was to find a way of talking to business side people in a way that was useful. And debt is, I'll come back to this again, debt is a useful tool as long as you control it and it doesn't control you. But what this says, another way of looking at this is another old-timer, a chap called Dick Gabriel. He talks about habitability, and habitability is where the developers can place their hands on any item without having to think too deeply about where it is. You go to the code and you just look. And if you think about, you go to the kitchen, you go to your kitchen, and you know where the knives are, and you know where the coffee is, and the milk, and the fridge, and all that kind of stuff, and you can read the kitchen, you know where to go. And there's a colleague of mine many, many years ago got dropped on a project for 3 days. It says, look, we're behind on this project. You've got 3 days free. Go and work on that. Really? So he sat at his desk. What shall I do? Well, here's my task. And if I'm going to do that, I'm going to need one of these. Oh, here it is. And I'm going to have to connect it to one of these. Oh, here it is. And this is how I connect it. And this is. And he says it's the most productive code base he's ever worked on because everything was just in the right place. Now, the dark side to that story is the way that happened was there was one guy who, if you ever tried to name anything, would sit on your head until it was perfectly named and was perfectly structured. And the problem was everybody hated this guy, but it was effective for the code. But what this says, if you go back to the kitchen, is that technical debt is not about that you find the milk in the oven, but it's about finding that you've got people coming around for dinner and you need to buy a bigger pan. It's like the circumstances have changed and now you're in a different situation. What this also says is that technical debt is a socio-technical problem because habitability is both about the code and the people who are working with it. Because you can have a horrible mess, but if everybody just knows where everything is, that's kind of habitable. And it's just like most of us, I imagine, could walk into any modern kitchen and kind of figure out pretty quickly where the knives are and where the fridge is. Because we've learned, because it's a consistent habitable environment. If you were brought up as a nomad, living in tents or something, and they stick you in this room full of cupboards, you wouldn't necessarily know what to do. And what this says is kind of interesting, because what this says is that if you have what you think is an excellent project, with all the latest patterns and goodness and the rest of it, and it gets handed off suddenly to a team that has no idea how this is, what this stuff means, all of a sudden that project has, in some sense, has technical debt, because it's not habitable for the team that has to work for it. Why do we care? Why are we using technical debt a thing? Is because it introduces, amongst the other reasons, it introduces uncertainty. So when the model and the code doesn't match the world that it operates in, we have to work harder to bridge the two. Now that might be an unplanned rework, because all of a sudden, by the way, we have to get this to work in 2 time zones, and you didn't plan for that. Or by writing ugly, brittle bridging code to get from one to the other. And that's what most people do, I think. So when you look at unpleasant code bases, it's mostly because it's stretched between multiple models, and then people write really nasty hacks to get from one to the other. And the reason the uncertainty makes it harder for the people to depend on us, or for us to make promises to the people who depend on us to deliver. I think there's another level up, which is in terms of team demotivation, is that it's harder to stay focused and enthusiastic when every day you're dealing with this mess, this brokenness, working around brokenness that you just can't fix. And eventually you lose all your good people. And what this says is that technical debt is actually a product owner issue, even though they may not think of it. Because if you think about what the purpose of debt is, to balance long-term and short-term priorities. So I take on debt so I can get something now, knowing that in the longer term I'm going to have to deal with it, because for whatever reason it seems like a good idea. If the product owners have to delegate those trade-offs to the technical stories without understanding value, then part of their job, and their job is to prioritize, they're no longer doing it, or they've lost control of part of their job. And that might mean that they're not making the best decisions because a significant part of their budget, if you like, is now out of their control. Now, there is a counter problem, which is where you have product owners that don't understand the system they're working with, and they don't understand these issues, and they never, which is kind of what drives a lot of our frustrations. And effectively what they're doing is driving the system into a ditch. Now that's an important but different problem. But the risk for us as technical people is that if we say, this is a technical problem, here's our technical budget, we will lose because we don't have the budget. We're always on the wrong side of history if we do that. And so if we only talk in these sort of terms, eventually that that budget will get squeezed out. There will be a crisis or something. Something else will become more important. So the conventional way of talking about technical debt, I just realized how many people are actually familiar with the term technical debt? So I'm kind of assuming no problem. And the standard way of talking about technical debt, the way Ward originally framed it, is like a credit card debt. You have a principal, which is the amount that you borrowed, and then regular interest payments, and then the interest payments can be compounding, all that kind of stuff, the stuff you get from your bank. And everybody the way you talk about it is that if the debt gets too big and interest payments get too big, then eventually your code goes bankrupt. And I have seen that many years ago when I was freelance, and I'd go to several companies in a row where it's kind of weird out-of-body experience, where development was in Europe, testing was in India, and product was in America. And they both had 10, 15-year-old C++ code bases that were just awful because for 10 years they'd just been jamming new features in as fast as possible. And now they couldn't change anything. And the competitors were beginning to come up and challenge them, and they were stuck. They'd run out of time. So you can go bankrupt on your code base. And it turns out that you can pay consultancies, and they will give you a value of your technical debt down to 2 decimal places, which is really quite impressive, if you believe that. But the trouble with this this kind of code base analysis, and they run a checking tool over it, and it looks for complexity and assorted debt things, plug into Sonar. But the trouble with the sort of static view of technical debt is it's not necessarily doesn't necessarily reflect reality. So consider you have 2 components. You have a red component, and your tool says the red component is absolutely packed full of technical debt. It's just horrible. Whereas the green component over here is not bad. And if you take a static view, it would say, go and fix the red component. However, the red component hasn't changed in 5 years, and it's not going to change, and it's going to be retired in a year's time. No one's ever going to fix it. Whereas the green component is changing all the time, which is why it's probably green. It's probably relatively clean. If we paid down the debt based on the sort of flat measurement, we'd be looking at the wrong component. And in fact, if you look at an awful lot of standard, very, very popular open source libraries, frameworks, the best thing to do is not look inside. I think a lot of them fit clearly in the red component area, because for all sorts of reasons. And on the whole, you don't patch those things. You just take the latest release. So that's one problem. The other problem with debt in terms of credit cards is my experience is that technical debt is not linear. So again, Ward's intention was to categorize technical problems or mismatches in financial terms so that it would matter to product owners and business sponsors. And the couple of problems with the principal plus interest model, or credit card model, is one is that it sounds linear, or at least compound. And it sounds like that the debt is directly a function of the code, which means that all technical debt is equal, or equivalent perhaps, which means it's just a matter for the development team to sort out. It's nothing to do with the context of the team or what's going on or what you're planning to do. But there's a less obvious problem, which is that for people doing normal sort of business-like people, the use of the word debt suggests that technical decisions and shortcuts are safe and easy to control. So if I borrow so much today, I know what the interest rates are, I can control it, I can see that, the payments are going to come through at a particular time and they might go up and down, but it's all very manageable. And, in a lot of businesses, debt, yeah, great, I have more of that, because that's where they get some activity. What it doesn't say is tell you about the sort of situation that most of us have experienced, which is you go along, and oh my God, you just drop off a cliff. And that doesn't the principal plus interest doesn't reflect that kind of reality. And that whole sort of dynamic thing is you need to be aware of these sort of risks. That needs to be a product concern. I think the other thing that's the theory that I have is, so in the West, or most of the world, we've lived in a period of low inflation and very low interest rates. I mean, now they practically pay you to hold them, to hold on to negative rate. Interest rates are almost negative in some areas. So there's a whole generation or two that have grown up with very low interest rates. Whereas Ward, and I'm not that far behind him, grew up just after a period of some interest rates in Britain were getting close to 20%. In the Carter era, 15, 20%. And when you're in that sort of situation, interest rates are very, very important and right in the front of your face. So I think possibly the debt metaphor has lost quite a lot of its impact. But from the nonlinear, how many people have heard of Fred Brooks? This book, The Mythical Man Month, which is a unfortunate title one. This is, you should all go out and get your phone. Now you can get your phones out and order that book. It's, like I said, it's an unfortunate title of its period, but it's at least 30 years old, and it's still a fundamental text in software development. Scaling up of software entities necessarily increase the number of different elements. In most cases, the elements interact with each other in some non-linear fashion, and the complexity of the whole increases much more than linear, which again is the thing that a lot of non-technical people, also non-software people don't get, is this sort of non-linear aspect where suddenly two or three little things align and then all of a sudden things go bang. So we're proposing an alternative metaphor for how to talk to other people about the concept of technical debt. We'll repeatedly emphasize it's a metaphor, it's not a financial model, it's just a way of talking to people, the relevant people, just to get the point across. So the sort of things we might want are, we want to talk about value as well as cost, because there is value to carrying debt. That's why people do it, because they get stuff now that otherwise they'd have to wait for. We want it to reflect the dynamic nature rather than the static nature of the debt. We want to try and make it relevant to product owners, and I should say business owners, business sponsors there as well. And again, finally, to encourage focus on active components. Yeah, the product owners thing is, we want them, in some sense, although it sounds strange, we want the product owners to take back ownership of technical debt so that they can prioritize between technical debt over building customer features. Because if they don't understand and they don't have that, they don't understand the real trade-offs, then quite often they'll end up making bad decisions. And that's how you get the whole relentless feature, and then it falls off the end. So I just want to divert for a minute, just to give you a concrete example. And this, I hope, will make sense in a little while. So in the travel industry, in hotels, let's say, there's a thing you can do with a non-refundable deposit. I mean, it happens in all sorts of situations, but let's just stick with hotels. And the idea is, I know I'm going somewhere in a period of, in 3 months' time. I can put a deposit down, not pay the whole thing, for a room in a hotel, and I'd turn up and I'll get my room at a price that I fixed today. And then everything's nice and orderly. The hotel collects the deposit, and that kind of locks things down. Now, when that day comes, it might be that things have gone very quiet, and that the hotel rooms are actually a lot cheaper than the price I booked for today when I put my deposit down. At which point, the sensible thing to do is just drop the deposit. I've lost it, it's fine, because the hotel rooms are so much cheaper on that day that I should just go and book a room, do a walk-in price. Because the deposit doesn't, on my side, I'm not required to use that booking. All I lose is my deposit. Now, as you probably guessed, it doesn't take very long before a large institution, or maybe a large hotel, will start to notice that how many people are not turning up and forfeiting their deposits. And that actually, it's a nice little revenue stream for, if you do it steadily. And if you do it right, you can start to overbook a bit. Because on the whole, it will all come out in the wash. And then if occasionally you get overbooked by a couple of rooms, that's fine, because you call your friend down the street and you move them over there. And maybe you lose money on that day, but on the whole, on the whole you win. And then one day, there's a football match. And I use this example because I was traveling to Manchester, and I think there was a City match that day. And I got to about 20 kilometers outside town before I gave up looking for a hotel room that wasn't just astoundingly expensive. And I just took the train home that night. So you get these, suddenly there are these events. And if you're a hotel and you've been doing the overbooking thing, and you've been doing quite well, and then the football match happens, and you forgot to make previous arrangements with all the other local hotels, you've got a bunch of people that turn up on the day with their contracts, which you have to honor, and you haven't got any rooms. And the only rooms left are the super-duper 5-star, city centre, whatever it is, Shangri-La or whatever it is, and you lose a huge amount of money because you have to house these people on your expense because they have a contract. Now, just hold that event from it, because I'm going to come back to it shortly. I want to talk about one more thing, one more concept, which is the cost of delay. This is a term from a chap called Don Reinertsen, who writes about a lot of this stuff. And this is a way of, again, a way of thinking about things. So the idea is that if I can deliver this new feature or change, whatever, if I can deliver it in a month, it's worth 10 million. If I deliver it in 2 months, it's worth 6, maybe because I've lost a month's worth of revenue, or because everyone's caught up, or I missed the Christmas rush or something. Anyway, there is a cost of in certain situations, that delay will cost you a certain amount of money, and that delay is called the cost of delay. So, imagine we have a team, and they can deliver a certain number of units of change with the code in its current state. And they have these units of change, these new features that people want, and each unit of change has a cost of delay. So if I can deliver it today, it's worth so much. If I deliver it in 3 months' time, it's worth a lot less. And the team has a certain capacity for delivering these units of change. And as long as they keep going, that's fine. As long as that's all, we only need 3 a month, there's no point in changing anything because there's no more demand, and we're going as fast as we need to. But then, things get successful, and people want more stuff, and and then what happens is the value of reducing that technical debt, the thing that's stopping us from going faster, starts to get more and more. The value of reducing that because it becomes higher and higher because we can do more, and we can reduce the cost of delay. And so we end up with this technical debt starts to cost us lots and lots of money. Now this shape, are people following so far? I'll just keep going round and round until I hope it sort of comes together later on. But this shape is what's known as a call option. A call option, how many people are familiar with the financial markets in any sense? There's a few. So the thing is not to worry about the financial. Don't forget, the financial markets are not some new thing. The Babylonians had futures. It all comes out of agriculture originally. It's just it's more recent. It's got out of hand. But so a call option says, I've got the right. I pay you for the right, but not the obligation, to buy an asset at an agreed price at a point in the future. That's your hotel deposit. So when I put my deposit down, I have the right, but not the obligation, to turn up and buy a hotel room 3 months from now. And I guarantee to lose a certain amount of money because I've given you a premium, given you a deposit. If on the given day, if the market price is higher than the agreed price, I win, because that margin is what I've gained. If the market price is lower than the strike price, than the premium, I've lost a bit, but it's okay because I've limited my risk, which is why it's called risk management. And so the payoff is the higher the value on the day, the larger the payoff of the option. Let's look at it from the other side. So there's value in carrying the debt. So we incurred this debt so we can get some features. So while we're carrying the debt, we've already acquired some value. So same sort of thing. This is how fast we can go. As we start to get slower than demand, the value of carrying that debt gets negative, which means we're losing money because we can't deliver as fast as we need to. And so you feel like the graph flips over. And the reason you want to look at that, or I think you want to look at that, is because this is from the sold side. I have sold you an option. I've sold you a hotel booking. I'm the hotel at this point. And what happens is the price is very, again, on the day, the market rate is much higher. Everyone's busy. Everyone wants hotel rooms. I'm stuck. I'm losing lots of money at that point. What is this? This is called a short call option because I've sold it. The terminology doesn't really matter. What matters is, at the level we deal with, no one knows what this means unless you're working in the markets. However, people on the business side, particularly people higher up, will understand this. And if you tell them that you just sold a bunch of short call options, they will go, what? Because in certain situations, the risk is unlimited. If you get this really, really wrong, you can go broke on this. And any risk management side in a large organization, if you start banding words around like we just sold a bunch of call options and we haven't hedged them, that will certainly attract some attention. And so what you're trying to explain is that we've done all this stuff, we got some benefit from it, but we haven't balanced it with what you're supposed to do at this point is what's called hedges. You buy a compensating option so that you don't get hit. If you're a hotel, you go and cut a deal with all your neighboring hotels, so if there's a problem, you have someone to go to. So what we've done at this point is we've explained that actually, all those shortcuts we took, one day someone can call us on them, and that would be really bad. What do you want to do about this to mitigate the risk? And there's a couple of ways of putting this. You can think about this at sort of the portfolio level or whatever. One way I look at it is, and Chris tends to view this as a sort of at the system level, but another way I like to think about this is that like each tiny little decision that you take in the code base, each if statement, each switch, whatever, is like a decision, a commitment now. And the premium you get is because you get to release a feature, or you get to add a little bit of functionality. And on the whole, it kind of works out, even if it's not great. But it's like, if you like, the whole code base is just like this portfolio of options. And the risk is if there's a sudden shift, that all your options get called at once. So again, we're pottering along nicely. Oh, you do know this is supposed to go into multiple currencies. One currency isn't enough. Oops. Crash. So that's the thing we're trying to get to, which is that it's not principal plus interest. It's a bunch of options because suddenly something can happen and you get called. And all of a sudden everything crashes and you didn't prepare. You didn't hedge. You didn't manage the risk. You just took the money. And the thing is, it's not just code. You can get system-level debt as well. I mean, there's all sorts of debt. And, I don't know. Anyway, but just in our little world. So a couple of examples. One thing, things like using synchronous versus asynchronous messaging or communication. If you get that wrong, then you lock everything up, or whatever's appropriate. The one I've seen a lot of is where a system starts as a website. So I kind of think of that as vertical. And then over time, as it gets successful, people start adding APIs to it. And then at some point, you find that the system is actually really a message-based system with a bit of website stuck on the top, except you built it that way, and the world has gone this way. And again, it's one of those things where crossing from one to the other can be quite tricky. So, a metaphor that highlights value as well as cost. We get our premiums, so we know that we get some value back from, or we should get some value back from making this thing. Reflects the dynamic nature. I think this is a better way of talking about it than just talking about principal and interest, because it reflects both the state of the code and the environment it's in and what might be happening in the future. We hope it's relevant to product owners because we're introducing them to concepts of risk, and their job is to, a lot of organizations don't do risk management, they do risk identification. They write down all these risks that might happen and they don't do anything about it. And this is a way of explaining to product owners or business sponsors some of the things that might be risky. And it's this thing about looking at a system as it moves over time, not just as a snapshot. And one of the things that's a little bit thing is this: if the product owner is aware of a potential change in an area that has technical debt, it gives us it's a way of talking about what might be coming up. Where do you have to hedge? Where do you have to compensate? So obviously the first thing any sensible product owner is going to say, well, this all sounds very good. What am I supposed to do about this? And there are some things that product owners should be supporting directly, just sort of raw hygiene. Things like, if you're making change in a bit of code, clean it up while you're in there. This is all standard stuff. The other one, which I think is interesting in this respect, is the support for the development environment. And we see so many organizations where the development environment is underinvested. You've got slow, it's not as bad as it used to be in many places, but slow machines, or what you see constantly in large organizations is that things like the version control is grindingly slow. Or if you're forced to use Jira, the Jira instance is grindingly slow, all that kind of stuff. And it just drags everybody down. Or the build is slow, which is the classic. The colleague of mine many years ago, working at a large institution, and his machine was so slow that he measured the hourglass time on his IntelliJ instance. Not lost productivity, raw hourglass time. And he worked out that even with their inflated cross-charging rate and his day rate and all the rest of it, that they could have bought a new machine in 3 months based on his hourglass time. And took it to his manager and says, well, that's true, but nothing I can do. Anyway, it's the sort of thing that product owner can do without changing anything in the system to make things go faster. But there's another risk-based approach to technical debt. So one of the things is looking at the cost of delay for upcoming features. Thinking about these are reasons that you might want to do it. You've got upcoming features where you can start to think about the cost of delay. Reduction of lead time. How many people are familiar with the Accelerate book? I should have written it down. There's a few people. There's this report coming out of California about high-performance organizations. Nicole Forsgren or something? Frosgen? Anyway, and one of the characteristics they have of high-performing organizations is short lead time. So these are the sort of things you want to promote, reduction in lead time. And then, again, just sort of standard, old-school, trying to reduce the probability of production bug. If you've got something that's already a bit flaky, the chances are that's where the future flakiness is going to be. Now, all these kind of discussions involve a degree of sophistication on the part of your product people and an open attitude. And it also takes a degree of reflection and maturity about talking about the current state. But here's a metaphor. And, whoops, come back. I suspect we're going to see more of these, but anyway. The interesting thing about the hurricane map is it's got this thing, what they call the cone of uncertainty. Does this work? It doesn't matter. It's got this thing called the cone of uncertainty. So we're pretty sure where it's going to be for the next half day, and then maybe this is a day. There should be a scale around here, yeah. And then as this is where it might be, and further out, we're not so certain. But it does give us a general direction. And if we've done our homework, we will already know which are the most vulnerable parts of the coastline, and the ones we have to worry about most. And we can sort of monitor appropriately, and do the appropriate warnings. And then, of course, as time changes, the map is continuously updated, so that the uncertainty disappears the closer you get. Now, in the old school sort of agile, people used to claim I can take this code wherever I want to go, but in practice, again, except in highly unusual circumstances, on the whole, pretty much everyone knows where they're going. They know what the likely roadmap is going to be. So let's do a hurricane map. This is rather big for me, for some code, and just walk this through. So here's a number of features that we want, coded in terms of, I might have that the wrong way around, immediate to far out, to far away. So we're definitely going to do this. This is the next thing on the list. This is probably coming up. Maybe we do the Chinese thing, who knows. Here are some components named after towns in Manchester. That's a separate issue. And we pretty much know kind of how bad they are. We can do a rough guess. 10 minutes. And we've put some sort of numbers on them. And most teams can do this without a great deal of effort. And so you'll see that this one, Cheadle, is pretty good. Ardwick is kind of medium. This one, Berry, it's pronounced Berry, is an absolute train wreck. It's going to take us 500 days to fix, and so on. And you can kind of look at this, and you can start to make some observations, which is, we're about to start working on this one anyway. Why don't we just fix it? Clean it up. Particularly as we know there's more coming down the pipe. Similar sort of thing here. We can probably defer this a bit, but we need to allow a bit more time to clean this one up when we get there. And then this one is quite bad, but we're not going to touch it to here. However, when we do get here, if we suddenly find we have to take 100 days off before we can do anything useful at all, that's not very good. So maybe we should allocate a bit of time here to sort of preemptively to start to clean up the mess, so that when we get down to here, we're in a much safer position. And same sort of thing. Actually, I should chop one of these off. The code, if you just did your code analysis, static code analysis, that would say, you really have to fix this. This is your biggest hole. But actually, it's one of those red components. It's not going anywhere. It's probably, some ancient thing sitting on an AS400 in a whatever, no one knows what it's going to do, it's just not changing. So there's no point in touching that at all. In fact, probably the best thing to do if you ever need to change it is do a complete rewrite. And it's this sort of planning based on risk, and a little bit of look ahead and thinking about the consequences and preparing well in time, which is actually risk management, rather than saying, this one's really bad, at least we've written it down. And there are some interesting approaches now. There's a chap called Adam Thornhill. I think he's written a book called Code as a Crime Scene, and he's got a associated product out now, which is looking much more in terms of dynamic, looking at, and there is a sort of schools of research about this, looking in terms of how code changes over time and hotspots and all that kind of stuff. And then finally, the other thing you can do with this is you can do the same thing if this was staff debt. Is like, it turns out that this thing is written in Turbo Pascal or some obscure 4GL that no one uses anymore. And it's going to take you 100 days to train somebody up to do anything useful in that. Again, it's risk mitigation. You can say, I know this is coming. I don't really want to do all of it now, but I can start to prepare a bit. Whereas, this is standard Java Spring. Everybody knows that. There's no problem. Or this one's in an obscure domain. Code is pretty straightforward, but nobody understands that particular logic because it's a very obscure kind of highly regulated thing that people need to know. So you can use the same sort of thing, thinking about the team as well as the code. So, just to finish, it's about thinking about technical debt as a risk management rather than just the raw sort of credit card payment and interest. And that, because one of the things, it's a way of looking at the system, where it is now and where it's been, where it's come from and where it's going. Looking at it dynamically. And it's also about getting our point across to certain people in a way that might attract the kind of attention it deserves, or that it needs, perhaps. Because otherwise we're just a bunch of moaning techies who don't really understand the business. And finally, it's just a metaphor. This is not a plan for a scientific method for accurately pricing code bases. It's a metaphor, it's a way of talking about things. And that's it. Thank you very much. Do we have a bit of time for questions? Any comments?
Are there any questions, guys? Of course, you're not currently. Steve, you will be somewhere on the floor.
Yeah, I'll be around for a couple of hours more.
Yeah, beautiful. So the lunch is, of course, starting now.
Yes, that's more important. Yeah.
During the lunch, we will have a lecture by Nikolai Matvienko from Grid Dynamics. He will talk about serverless. So it will start here. It is the one that's been switched. It will start here at 1:30. So if anyone wants to come down, do so.
Thank you.
Athena on the scene. Hi, hi. 1, 2, 1, 2. Yep.
Wow, this bell is really working. We should have thought about it yesterday.
QA?
Q&A.
Okay.
Okay, guys. Welcome to the after lunch nap session. Here to keep you awake is Nikolai from Grid Dynamics. Nikolai, the floor is yours for the next 30 plus minutes. He will talk about serverless architecture. Thank you.
Hey, thank you for coming. Yes, my name is Nikolai, and today I'm going to talk about how to design data-intensive application in serverless architecture. So I'm a senior software engineer at Grid Dynamics. Also, I'm a Node.js expert and consultant of diagnostics and performance improvement of applications. I work in St. Petersburg and in Russia, and there is an interesting fact that I'm originally from St. Petersburg in Russia, but I work in St. Petersburg in Florida. Yeah, so different reality. And I already designed a couple serverless computing platforms with AWS and Grid Dynamics partners or clients are Amazon, Google, Microsoft, Apple, such big companies of retailers like Macy's, American Eagle, and so on. And let's focus on the serverless designing. So serverless computing has become very popular, and those solutions are really cheaper. And based on my experience, it's 70% cheaper than not serverless solution. But each year, AWS announces very awesome, very beautiful services, serverless services. But there is a lack of patterns, best practices, and solutions of experience, or especially if you are not an AWS developer. And today I'm going to show you how properly to design the data-intensive application to do not lose the money. So data-intensive application, it's a kind of applications that work a lot with data. So we may have structured data, unstructured data, and we need to extract this data, transform, and load to the different data storage or warehouse. After that, we have to analyze this data because we have to show to business something interesting, right? And so today I'm going to talk about this. So we'll focus on the step number 1 and step number 2. Also, we will focus about ETL pipeline analysis and the scalability of the data. So let's go forward. But the first question is, where does the data come from? So it might come from IoT devices, billions of IoT devices all over the world. And we have such a project at Grid Dynamics. So this data is processed in real time and stored to the database. Or it can come from different enterprise platforms, data centers, API services, and to data lake. And after that, it's processed in a pipeline to the database, and it might be in batch or stream processing. But you can use existing processing services like GlueJob from AWS, it's ETL pipeline, or you can use Kinesis plus Kinesis Analytics, Athena, some services to do stream processing. But if the logic is not so easy, it's not simple, and it's quite complicated, you can use AWS Lambda and build your own pipeline. And I have a very interesting experience. We had a project, and we had to develop the platform for 300 plus customers. And each customer established his own data processing rules. Moreover, he could update them or add new rules, and it was on the fly. So we had to process data, and also we had to reprocess data by his ad hoc request. So many data manipulations that we had to do. And develop such platform, we use AWS Lambda. But during the development, this project reminded me some famous picture from some movie. Yep. And we did it using AWS Lambda. So AWS Lambda, it's a compute service. So you write your own code, And this code will be automatically invoked in the container. So you don't need to worry and manage your infrastructure. And it's triggered by event. It's highly scalable. That's why I like it. And it's stateless and it's very cheap. That's why business loves it. And with AWS Lambda, you can process even a data lake. And data lake concept is pretty small. So data comes from different services, enterprise platform, and is stored and collected in buckets. So there is an example, each bucket, it's a data center. And inside each bucket, there are some folders, like partitions for the type of data. So to process this data, what we need to do, so we use a folder, like a bucket, and there is a snapshot for, let's say, 1 day, right? So we need the Lambda function that will scan the whole bucket folders for the files. After that, it will combine a message with the path or files. We need another more Lambda to read those files, merge records to produce a model, right? And after that, we need to process, analyze this model to collect to the database. So to make a very simple, minimalistic pipeline to process a data lake, we need at least 3 Lambda functions. But after, we need to have services to transport the data. And step by step, we'll scan and process those data until we process the whole snapshot from data lake. And we've done this job. So let's focus on the transport because it's very, very significant and valuable. So there is a notification topic service. It's a fan out. So let me explain how it works. I have a Candice. So SNS topic, it's a publish subscribe. So do you like Candice, guys? It's Candice from Russia. So it works like this. Okay, hey guys, catch it. Who want Candice? Awesome. So it's SNS topic. It doesn't worry about delivery, right? It's good, but not so protected. Hey, okay. So, but I also can put the Candice here, like, hey guys, enjoy, take the Candice, and it will be like a queue. So everyone can come here to take a Candice. So it's faster and it's like reliable because Candice are here, right? And it's out of scale. But I can hire some people that will go through the ranks and will deliver you a Candice. It's like stream works. It's much faster, and I can deliver up to 10,000 records, right, with 1 people. But I have to pay them each hour. It's expensive, and it's not fully serverless, and yeah, and doesn't have auto-scaling. But there is a DynamoDB streams that has auto-scaling, and the same performance, very, very fast, exactly once processing. I like it. But you will know about any change of candy fate. So you will know about the candy was eaten, or the candy updated, or I have more candies, so pick up. So, but if you need to choose about transport, be ready to pay, because, for example, if you compare queue and DynamoDB streams that are similar because it has auto-scaling, but DynamoDB streams really faster, you have to pay 10 times more money. Be ready for that. Okay, to process the data, we can use queue for ETL batch processing. It's enough, and that's how it looks like. We need 3 queues and 1 notification topic to announce the pipeline, and hey, we have a message, we need to process the data. This is a snapshot data. Okay, but if you need to go to the real-time processing, because you have to ask your business how soon you need to present data and analyze the data, and there is delay is pretty small, or your delay decrease during the development time, you can go to the streaming processing and real time. You need to use data stream, Kinesis data stream, and it's pretty simple to replace queue to the stream. And you don't need, so you need to give up with the first part and continue to develop the second part. That's how it works. Yeah. So, to extract the data, you need to move from the big data, from the data lake or a lot of messages from IoT devices to the large number of messages. Use queues for messages and data streams for big models, or especially for big collections, because in a stream you can path them as a train of data. Yep. Do not rush to use streams. It's expensive, and yeah, so you have to choose the transport for your needs. Okay, it was about extraction. Let's focus on how to transform the data. Yep. So there is our pipeline, minimalistic pipeline, and there is a part of application or of architecture where we transform the data. So let's focus on it. There is my suggestion: do not do everything. So do not put the whole logic of your transformation to the one Lambda function. So use event-driven design patterns names, for example. You can make merger, you can add a filter, you can make a fan-out copy, or use like some services, SNS or Kinesis for that purpose. Writer, splitter, so make your pipeline. But if you do that, focus on models, on your contracts, because, for example, and it was in my practice, merger. We merged a lot of data and made a structured model. And it was like context one. But after some time, people from other department came to me and he asked, "Hey, buddy, I like your data. I need your data. There is my pipe. Boom, boom. Pass data here." And we had to transform the models to be ready to send it. So don't blur your model through the pipeline. Keep the strict contracts, interfaces. It's like from domain-driven design. For example, you pass your data to the Kinesis data analytics, and someone can come to you and ask you, "Hey, I like your stream and data. I have my own ETL pipeline. I will subscribe to your stream and pass data here." So it's another context. So don't blur your models over the pipeline. Hey, okay, we separate our transformation, our transform Lambda to 3 Lambda functions: transform 1, 2, and 3. And there might be a case when each Lambda function has to connect to SQL database to make a query. For example, the first one has to select the data, the second one has to insert the data, and the third one had to update the data. So in the result, many Lambda function has to query database. It's not good. A lot of connections, and connections is a part of these architectural limitations. And a lot of dependencies, because each Lambda function has to have packages for how to connect to RDS, Aurora, SQL database. So it's not good. What to do? We need more Lambda. Yep, it's funny, but it works. So we need to hide the data access logic behind the API Lambda. And in this case, all queries logic will be hidden, and you will have less connection. So you can keep connection pool in one Lambda function. So you will reduce connection, and it allow you increase your scalability. Moreover, you will have less dependencies. That is nice too. Very interesting moment is reliability in this architecture, because when your message is not processed and it failed, it is not gone. Yep. It returns back to the service like Q or Kinesis. And those services try to retry a message because do not lose the message. And each message, it's some money. I had a very interesting example from my real life. So let's imagine that factory produce sport cars, expensive sport car. And we lose a message of how many logo in front of car we need to, the demand of the logo we need to make, and we lose those messages. And without those logos, I cannot say the car is ready. This car can be sold, right? It's a business problem. We lose money. So every message is money, and it's very important. But how to protect from message loss? We need to set up retry strategy. To do that, we can use a pattern dead letter queue. And every time when your function like transform cannot process the message, it returns the error. Service like a queue or a stream try to retry this message, and if not, it will pass it to the letter queue. And after that, me or you as a developer, you come, you make a fix, you'll take a look on the message, on the errors, you make a fix, deploy. After that, you pass a notification, okay, reprocess those types of errors, because I made a fix, I'm ready to process them. So pass a message to the reprocess Lambda function, and this Lambda function will extract those messages that are ready to be reprocessable. So, and pass to the topic. And so this is a controlled loop. So you don't lose your money, your messages, you can retry, reprocess, and you don't need to reprocess gigabytes of data or terabytes of data. You just can reprocess some messages, so it's very helpful. There's a much interesting moment with kinesis, with the streams, because kinesis, streams really care about persistent, and those messages will be retriable each 100 milliseconds up to 7 days. So it's not so expensive, but it spams your channel because it will retry. It's not good. So, and we have to split our messages by the type. The first type is infrastructure errors, because you can those errors can be you can process those errors, right, without your help, because it might be a timeout issue and so on. So after some time, like 1 second, it can be, you can process those messages. But if the message is a business logic error, internal error, and so on, and you have to help your application, you have to make a fix to process this data. Yeah, we need to pass this data to dead letter queue, but we have to lie to Kinesis and say, okay, I'm good, so nothing happened, I'm okay, yep, success. And we pass data hiddenly, and after that, we again pass a message through the topic, reprocess those messages, pull from dead letter queue and pass back to Kinesis. So it's a controlled loop of processing, and yeah, it helps a lot, and you don't need to reprocess a lot of data, gigabytes or even terabytes. So that's how it looks like, our pipeline and the controlled loop of reprocessing. So it's easy to troubleshoot, right? Because when you work with microservices like containers, you lose your data, you need to research from logs. Here you keep all messages, failed messages, in a persistent storage, like a queue. So you can come every time, just take a look, research, understand how you need to fix this data. And you can easily reproduce right, the error locally because you have the data. And yes, you don't need to reprocess a lot of data. Okay, so how to transform the data? One Lambda function, one responsibility. It's very important. Divide the pipeline into boundary contexts, so don't blur the transformation of logic of your model through the whole pipeline. Encapsulate the database query behind the API function to reduce the number of connections and queries. And use the data queue to protect your data for reliability. Okay, let's focus on data loading. So we need to load data to some storage, data warehouse. And that is very where this part of logic is located on the architecture. So let's focus on it. So our Lambda function can receive up to 10,000 messages if we use Kinesis streams. But if we process the data and this Lambda writes to database the data, it has 2 points of failure. So because issue might happen on processing or during writing, it's not good. And usually we have to write to the different databases, different storages. For example, we need to write data to the UI dashboard to visualize it, right, for the charts, diagrams, and so on. We need to put data for accounting, or we need to put data again to the data lake in a structured view. And here we have more points of failure. It is not good. So what to do in this case? Retry the whole batch, but you need to retry up to 10,000 records in the message. Not good. Or retry manually failed records in a Lambda. So let's focus on it. If we retry the whole batch, we need to roll back those messages or records that were already written in a database to do not have duplications next time when we do retry. Or if we want just to retry like accounting writing, we need to orchestrate this logic in Lambda function, but this is not a good approach, not a good solution, and it will not help in all cases. How to do that? Decouple your writers. So make a new Lambda function for each writer, for each database. And in this case, you will have an error of infrastructure, like your database is busy, you cannot access the database and write something right now. You don't need to reprocess the data one more time. So it's cheaper, and if there are errors during the processing, you don't need to write the database again. So you divide the responsibility. It's awesome. Moreover, so you have independent retries, and moreover, better scalability. You can set up like 1,000 instances for processor writer or processor Lambda function, and less for each writer. It helps. Okay, but what if we need to support distributed transaction? What if we need to roll back in case of error from other database? And for this case, I suggest you to use step functions. Yeah, it's a very good approach. So it's a mechanism that has instructions. So you can set up and describe your step like first writer, second writer, third writer, and in case of any errors, you can easily roll back all operations. Yeah. But you also can use DynamoDB streams, and that is where it's very helpful. So if your DynamoDB is a main database, so you can subscribe to the stream on each change of record in DynamoDB, fires event like insert, modify, update, and you may have up to 2 subscribers that will react to those changes and write records to the data lake or to the like SQL database of RotoDB. Yep, let's use it. But usually we don't write to one database. We write to several databases like SQL, NoSQL, data lake, and if we will focus only on transformation to make our pipeline faster, we can lose a focus on who will access to the data, consumers. And in my experience, it was a situation when we developed a really fast platform on the Kinesis stream. It was very fast. But after some time, we created a new application developed for risk, forecast, anti-fraud, machine learning. So your pipeline, it's just a core of the many platforms. So you need to focus how you will extract this data, which patterns query. And we had completely redo our pipeline because we had to make for risk and anti-fraud a lot of joins. So we had to use graph database, and we moved to Neptune GraphDB. So don't forget about your consumers and who will access to your data and how. Okay, so decouple functions by points of failure. It's easy. Use infrastructure as a code. So basically don't orchestrate inside your Lambda. Use the step functions and DynamoDB streams for transactions, and your pipeline is just a core. So think about future platforms around it and how they will access to the data. So we extracted the data, transformed it, loaded, and now we need to be sure if the job is done, right? Because we need to make a decision and go forward. So how to understand? But there is a problem. If we process the data, we write in parallel. So it's not easy for each Lambda function to make a decision, is it done or not, because it might be thousands of them. Or, okay, it's okay if we process in a batch, right? Because we can monitor, using New Relic, right? And monitor the window between the processing and to be sure, okay, it's done. But what if we do streaming processing? Because data comes constantly. You need to separate and understand it's done or not. You need to notify the user, for example, or visualize the data. So, and it writes in parallel. To do that, in the start of our pipeline, we need to use DynamoDB table to make a log for that for the job, like job was created. And every time when we get the record from the data lake or your database, we put the log message to the processed record table with the state done or not done. And every time when we analyze, and after that we write this record to the database, we change our state to done. So until we process all data, and we have a stream, DynamoDB stream, that fire a Lambda function that checks the count of already processed records. And if the count equals to number of all records, it means the job is done. So that's how we do that. And in the end, it notifies through another stream a subscriber. It notifies the user or the other system about completion of the job. Let's focus on data analysis. This is step number 2. So in data analysis, it's actually another pipeline with another logic. And actually, this logic is much complicated. It's not simple because you have to analyze risk, right, accounting, and so on. And but the first part of the job that I just described, you can, if it's simple, you can change it, replace it by glue job ETL service from AWS, and you can write your transformation on SQL. And to go to the second step from the main architecture, and actually the step number 3 here, you use step functions, so you already know about it. But also to make a decision the job is done, we need to use DynamoDB stream. So to build an analytics platform, data analysis, ETL pipeline, we can use again Lambda functions. So let's focus. So you build your own pipeline based on logic that you need to do. And that's how you orchestrate multiple ETL jobs with step functions. Okay, let's focus on scalability. It's very important because if you architect and you make a big pipeline and in the end it's not scalable, that's not good because you need to focus on scalability. And that's how it looks like. So simple pipeline, right? 3 Lambda functions, some queues. So basically you can choose how many Lambda functions you need to run in parallel for each step of your pipeline. So let's say that we need just only 10 Lambda functions to start to make for the job. Okay, 100 for files, to read files, and 1,000 to process messages, because messages are a lot. It's usually millions of records. So it's easy, but the most interesting part that Lambda scales very high. It's awesome, but database and services not so flexible in this case. So you need to focus on your transport and on database. So this is an example of a minimalistic presentation of architecture diagram from some project. So actually it's a blueprint. So, and using this blueprint, we were able to process 10 and up to hundreds gigabytes per second on 5,000 up to 10,000 functions in parallel. Yeah, it was so fast, but we had to focus on our database, so DynamoDB capacity. We had to focus on Aurora connections, database size. We had to switch to the Neptune. It's Hero, it's a graph database. So you need to focus on the data. And this architecture, so you need to build architecture, focus on the data view and the schema. So that's how it looks like. So in the end, design mistakes, it's a solution price, right? But in serverless, you can build very flexible architecture. You can switch from a batch processing even on the fly to the stream processing, right? Switch your transport and just redo some architecture patterns. And you can run 1,000 lambdas in parallel. That's really high scalable and process gigabytes of data per second. Thank you so much. My name is Nikolai Matvienko. I'm from Grid Dynamics. It's an international company, and now we have an office in Belgrade, so welcome, and thank you so much. Oh, okay. I understand that not all of you designing serverless architecture and even work with serverless. But if you have some questions, you can ask me, or if you'd like a Candice.
Hi. So my question is on the first step of your sort of ETL part, where you actually ingest something from external API. Are the Lambdas best solution for that? Because you can experience some throttling from that third-party UI? And if not, what would be?
Oh, you ask about the Lambda extracts the data from the some storage, right?
Yeah, from some external API, let's say service.
External, no. Lambda doesn't extract data from external API. It extracts usual data from a data lake.
Right, but in your presentation there were cogs with API written in the center. So who extracts data from those APIs?
Oh, I got it. So there is another Lambda function which I call API, right? Yes, so you need to invoke, so actually you invoke the Lambda function inside your Lambda. Yeah, so first time you will have a delay, but you need to set up the concurrency of those Lambdas to run next time on a warm start. But if you focus, let's say you need to open the connection to MySQL, right? You need to spend the time. And to run a Lambda function, even like on Node.js, it's faster. And when it's already run it before, so it's a warm start, it's pretty fast. So you need to choose like scalability, like connection count, and you need to compare the performance. And in our case, it worked faster.
Okay, thanks.
Yeah, good question. Thank you.
Any other questions?
Thank you. Are there any limitations regarding the time the Lambda functions can run? And if there are, how could that be a problem for the machine learning applications, which typically can take some time to execute? And what would be the solution for that? Thank you.
Very, very good question about the time. So it's a long topic because sometimes, like when you see the time is 15 minutes, it might be a problem in your Lambda function because you do not return like if it's a JavaScript like promise resolve and so on, so you need to check the errors. But yeah, there is a limitation 15 minutes, and actually every year AWS increase the limitation. So in the past it was 5 minutes, now it's 15 minutes, so actually you can run a job. But in my experience, I do not recommend to run a function for 10 minutes, even for 10 minutes. It should be less. So because if you run Lambda functions that do a lot, does a lot in 15 minutes, and you run like thousands of Lambda function in parallel, you pay the same money because you paid for the time. About the machine learning, repeat your question about the time about machine learning.
Are they suitable for machine learning tasks since there is that limitation? But if it can be run in parallel, highly parallel, then might be. Right?
Yes, I understand.
Typically, long-running tasks with large amounts of data.
Yeah, I understand. So these Lambda functions, we prepare data for machine learning, but for machine learning, we run existing services of AWS. Yeah. Thank you. I have some candies, guys, from Russia. Enjoy.
Sve ok. Ma već sam setupovao. Aj samo da vidimo dok krenu. Čekaj, evo ga. Šta vam dam? Znači samo na dan. Aha. Ćao. Boban, vratite mikrofon. Ugasite mikrofon. Zdravo, ugasite mikrofon. Sve govorimo oko Q&A, hoćeš to da radiš ovdje ili ćeš sam polje? Ma mislim da je okej ovdje. Okej, dobro. Ako ti to potigneš. Pola sata imamo, tako? Da, imaš, evo ti gleda ovaj timer. Ako se, što hoću da cijenim? To, znači imaš tamo da gledaš možda tu. Ako imaš, ono, to malo meta, možemo ti malo. Da, mislim, počet ću i ostavit ću na kraju, jer svakako ide otprilike na krap, 30 minuta, ali vidjet ću malo. Da, može. Znači, ako završim tačno u 2:45, reći ću da dođem na štamp, a ako završim ranije, reći možemo sad neku diskusiju. Ali ono, pošto su ljudi, brate, prestravljeni da pitaju bilo šta ne. Možda ih nema mikrofona. Ne, možda su dosadni. Ne, nisu. Mislim, oni imaju nema veze, bit će tako. Aha, zvonim. Nešto da bude, ne ubijem. Mislim da ću čak i na završiti, pa da ostane.
Okay, guys? Yeah, this bell is really doing the job. I'm impressed. You're in for a treat, of course, during this lecture, but also after. Ice cream from Poslastičarnica, my humble opinion, one of the, if not the best ice creams in the city, will be served by the partners wall upstairs, so just on the O level. And of course, you can go ahead and feel free to enjoy as much as you can and as much as they have. So yeah, I'll be handing the floor to you now, so you can, start with your lecture and have great 30 minutes, guys. Thank you.
Thank you. So welcome. Today I'm going to talking about how to convert technical expertise and soft skills into great product. So if you are working in an IT industry, half of this story is going to be really familiar to you. Or if you are working in biology field, also some parts you are going to see as familiar parts. So I would like to start with this picture. If you ever saw this picture, it's a really important moment in our history of humans, and it presents the first human genome sequenced. So these books, or this bookshelf, they contain the whole genome of one person. So historically, this started, let's say, 30 years ago. The whole project was funded by US government, and they decided that they want to analyze the whole human genome. Before that, that was only done in parts, in small chunks, so they decided, okay, let's get a clear picture how the genome looks like. It took them 13 years to build this bookshelf. So scientists all over the world started sequencing small chunks of one person, and at the end they combined all of them, and this is what they got. So as you can see, these books are divided into 23 groups, which are presenting chromosomes. So, but what's in these books? If you, let's say, take any book from this shelf, open any page you want, you're going to get something like this. It's not really understandable, but what you can see here is a combination of 4 letters, A, T, C, G, and they are presenting your genome. So basically in these books, you have somewhere around 3 billion of these letters, and they are presenting what you are in a biological way. So while you're looking at this, you probably can't tell anything, but actually these letters are telling everything about you. So in these letters, you can find almost everything about some person. What's the eye color, how tall that person is, does that person have predisposition to get some disease or anything similar. So everything in a biological way. So that project was really expensive to get this. It cost around $5 billion. And that was for only one person, but today technology advanced. So you can do that now for only a couple of $100s let's say in a day, because now we have machines doing that, and those machines are called sequencers. So how does that work? You find a sequencer, then you need to provide, as an input to sequencer, you need to provide a human sample. It can be blood, cells, saliva, anything. That sequencer does some magic inside it. We won't go into details. And at the end of that process, you get a file. So that file basically contains everything that you saw in these books. It contains everything about you. So the whole concept now looks like this. At the beginning, you have the data. You're collecting the data about humans. You're doing analysis on that data in order to get knowledge about humans. And then with knowledge, you are creating an impact. In this case, it's impact on human lives. So the more data you have, the knowledge that you get from that data is more accurate, so you can make better decisions when you are working in bioinformatics. So we as a company, as a software company, we are somewhere around here. So we are building tools with software that are helping people to get meaningful data, which they can use to create knowledge. With knowledge, they're creating impact. Almost 5 years ago, when I started working at 7 Bridges, when I learned all of this stuff, and when I learned about bioinformatics, and when they told me what bioinformatics does and people in bioinformatics, I thought that they are unicorns, basically. Because that's really a weird merge between two worlds. So on one side, you have biology, and you have humans, and on the other side, you have technology. So these are really two different skill sets. You need to know how human body works. You need to know what you are looking in data. And then, in order to get the knowledge that you want, you need to know programming. And all of that is probably done by one person. And that was, let's say, a weird set of skills. So today you have somewhere around perhaps few thousands of bioinformaticians in the world. So bioinformatics as industry is still young. A lot of hacking is happening at the moment. I think that they are mostly using, as programming language, they're mostly using R, they're using Python, maybe Java, and then at the same time they are learning about humans. This concept may sound pretty abstract now, but let's see how that would look in real world. So let's say whenever a person steps into this room, without even looking at that person, we want to find what's the eye color of that person. And that's our whole process that we want to see. So a person steps in, we want to get a PDF file that says this person has blue eyes and chances that we are wrong is, let's say, 3%. So how we are going to start? We are going to start by taking a sample from that person. So person is stepping in, we are taking a sample, and then we are using sequencer to get a genome of that person, and then we are getting a file. But what to do with that file? I mean, you have a file that has millions of lines of letters and some random data that it's not readable to you. You need to make analysis. You need to process that file. So as bioinformatician, you're probably going to know what you're looking into that file. So in our case, we want to see eye color, and we know which part of the genome we are targeting. So we need to find a tool that's going to take whole genome. It's going to split that genome into multiple parts, and it's going to say, okay, this file contains data about eye color. And then we need another script that's going to compare your data. So in order to have accuracy, you need to compare data between humans. So we need to compare file from each person in this room just to have a meaning how accurate data is. So let's see, for example, each person that has blue eyes in this room, we want to compare all of them to be sure if we are correct. And this is basically how bioinformatics works now. They are still hacking a lot. All of this is mostly manual process, so you're losing a bunch of time just to, let's say, to upload the data to some cloud. Then you are losing time to find all of these scripts that you want to use. So imagine executing each of these scripts manually, and that's a lot of time. And then when you have a data set, for example, let's analyze the whole country. Imagine how large data set that would be. For example, one human genome can weigh up to perhaps 30 gigabytes. So we are talking about petabytes of data. So we decided to create a product called RABIX. RABIX stands for Reproducible Analysis for Bioinformatics. You can probably make a connection between RABIX and rabbits and reproducible, so you get the idea what we wanted to say. So RABIX is desktop application. It's open source. You can find it on GitHub. And if you ever researched how visual programming looks like, you've probably found a concept like this one. So how it works. On the left side, you have these scripts that we talked about. On the right-hand side, you have a huge canvas. Then you are drag and dropping your scripts, and you are connecting them between. And that's it. The concept is pretty simple. Of course, there are steps in how to create these scripts and how to write this language, but all of that is a layer below. So what you are doing here, you are creating a workflow visually, and below what we are doing, we are creating a layer of code. And that's it. It's pretty straightforward because in all these manual processes, you don't want to add another step that bioinformatics people need to do. So this example is pretty simple. I found online some of real-world examples, so they look like this. Someone told me that this thing looks like Sentinel from Matrix. It was the creature from the movie. And this workflow presents how it looks like in bioinformatics. Of course, you can go even worse. You have stuff like this. This is also a real-world example, how that automation that people are using looks like. So here you have probably 100 scripts. Each blue circle presents one script. And below that, you have probably millions of lines of code. And all of that you are presenting with one image. And this is how we created the product called Rabix. So when we released it 2 years ago, people started using it. People adopted this as a product for writing these automations, but we encountered some other problems. The first problem was user experience. So our main product was a cloud-based platform, and what we are offering here is a desktop application. So in bioinformatics, almost everything is in the cloud because you need to share your data with others. Those are huge data sets. You cannot store them locally. And then you need to provide reproducibility, meaning that if I'm doing something today with this workflow and I'm writing a paper about this, 10 years later, if someone wants to get the same results that I'm getting today, we need to provide that. So meaning that all these scripts should exist. All files that we are using should exist in 10 years. And that's one of the biggest problems that bioinformatics is facing at the moment. So you can probably tell, you as a user, you're using web-based platform, and then you're doing your analysis, and at one moment we say, yeah, but if you want to continue, you need to download desktop application. So that's a really bad user experience flow, because we are asking someone to stop what they are doing, to install desktop application, to make a connection with the account, and then to sync the data between two applications. That was the first problem. Other problems we had, of course, with Windows and Docker running on Windows. We also had problems where some users, they are working in large pharmacies, meaning that they probably have third-party app restrictions, they cannot download desktop applications, and so on, so on. So what was the idea? We had to move the Rabbit to the cloud. And that's how our second project started. And we did it. That's it. Like, we moved the whole desktop application to cloud. It's working in the browser. Everything is cool. We are offering now both products, and that's it. But let's talk why we should have failed. What I mean by this is why we shouldn't make this product at the first place, and what were the things that we are facing at the moment. So let's start with the team. This is our main engineer. I'm not saying it's his fault, but I just trying to create you a perfect image how the team looked like. So this is Marian, and he has a back pain problems, so he's using this ball instead of his chair, but obviously wrong. And at this very moment, so why this moment is special is because this was at the very beginning of the project, and we were sharing the same office, and this was super early in the morning. So I started morning like every other morning. I started asking a bunch of questions that we are facing. I started presenting him a bunch of problems that we had with our desktop application, and he was not really enthusiastic about all of that. He's obviously holding his phone, and he's probably thinking, I just wanted to do Angular, that's it. I don't care about users and what's happening at the moment. So yeah, the project started as a two-person team. You had Marian as an engineer responsible for this project, and you had me. My field of expertise, my previous field of expertise was user experience, and I spent last couple of years working with users. So all of my focus was how users work, what they are doing, what's their behavior, how they are using our products, are they frustrated, how intuitive our interface is, and so on, so on. But here, on this project, I stepped in as a product manager for this, and now on this project, you had this merge between product and engineering. So when I look back, there's probably a bunch of things that I'm still missing, but let's just talk about persons who are doing this. So on one side, you have a user experience guy. As Marian would say, my purpose was to pick colors. On the other side, you have engineer, and as I would say, he was just copy-pasting code from desktop to web. And that was cool. Like, we covered small parts of our product, but what's with all other things that you need in order to release the product? What's with business? What's with sales? How users are going to learn about this product? How we are going to release it? Who's going to write documentation? How do we include someone from quality insurance? And so on, so on. So as we started working on this, since both of these roles were aimed toward the solution, so we were falling in what would someone say, build trap. We are building what's cool for us, but we are not building what's actually solving the user problem or what's actually working for our business. And then, of course, after some time, we got more people joining in. But let's also talk why we didn't fail. If, let's say, we were building a car, we started with prototype. And our prototype looked like this. So we decided we had, let's say, somewhere around 4 months to build the whole thing, to move the whole desktop-based application to work in Chrome. So how we started? We started by building a prototype, and we spent almost half of our time of this prototype. The thing was simple. Let's see what's the happy path for the user. Let's see what's the single thing that we need to have in this prototype in order to prove our concept. If you're thinking about the car, that's probably it. You just need wheels and a base where you're going to sit, and that's it. So we stripped down everything, and it took Marian around 7 days to build the whole product, the whole thing that we released after. But there was a catch. Half of functionalities didn't work, but as we agreed, we are only covering happy path. And why we did this? Because we needed to test our idea. That was the one case. The other case was we are only 2-person team, and we need to deliver a huge product, and we need more people stepping in order to get more information and to release the product as you should have. So what's the next thing we did? We told everyone about our car that we are building. First, we went to product design team. We told them, hey guys, we are merging 2 different products into one. So the problems that we are facing are obvious. First, you have 2 different UIs. Then you have 2 different front ends, 2 different technologies. You have 2 different flows. You have different interactions, because in the desktop app, you can use right-click, you can use shortcuts, you can use double-click, but now when you are moving to web, you cannot use all of that, and we don't have time to think about everything. So we started collecting feedback from product design team. Then the next team we went to was front-end team. We told them, guys, we built application that's desktop. We built it by using web technologies, but we used Electron to wrap everything and make it available as desktop application. But the platform that we need is written in Backbone. So now you have Angular, you have Backbone, and you have to make those things work seamlessly and offer as one solution. What we are going to do with that case, we also asked, okay, we have a bunch of public API calls. We need somehow to revert everything to make it work with our internal services and so on, so on. We also went to product team, said, is anyone building similar car? Like we need your inputs. We also went to bioinformatics team and said, you are our end users. You're going to probably use this car, so it's better for you to give us feedback and if you have anything to add, or you're just going to get the thing as it is. So at the end, everyone in the company knew what we were doing. They knew that we are building this ugly car. So after some time, people started coming to our office, and they were like, hey, I was thinking about the car that you're building. I have advice for you. Or in my previous company, I was building the similar car that you are building right now. Here's how we solve this problem. So as a two-person team, we started by inviting more people into this project and telling them what we want to build. We also took, okay, my field of expertise is user experience. What I'm going to do next is I'm going to do user interviews. So that was our next step. What we did, we started doing usability tests. So that's a really good practice if you're in an IT company to do usability tests with your products, if you have. If you don't, you can do it with your colleague. So how it looks. We have a prototype, and that prototype fulfills only one path for the user. In this case was someone needs to open an app, they need to drag and drop scripts, they need to connect them in between, save those scripts, and that's it. That was the only thing that was working at the moment. So we created small tasks, took like a piece of paper, wrote down for a user, saying something. First, you need to find the script, then you need to create a workflow to connect all the nodes in between. Once when you've done that, you need to save all of your work, and then you need to share it with others, which is basically what people were doing at that moment. And then we went to do usability tests in person. So it looks like I take this laptop, I give a prototype to someone, I show them the task, and I let that person do his job. But next to that person, it's me and Marian, watching what does that person, what are the struggles that that person is having at that moment. And then you can actually see what's happening with your product. All our things that we wanted to build, that we thought that they are cool, are in most cases not usable. People are not, they don't care about that, they just want to fulfill one single task. So next, we also did some remote interviews. So what was the approach? If you approach to someone and say, do you need this feature? Do you need this car? Everyone is going to say, yeah, I need it. Nobody is going to say, I don't, because it's better to have something than not to have it. But in most cases, that was wrong, because people are not thinking on that way. They will always say, yeah, I need this feature, but they won't stop to think if they are going to use it, in most cases. So instead of asking them, do you need this car? We ask them, can you tell me what you are doing at the moment? Can you share your screen? Can you tell me what problem are you trying to solve? So once when they started doing that, they were literally sharing their screens. They opened Rabix, the thing that we built, and then they said, okay, I'm having problems with connecting with your platform. When I connect the data, I usually search for a script. By the way, your search is not working. Once when I find the script, then I drag and drop it into the canvas, and so on, so on. So that way we could see what they are actually using and how. Because we are building the product, so we know every detail of the product, and we know what's the perfect path for using it. But when you are watching from user side, you cannot do that. So at the end, as someone who changed his field of interest recently, and as someone who was not so familiar at the time what I'm doing, stepping up as a product manager for this product, this is probably the single thing that I would outline right now. So the most important thing that I learned is you need to talk with people, and you need to talk with people a lot, especially if you are not sure in how you are making decisions, if you are not sure if you are asking the right questions. But also, you need to make other people talk. In this case, I had to make Marian to go to engineering group to present the problem and to ask them to give him advices on how to take out all desktop parts and then connect them with the platform. So that was the project-based decision. But as a team, when we were working, one of the most important things that I learned is you need to share how you are thinking at that moment. So as a product manager, you are not a team lead, but you need to make a lot of decisions, and for a bunch of them, you are not sure because that wasn't your field of expertise. In this case, I had to know technology, I had to know design, I had to know bioinformatics, and I also needed to know, is this thing going to sell? So I started sharing my flow of thoughts and how I'm making decisions. So when we sit down and then we started discussing, for example, is this going to be a full screen application or is it going to be embedded somewhere? I always shared all the information that I know. So at the end, yeah, that's basically it. Like, if you're not sure what you're doing, you just sit with other people, you find people that are expertise in that field, you talk with them, and it's way easier for you to make decisions and to help other people in your company. Thank you. I guess we have time for questions.
You have 2 minutes for Q&A if you'd like to use it now, or of course you can always visit the booth. Okay. We have a question over there.
Product manager. That's also one of the things that people miss. Is it product or project manager? So my previous interest was user experience. I was a designer. User experience designer. So meaning that I was mostly doing research, but that also included creating prototypes and working on actual visual design. More questions? You can also stop by our booth, 7 Bridges. I'm going to be there for next, let's say, 20 minutes, so we can talk.
Okay. Thank you, Bojan.
Thank you.
And a special thanks to 7 Bridges Genomics, one of our oldest friends. Yeah, their booth is upstairs, just beside the Americana stage. So yeah, you can hop over, Bojan will be there. Also, I will repeat that we will have ice cream served at the O level at 3 o'clock, but you know the talk will be then. So yeah, you can hop over. They will be there until 5, so until basically we close. Okay, thank you guys. The bell is not ringing outside, so I assume more people are in front. Maybe they hear me now. All right. Dan is here with us for the 5th year in a row. So he's been one of the most loyal Heapspacers ever. Dan, why do you keep on returning?
Because this is one of my favorite conferences and events in general, and it's really good.
Yeah.
So I'm enjoying it. Even if I'm not a speaker, I will be here.
Yeah, brilliant, and I mean, congratulations really for passing the call for papers each year. It's not
Thank you.
It's not an easy task. So thank you very much. You'll be talking about edge computing today. So you have your 45 minutes starting now, and good luck to you.
Perfect.
Thanks.
Thank you very much. So how's everybody doing? Friday afternoon, everybody waiting for the weekend. That's all right. Me as well. So hopefully I have an easy topic for today. So I want to talk a little bit about what we think, where we are at our computing journey at the moment, and where the things might be going in the future, and why would we want to consider moving in that direction, and finally try to provide some challenges of what we can expect on that journey, and how we can try to solve some of those issues. So, what's edge computing? Basically, to know where we are going, we first need to figure out where we are today and how we got where we are today, and then try to figure out what's coming next, right? So, cloud native computing, right? That's the buzzword for the last couple of years. Everybody's doing containerization, microservices, scaling websites, scaling mobile applications, solving IoT problems, and things like that, right? But even if we are living in that highly distributed world from the programming perspective, everything is still deployed into what we can call like a core cloud and centralized cloud infrastructure, right? So we have a large number of websites, large number of mobile users and devices, but everybody is connecting to the basically same infrastructure hosted in the central cloud, right? That's not that was not always the case, right? So here's a little bit what people figure out how these big shifts in the computing were going on, right? And you can see the things are going back and forth, and it's not just a fashion, but there is a lot of fashion in it. But let's talk a little bit about all this and how we got here, right? So first we had a mainframe computers. So computing was very expensive, so there was like a really limited number of centralized computers where all the workloads were running and all the applications were running. That was fine. That was good enough for the use cases that have been solved in that era, right? Later on, with the development of the networks and personal computers in particular, client-server era started. So now we have like a distributed computing for the first time. In distributed computing, in terms that one solution, one application is not hosted on a single computing power, right? So it's you had typically fat clients, you had some logic on the server side, and you had your database on the server side. So your workloads were workloads. So your application was distributed between the clients and the servers, right? Cloud computing is what we're experiencing now, right? So, as I said, it doesn't look centralized if you're a software developer at all, right? Because everybody's trying to build a lot of microservices and connect them together. But if you take a look at the clients and where the workloads are, everything is, so there's a lot of clients connecting to the workloads that are hosted in the core cloud. So the next age, the next shift in the computing is edge computing, where we all try to again distribute our workloads. And even if this seems like that all these big shifts that were coming in this process were unnecessary, it's not. So with every of these shifts, the scale of the solutions that we build went dramatically, 10 times, 100 times, thousands of times, right? So we had like a very limited number of mainframes. Then we had like a small system within every enterprise doing their own client-server thing. Now we have like a website that serves millions of people and millions of mobile applications. And so you can see that with every shift, there were some of the triggers that enabled that shift in the technology and opened up a lot of new use cases that couldn't be solved earlier, right? So what's edge, right? So we started talking a little bit about this in different working groups that I'm involved in. And the problem is that, yeah, edge basically means different thing to different people, to everybody. So depending on your background and from the field you're coming from. But if you put it in like a single sentence that you want to try to explain to people, you know, what edge computing is and what edge particular is, that's yeah, everything that's not running in the core cloud can be considered as an edge site or edge, right? And why would we want to do that, right? So that's the other obvious question. And the answer to that question is that we'll try to bring compute resources as close to the source, to the users of those resources as possible, right? So that can be humans clicking on their phones, that could be devices, that could be autonomous cars, whatever is producing the data or consuming those data or need to be controlled by the systems. So we're trying to bring the compute resources as close as possible physically to those sources. And as I said, what are some of the triggers that push us in this direction? I think what we can say is that like the systems now are producing much more data than we were that we were used to, and that we are solving with the pure cloud native technologies. So we have much more data, and that provides a couple of problems. We don't have enough bandwidth to get the data to the cloud. We need much faster processing of those data, and in the end, we have much more compute resources available to us. So how we are going to deploy them in order to get better applications and better use of those resources is a big question. So IoT can be seen as one of the main triggers for the edge computing as well, right? We'll cover all these topics in a little more details as we go forward. But these are like what can be seen as a key triggers for edge computing. So if you can imagine. We are not now dealing with people scrolling the Facebook pages and putting posts and pictures. I read somewhere information that like autonomous car, one car is producing I think tens of gigabytes of data per second. There's no bandwidth and there's no real chance to get all this data from the car to one central cloud and get it back in the available time to actually make a rational decision about the data we're trying to deal with, right? So with the triggers, in order to make a shift, we need triggers. We need to identify the use cases we want to solve next, and we also need to figure out what are the enabling technologies that can get us where we are. In my opinion, cloud native computing is one of the main enabler. And even if everybody is not convinced that going to the microservices way and containerize everything and distributing your applications in a lot of independent small services makes sense. It might not make sense for smaller applications, but trying to solve all these problems actually makes sense. So now we have a lot of tools that we didn't have 10 years ago. So everybody's talking about Dockers and Kubernetes and using CI/CD platforms to actually develop, deploy, and organize these services in a really large scalable way. And this can without having this at the moment, without having this technology to be able to use today in the core cloud and only in the cloud native environment, we wouldn't be able to try to tackle the edge computing use cases. 5G is a big promise as well. So it will, in theory, help us to solve some of the bandwidth problems, but not all. And in the similar fashion, even if we have a much better bandwidth than we have today, there will be need to put the compute and to put the services closer to the data as well. But in my opinion, the 5G would not solve all the bandwidth problems, but will open a new use cases that probably we are not even aware of exists today. This morning there was a session in this room as well about machine learning, and there was a mentioning of a couple of use cases of actually running those trained models on the edge sites, which makes sense. So that's one of the key enabler, moving the applications from the traditional model to more like trained machine models, and executing those models and making decisions locally as much as we can, right? So, as I said at the beginning, once you put this thing into this perspective and try to talk with people and start to think like, what's edge for different kind of people, you get a millions of answers, right? And this is why I like diagram, this particular diagram that we came up after a little bit of talking and researching, trying to categorize all the other things. And as you can see, we can define multiple types of edges, and I think all of these use cases make total sense. So, starting from the right, it's where we are today. That's AWS, that's Azure, that's Google Cloud, that's OpenShift, that's all the cloud providers coming out, right? All those cloud providers also have regional data centers, so they can. The hybrid cloud becomes a thing, a much more closer thing than edge computing, and that's all fine. And then we coming outside of the clouds and entering the edge space. So the first folks that are very interested into edge computing are all the service providers that we have today. Telcos, ISPs, CDN networks. Nobody wants to be, no one of them wants to be a dumb pipe for cloud providers, cloud software providers. So why would CDN network only host our pictures and videos? Why they couldn't host some of the workloads and some of the services and host actual application for us? It also makes sense for telcos and ISPs, because these guys already have a lot of widespread geographical presence everywhere. So those are called point of presence, POP sites, all over the countries and cities and regions and even neighborhood. So, in theory, those sites could be used to host some of the applications of the future, right? And then, and when you take a look at these kind of scenarios. We will talk a little bit about computer resources soon, but what's common with this kind of application, with this kind of infrastructure, is that these guys usually don't have problems with network, right? So it's all reliable, high capacity networks, which is one of important things to note now. We'll talk a little bit about that later. Then we have a last mile. So once you get out of your infrastructure, guys, there's a office. Enterprise offices, retail places, like every supermarket want to have some computing power there. That's not new. We're trying to do that for a long time, right? And the only difference between that type of edge sites is that the network here is a little bit more challenging. So you're relying on your typical end user network, right? It can be reliable or unreliable. It can be symmetrical or asymmetrical, depending on the upload and download speeds. But also, if you take a look at the use case of a traditional IoT use case, like having oil refineries and oil sites and all these kind of really remote locations, that network can be really even bandwidth can be really really expensive and really small, right? So that's another thing that you need to account for in these use cases. Then that's only categorizing the edge from the provider and end user kind of point of view, right? Then you see that we have, even in those categories, we have different type of things we can do, right? So for a big telco provider, it couldn't be a problem to provide like a mini data center and with like a full infrastructure that you would expect from the core cloud provider. And then as much as you go to the smaller point of presence sites and even the retail infrastructure and office edge scenarios, you have less and less computing power available to you, right? So that's a basic story about what edge computing is. So yeah, let's try to figure out what kind of use cases, what kind of applications we're trying to solve with this. And there are a couple of things we identified so far that are really make sense when it comes to edge computing. So first thing we were talking about is that in most of these cases, the systems on the edge are producing large number of data and are sensitive to the latency of result of processing those data. And it's unfeasible to send all this to the central cloud and get the application there. So that's one big category of use cases. Other is trying to provide reliability and high availability of edge sites. So some of these, as we said, in some of the cases, the network could be expensive and unreliable, but we need to provide that site is functioning properly, even in cases when there's no network connectivity to the central cloud and to the services running into the central cloud, right? And the third thing I would generally is a data protection and data pre-processing. So one thing is that in some use cases, because of the local policies of sometimes the data even can't be used and can't be sent over from the site where they are generated. Think about GDRP in Europe. Also, I heard recently that in China there's a law that GPS data can't leave the region, can't leave the country. So those data needs to be stored and handled locally on the site, right? but also what we have a lot in the IoT use cases as well. There's a large heterogeneous amount of devices and systems producing those data, right? And what we usually like to call there's a device zoo out there, and usually the job of this first level of processing of the data is to normalize and pre-process this data for a further processing. So trying to handle with different protocols, different data formats, do some basic analytics to filter out the noise from the actual information, add some metadata to everything like location and identity of the systems that are producing the data. So those are the three main problems that edge computing is basically trying to solve, right? And like with everything with technology, there's no silver bullets and magic nowhere. So there's always trade-offs, right? And I think this diagram is something that we are trying to spread around and talk to people about, why and when you should try to consider edge computing. So if you go to the core cloud technologies, you get a better economies of the scale. That's where we are today. So with a very little of computing overhead, we can manage large number of workloads and everything can be shared between the same computing infrastructure, right? And our workloads are sharing the resources, and the cost of computing is going down. But if we go to the edge, we are tackling this problem of doesn't have to deal with the bandwidth. We have a better latency, we have a better resiliency, availability of our systems, and our data are better protected in terms that we don't send data outside of the realistically area where they are produced from, right? But we get a much more expensive computing, right? So it's not easy to put those resources on the edge side. So we lose the economies of the scales of the cloud computing. So the general mantra we come about is centralize when you can and distribute when you must at the moment, right? So taking all this into account, there's a couple of applications that are people always mentioning about, identify based on the problems we can solve with the edge computing is what are the envision like a killer applications for this. And it's usually when you say like smart infrastructure, meaning that like your smart vehicle can't make all the decisions itself, even if those new vehicles are really small data centers, and they also can't be connected to one centralized cloud, right? So people are trying to figure out how they can make roads smarter, right? So put the computing resources closer to the cars themselves so that they can synchronize and coordinate and try to tackle these kind of problems, because one vehicle on its own can't make all the decisions. You need to have them networked, and they need to figure out together how to behave on the road. So that's just one of the applications. Large-scale IoT and industrial IoT is another use case. So, all these years we're talking about, the prices of sensors and actuators and all the devices going down, people trying to build the systems with a very, very large number of devices, millions of devices, and even getting even crazier than that. It's really, really not practical to try to connect all these devices to a centralized data center and try to get all the data from those from those devices centrally, right? I mean, today exists these kind of systems. I mean, it's nothing new. So IoT gateways try to do some of these things. This trend is only going into this direction that these gateways will go from small systems to a system that can really run our subset of our cloud infrastructure and can be handled in a similar way. Gaming industry is one of the great examples of latency as well, because milliseconds there literally means life and death, right? in that world. So, for example, telco providers are thinking about how they can put the gaming servers on your street, on the boxes that they already have there, so that you can have quite a different latency requirements and different experience playing in a local environment than you can do today. And as I said, like on the session we saw this morning, you could see actually a couple of real use cases running today in the space of AI and ML spaces. Again, virtual reality, artificial reality could be an interesting use case. Think about that use case in the terms that your device that are producing and consuming that data is not powerful enough to produce to handle all the data. So that's something that people usually refer to as a compute offload. So instead of pushing the data again to the cloud, it could be pushed to a local environment to be produced and consume the results of those of that computing. So finally, in this final part, I would like to talk a little bit about how we can do it. So it's a really new domain. So today what I will try to do is provide some questions and define the challenges and provide a basic theory of the solutions of what we can do. And some of these things are already in the works. So hopefully next time we'll meet, we would be able to go into the details about at least solving some of these challenges. So as I said, in my opinion, the cloud native computing is providing a lot of benefits to try to solve all these challenges, and I'm personally involved into solving some of these things with the Kubernetes, and there are two things for that. So Kubernetes architecture and generally cloud platform architectures are good. There's no need to reinvent it from the scratch. So the basic idea of having the control plane consisting of multiple master nodes and then the worker nodes that actually execute our logic is sound and well. We have a scheduler for those workloads. We have API server that actually informs the nodes to start executing some of these workloads. So I don't see why we would need to redo everything. Some of these things, as we will talk a little bit more about, will need to be redesigned, because some of these components today in Kubernetes are written with the perception of the infinite scale out and local network between the components. So that's the problem. But the general architecture is good. And the other thing is that the Kubernetes and cloud native computing is where the developers are today. So the tools, a lot of tools already exist, and we already are doing what we can to develop our applications in a certain way, and again, there's no better way to do these things. So why not reuse the existing APIs and existing toolings to try to develop all these services? And the only thing that edge computing is really changing is where these services will run and how it will communicate with, between themselves. But the development of the services is generally, and the infrastructure is already here. So, what are the general categorization of the challenges we have for the edge computing, right? I would like to put 3 big categories of challenges to actually execute edge computing. First is the infrastructure, and that is how we're gonna put our compute resources at the edge, right? So how do we actually create our small clusters or nodes outside of the central clusters, and how we create the infrastructure where everything will work, right? Other is the control plane, and that's the job of the a cloud control plane, right? But some things changes, right? So now we maybe have nodes that are running over the bad network, or we have much more hardware constraints there. So nodes that can't run all the components on the node itself that's needed for the workloads to run. So we need to consider some of those aspects as well. And finally is the data plane, and that's the problems we have when we successfully manage to put our workloads on the edge side. So how those microservices running there communicate with the cloud and communicate between themselves, because that's something we don't do enough today, at least in the mainstream with the mainstream technologies, right? So what do we have as an issues for deploying our infrastructure at the edge? First is we have much more resource constraints. Even if you talk about small clusters there's no auto scaling. When you operate in the cloud environment, you have this notion that whenever you need more resources, you can just click the button and you will get more resources provisioned for you, and your applications can scale out. That doesn't happen on the edge. So somebody needs to go there, put a new servers, provision everything, and add more power to the edge side. And it's not just the cost of the computing resource. It's also the question of the skill and the engineers available to do that, right? It's much easier to have a proper engineering handling your data center than your local convenience store, right? I already mentioned network, and that stays. And then we have problems of the physical security of the edge sites. So something running in the central data cloud, you don't need to think about if someone will physically tamper with the hardware, try to install any kind of software on it that shouldn't be there, starting from the operating system all to running the services that will mine bitcoins or things like that. So edge nodes needs a special consideration when it comes to thinking about the physical securing these sites, because those systems are meant to be run unattended. So think about a public infrastructure, or even if it's running in a private premises, in offices and the stores, it's much easier to tamper with. So let's talk a little bit about the services themselves and what's important about when we talk about how we're gonna manage those microservices and what we are going to do to solve some of the issues there. Because as I said, there's a lot of services. There's no infinite resources going on there. So we need to think about a couple of things. First thing is how we are going to deploy those services at the edge locations. So GitOps is becoming a word of the day, and we already have our own developer pipelines and creating a good containerized workloads. One thing that is different is that all these tools that we have today assume some kind of the central registry for all these artifacts of our builds, right? So maybe we need to rethink something around this and see how we can deploy these services and provide patches and updates to the sites that are not connected constantly. One of the interesting use cases that people are mentioning is like imagining the big ships, cargo ships or cruisers that are sailing for days or even weeks and don't have any network in those days, and they only got the network when they dock for a couple of days at some of the ports. So yeah, there's something to think about that this is the window when you actually are able to deploy new services to that site or do the critical updates and patches and get the data from the services back, right? Also, different kind of workloads have different priorities. So imagine running your convenience store or fast food store. There's actually a very good use case of American US fast food chain Chick-fil-A, which are doing this in production today. So if you're interested into that, Google it and find it. It's a really good story. But imagine having a fast food store where you use the same infrastructure at the store to do your to do billing and to charge your customers and use the same infrastructure to do some analytics and send data back to the headquarters. These two workloads are different, definitely having different priorities and impacting the business quite differently. So you need to think about that. What happens when the system comes under the pressure? There needs to be some policies that will say that the high priority workloads needs to contain working, and that you can kick out the lower priority workloads and schedule them to work off hours and when there are actually enough resources to do so. Communication is one of the big issues and big challenges. That's one of my particular area of interest. So imagine having a lot of sites that needs to send data or RPC requests between each other. How you do that securely? One of the main premises is that you want to be as secure as possible. So you don't want to have anybody be able to dial into your system. So all the communication needs to be originated from the system outbound, but you still need to be able to do a duplex communication over those channels. So people are using a lot of VPNs today. We are trying to develop what we are calling virtual application networking, trying to move that communication on the higher level to specifically solve some of these issues for the edge-to-edge and edge-to-cloud computing in a secure way. And as we said, like with the hardware, the security is always a problem. And again, we need to make sure that we are running only the services that are authorized for a single site, single node. We need to track and monitor that there's no unauthorized outbound connections from that site, so to prevent all kind of malicious activity, which is much easier to do in this kind of environment than in the central cloud. So how we can do it today with the tools we have and where we are going with this. One obvious solution, especially for those infrastructure edge and and provider edge use cases is to have a multi-cluster, multi-cloud environment, right? So every node, every site is a separate cloud cluster, and that's okay. And the only thing is that we can only do this when we have enough capacity to do it like this. The other thing is that we need a completely another layer above this to be able to provision these clusters to solve infrastructure problems, to solve control plane problems of how we're going to deploy things on this cluster and monitor what's running where and why, right? Other approach that people are often used today is to try to scale out the one central cluster into the nodes that are not really nodes of that cluster technology. So that's why we have a technology called virtual kubelet, which basically proxies proxies on the server side how the central control plane sees the rest of the system, and you know, it can instruct using the same API server. It can you know, the scheduler and the APIs and everything beyond the API server looks basically the same. So you can say I want to run these services and have these deployments, and the scheduler will do that. But then the virtual cloud, virtual kubelet actually provisions that on the resources it knows about. It doesn't have to be even containerized workload if that's not the case. And finally, something we didn't talk a lot about is trying to have on the complete left spectrum of that edge types, we have device edge, which is not trying to have clusters outside of the core cloud, but having the single control plane and having only the cluster nodes outside of the cluster, right? And with that, we're again getting into the device edge IoT kind of scenarios where people want to have what we have today as an IoT gateways. They want to have those IoT gateways containerized and all the workloads be managed and provisioned like we do it with the Kubernetes in other environments. And for that, we need to be able to run things on very constrained devices, something that we saw this morning, Raspberry Pi, up until recently couldn't even run as a Kubernetes node. So you need to have a special components running on the edge and being able to talk with the control plane and being able to run at least some of those workloads there. So that's what I have as a story today. So I try to bring you the bigger picture where we can see that the industry is going and what's going to happen in the next couple of years. I'm sure we'll go through the multiple hype cycles and booms and busts like it happens with every new shift and new technology. But as you could see, I think even today you can identify a lot of valid use cases for doing this. So as I said, some of these challenges that we presented today have been already discussed and started to being addressed. So hopefully next time we see each other, we can talk into a bit more details about all this. Thank you for joining. Yeah.
If you have any questions, just ask me. I will give you the microphone.
If not, I'll be around. So if you're interested into this topic and want to talk more, just feel free to reach me and have a chat. Thanks again.
Okay, guys. So welcome back. I didn't hear the bell ringing, so I suppose that I will have to shout again for everyone to come in if the doors are open, but they are not. Okay. So no one can hear us outside this room. Yeah, I'm sure they will start coming in. So just announcement that at 5:30 p.m. will be the closing session. So yeah, the time really flies by so fast. We are already talking about closing. I feel like we opened an hour ago. But yeah, nevertheless, so 5:30 here will be the closing session, and then all the sponsors will be giving out the rewards they prepared for you. Okay, so we have the pleasure of hosting Antonis here for the third time in the organization of Heapspace. He spoke previously on Vox Days. He actually works for a food delivery service in Athens, if I'm correct, in Greece for sure, and it's called eFood. We recently had an expansion of those services here. Volt came, Glovo, who delivers everything. We had our own platform called Donesi, or Bring It.
Donesi is also, I think, part of Delivery Hero, which is
really
which has bought also eFood, so part of the same company now.
Yeah, good to hear that. Yeah, we are all connected. So how is the food delivery network in Greece working currently?
So I think Greeks order too much from outside. So I mean, also have a lot of coffee delivery. So Greece is a very good market, I think, for online delivery.
How is your competition over there? I mean, do you improve each other?
I think eFood is one of the leaders. We have also Wolt, which was introduced a few months ago, but I think it's a lot smaller. I mean, I'm not on the business side to see the actual numbers, but from what I understand from friends and family who are ordering from eFood,
you are the best.
No, I mean, our marketing is the best, and hopefully our tech is also good enough.
Yeah, I'm sure it will be. Thank you very much. Okay.
Thank you for hosting me, and thanks to all of you for being up so late after 2 days. I hope you had enough of coffee, and you'll be happy to see the presentation. So in this presentation, I'll try to give some pros and cons of using containers. So although I love containers and I use it every day, I'll try to see and discuss with you if this is a good choice and which are the things that you would need to consider when switching to containers. Before we start, a few things about me. I'm a Docker Captain, which is a program from the company Docker that's similar to the Microsoft MVP, all the other programs that get people from the community and give them more resources in order to do presentations and that kind of stuff. I usually code in Python. I really love it, and I've recently started also doing some development in Go. So I'll try to give examples from other languages too, but excuse me for sticking with my favorite language. As we said before, I'm a senior software engineer at eFood. So I'm mostly on the developer side at this point. But I'm also doing on the side a lot of container training and consulting with my company called Sourceler, with my partner Paris in Athens. My general motto is that I love to automate stuff, so whatever can be automated, I'd like to automate it. So I'm a bit crazy on that end. And I also like to share knowledge, so you might find me speaking often in meetups in Athens, often, or in conferences like this one. What we're going to talk about today, which is the interesting stuff. So first of all, we'll try to see the different deployment options that one has for deploying their applications in their company. Of course, containers will be one of them, but we'll also examine other ones and see all the different pros and cons and how do they operate, what are the costs, the benefits, etc. Then we'll see more specifically about containers, what containers bring into the game, how do they change the game, and why or why not they are better or worse. We'll see some obstacles, because every new technology and every technology adoption has some obstacles, so we'll try to realistically see what challenges we will face when switching to containers. And after that, of course, we'll see all the nice things that containers excel. At the end, provided that the internet permits us, there's a funny little game to see if we understood everything from the presentation, and of course we'll have some time from Q&A. So if you have some questions, feel free to ask them here or grab them later. So let's start with a joke. So as every joke, a container walks into the bar. And okay, I'm not going to bother you with stupid jokes about containers, but I really thought this was a nice intro. And let's see a situation which is a bit more realistic. So let's say that you walk in the morning into the office, and a manager starts saying things, container buzzwords, cloud, and other fun words, and says, okay, you know, we need to do cloud-native things, or containers, or cloud, or whatever. And then you're like, why are you going to do this? And it's like, okay, you know, I went to a CXO conference the other day, and they said that they had 10x the performance by moving to containers. So if we take the application, not change anything, put in containers, it's going to be 10 times better. So your task today is to move everything to containers. And how many of you have faced this or something similar? Is anyone in the room here? I see a few shy hands raising. So this is something that has been greatly heard of. And what I'm trying to do in this presentation is try to see all the realistic reasons for moving to containers, and of course the obstacles and the other things that are not. So this is a comic strip. It circulates the internet. Hopefully I'm allowed to put it here, but we'll see that later. So let's start by examining the different deployment targets and how can one deploy their applications if they want to. So one separations that I like to make at the beginning is on the infrastructure level. So let's say that the provider, a company, provides us with infrastructure. This could be either bare metal, so actual servers, or infrastructure as a service, as you call it, or the cloud, or whatever you might have heard of it. So something that is more managed, but still infrastructure, so still machines, still either virtual machines or physical machines. And there's a top level, high level level, which is the application level. And this includes platforms like Heroku, so platforms as a service, where you don't have full control over how your application is going to run. And the company that provides you this application level infrastructure is responsible for running it for you. The first one, as we call them the bare metal, can be things like Hetzner or TopHost or other bare metal providers that you might have heard of. And usually in these cases, the infrastructure is being managed by a human being. So there's a human connecting machines with each other or putting physical machines into racks. So when you want to deploy new servers into this infrastructure, then you have to make a ticket, for example. Someone has to go into the data center and put a machine into a new rack. Usually, but not always, in these cases, there's no virtualization involved. So your application is not running in virtual machines or virtual servers. It's running on actual physical machines, bare metal servers. On the contrary, which was the introduction of the cloud, they said, okay, you know, companies should start stopping using this infrastructure and relying on slow processes in order to deploy new machines and new physical servers. And they proposed an alternative, which was the infrastructure as a service model. So you have companies like Google Cloud, AWS, Azure, DigitalOcean, Scaleway, or whatever you want to call it. So there are many different companies providing infrastructure on that level, that in this case, the infrastructure can be automated. So you go and click a button, or you make an API call, and something gets done and returns immediately, or semi-immediately in real time. So in this case, the infrastructure can be automated because you can have programs orchestrating the whole infrastructure provisioning for you. And usually there's virtualization involved. So in these cases, when you want to deploy a new server, this server is usually a virtual machine that's running somewhere in a cloud of this company. I'm saying usually because, for example, there are companies like Scaleway that are providing bare metal servers, but with the infrastructure as a service model. So, for example, they have bare metal servers running your application, but might have virtualization for connecting those servers together. So the network, for example, is virtualized. All these things provide different flexibility and different, let's say, guarantees on the infrastructure. So, for example, bare metal servers are usually more cheap, but on the contrary, bare metal servers do not provide as much guarantees about reliability and uptime as virtual machines. So, for example, if your actual physical host running your bare metal server dies, then there are no good solutions about moving this machine to another one. There's many manual steps that need to be made in order to do this. On the infrastructure as a service offering, you might have sometimes you can have machine restarts without the application noticing the actual restart. So your VM might be hot moved to another server without you realizing this change. So everything happens on a different level. So actual hardware failures do not mean 100% of the times failures in your application and your servers. Of course, bare metal servers are harder for you to operate and give you some good options, and cloud gives you some other options with other, for example, costs or other things to consider. So in this paradigm, then we go to application level, which is something that you've heard maybe more times recently, and especially in the conference. You have more classic platforms as a service. So for example, you have things like Heroku, Google App Engine, and that kind of stuff, where you deploy your application, you just send your code, and then your code gets packaged or whatever, and you don't know what actually happens. There's a magic step there, and it starts running, so you don't have absolute control over what you are going to do. And usually this is using pre-baked environments. So you cannot choose all the different libraries you are going to put in your application, or you are not going to say, okay, you know, I want to run this application alongside the worker, because platform as a service clearly defines how is this being made. The evolution of platform as a service is what we try to call serverless, but wait for it, because there's a catch. There are servers involved in serverless. I don't know who knew that. Okay, many of you. That's good. So in serverless, the shifting paradigm says that you don't care about your service. So this is the actual thing. You don't care about if you need like 1, 2, 3, or 1,000 servers for running your application, while in the platform as a service, you had control over the different instances running. Also, a big change is that if your application is not running, if your application is not in use, it's not running, meaning that you don't pay for your application when it's not up and running, and you pay a lot more if your application runs a lot in parallel. So all these different deployment levels gives us different perspectives on how we are going to manage our infrastructure and the infrastructure that application runs. But where do containers fit into the whole picture? And what are actually containers? So let's go a step back and see what is a container and how a container can actually fit into the whole picture of the different infrastructure types that we saw before. So the first thing is that a container is actually a simple process. So a container is not a virtual machine, it's not a different physical server, it's just a process running inside a machine. So there's no actual difference between me running Python myfile.py and running an application and running this application inside the container. All the changes are in two very important tools that we are using in order to make our application think that it's virtualized. So we take this process, this application running, and then we use two tools. The first one is namespaces. Anyone heard of namespaces before? A few of you. So namespaces allow us, it's a kernel feature actually, and allows us to wrap the application around a virtual world. So the application thinks that it's in a different world when running inside namespaces. So for example, we have the network namespace. This means that I have my own virtual Ethernet, my own virtual network card, and I can bind to any port of it I want as a container, as an application. And this does not have anything to do with the application or the container running next to me. So I have my own world with my network, and I have my own virtual Ethernet card, and this is the network namespace. Another namespace is the file system namespace. So in the file system namespace, I can run a completely different Linux distribution from the container running next to me. So let's say that we have a Python application running on Ubuntu, which is a Linux distribution with Python version 3.7, and an application running next to it with, for example, Alpine, which is another Linux distribution, and Node version, whatever is the latest one, because I don't write Node and I don't know. So these two applications can have their own different file system, their different root, the different binaries and everything, and they don't have to mix this together, so they are completely isolated. So that's the first kernel tool that we use. So you can have different applications with different requirements running one side by side with another. The next one is called C groups or control groups, and this tool allows us to actually limit the resources that the application uses. So let's say that we have a big machine, okay? So let's say that we have a machine with, 64 gigabytes of memory and 16 cores of CPU. We don't want one malbehaving application to take the whole resources of the machine. We want to have each application running in its own contained environment. So we're using C groups, and for example, the CPU C group that says that even though we have 16 cores in this machine, this application is going to use only one of the cores. So using the C group of CPU, we can make sure that one application will not take the CPU of the machine alone. Also, the memory C group, for example, which is another one, we can use it and say, you know, you cannot take all the RAM of the machine. So, for example, if the application has a memory leak, it will start growing in memory up to a point, up to the limit that we have imposed with C groups. So, as you might start to understand, not depending if we use bare metal servers, infrastructure as a service, containers, or whatever, it all comes down to actually managing CPU and RAM. So all these different tools and all these different infrastructures and infrastructure services are actually a way for us to get some CPU and some RAM in some form and give it to our applications to run. So in the first scenario, for example, we have the bare metal infrastructure on the bottom, which is in blue. Then we have a supervisor. Then we have 3 different virtual machines running one for each one application. So this is the infrastructure as a service model that we saw before. So in this model, we have 3 different kernels running and 3 different applications. So we have to virtualize everything for each and one of these VMs. Containers, the only thing that they change if we just use containers on these virtual machines in the same infrastructure is actually, instead of having 3 different versions of the kernel, having just one and sharing all those resources with the applications and running on the side of them Docker or another container runtime like containerd or whatever you want to use. And this runtime is going to manage all the different applications and using namespaces, C groups, and all the other tools that containers use, make sure that these applications are constrained within the boundaries. So the same thing that we can use VMs to have is the same thing that we can also do with containers with different semantics. Of course, when containers started, we had another, let's say, hype, which said, okay, you know, we're going to run bare metal containers. And bare metal containers were nothing more than removing the supervisor, so not running everything inside VM. So let's have having a bare metal server, having a VM inside it, and then inside the VM run containers, but removing the virtual machine altogether and running the containers on the bare metal server. But this has other problems that VMs try to solve. So VMs try to solve cutting big servers into smaller pieces and managing them and moving them easily. And then you throw this away for having containers run on bare metal and have a small improvement in CPU and memory. So I wouldn't say that bare metal containers is something that really kicked off. But it was something that, oh, you know, if we have containers, we can run them on bare metal and we can have bare metal speed. That's not quite true because, for example, we have paravirtualized drivers which run on virtual machines and allow applications running inside those machines to actually get directed to the actual CPU and memory. So the speed reduction is very, very small for moving to bare metal. Another really important thing that containers introduced into play, apart from the management of the CPU and the RAM, which was done in the way that we saw before, was a packaging format. And I would say that this is one of the most important things that Docker and containers introduced, because the packaging format is one of the things that we use currently and we see being adopted a lot. And by packaging format, I mean that we can now package our application into something which we call Docker images, for example, and send that something, that unit of deployment, to our operations team to run it. So let's say that on previous, before containers, we had, for example, Java and other applications like Java, where you said, okay, this is my code, this is my application, and then the application was packaged using Java tools into jar or WAR files, and then those WAR files or jar files were sent to the operations team and were deployed to the actual production cluster. So in this case, we had the Java virtual machine, which was something standing below the application that knew how to interpret the code, the bytecode of Java, and run actual instructions to the machine. And this gave you some guarantees that the same instructions running on production machine will be the same that running on the developer machine, and the application will behave in the exact same way. The only thing that we couldn't make sure in such a case was that if the application required some system libraries that could not be packaged inside a jar file, then those packages should be communicated between the developers and the operations. And say, okay, you know, I need this new SSL library version, and you must install it on the production machine. And then the operations had to go to the production machine and install this new version of the library. So in another sense, you can think of Docker files and all these packages being format, because Docker files can also include the system libraries and everything. You can think of it as the API, the communication layer between two different teams. So one team can be responsible for running Docker images. It doesn't care if these images are Java, Go, Python, Node, or whatever, as long as they are packaged as Docker files and Docker images. And the developers on the other side can use those Docker images and produce them in order to deploy their service into production. So the packaging format of containers and Docker images specifically, I believe it's very important because it was the thing that was easy to communicate all those dependencies between two different teams. Let's see now that we talked about containers, how do they come into play and how we can use them in the infrastructure level or the application level. So first of all, on the infrastructure level, you can deploy containers using a container orchestration. So let's say that you have a bunch of machines in your production cluster. Let's say that you have 9 of them. And this actually is a combined CPU and RAM as the resources. So you stop seeing each and every one of those machines as a single machine, but you watch them as a whole cluster. So this cluster, you can use a software called an orchestrator, which can be either Docker Swarm or Kubernetes or Mesos or whatever you want to use for your production cluster. And then instead of go and manage one application on each and every one of those machines, you just say to the orchestrator, I want to run this application, and the orchestrator goes on and runs it. So the orchestrator is the one that's watching over your cluster at all times and goes and makes sure that everything happens as you want. Also, you can go a step further and create what we call a containers as a service platform. So those platforms try to imitate what was platforms as a service in like the previous examples, and try to give platforms as a service inside this company. So containers as a service could be platforms like, for example, Docker Enterprise or OpenShift from Red Hat or whatever enterprise Kubernetes offering you want to use. And all those platforms actually try to abstract all those different bits and pieces that one should use in order to use an orchestrator and give you a higher level of abstraction. On the other end, on the application level side, then you have your application quite possibly running in containers already. So if you don't know how your application runs, it probably runs in containers. For example, Heroku, which was happening long before Docker introduced containers to the world, like us, was running containers in production. So when you deploy an application in Heroku, which is a platform as a service offering, then your application runs in production. Google runs a lot of their software in containers. So believe it or not, much of the code that you use for C groups is written by Google like 10 or 15 years ago. So it's something as a technology that existed long before Docker and containers, but Docker was the one that made containers available to developers with an easy CLI and an easy developer experience. It's not something that Docker created, actually. Also, when you use application level infrastructure like serverless or platforms as a service, now you most probably can use Docker images as a deployment unit. This means that you can build your Docker image with everything you want to package, and instead of running on a pre-baked environment, you can actually create your own environment to run it. So knowing how to create Docker images is really important if you want to use one of those platforms and be able to customize it to your needs. Now, when you deploy containers in any of those cases, it doesn't mean that it solves all your problems. It doesn't mean that your application is going to be faster or more resilient or anything. Actually, containers do not solve your problems, and this is really important to take a note. So containers are actually a tool that helps you, but not a tool that we are going to say, okay, you know, enable containers, everything is going fine now. Actually, Kelsey Hightower, which is a developer advocate for Google, and one of the most respected advocates in the space for containers, said that, you know, you cannot just take, for example, a MySQL database, put it in containers, make it distributed, and then you have something like RDS, which is a distributed database with MySQL semantics from AWS. So it's not easy to create a managed service like RDS, which has resiliency, which is distributed, and which you can actually make sure, not make sure, but be sure that your data is always going to be safe. It's not easy like that. You need a necessary team to manage your infrastructure. You need people who know about database to make this database distributed. It's not like because you're using containers or orchestrators or whatever that your application is going to be more resilient and more secure. What actually containers do is that they transform your problems. So if you remember from math or from school, when you had a very difficult problem, you use some tools, some theorems, in order to transform a problem into other, more simpler ones, then solve those simpler ones, and then have a solution for the initial problem. That you can think containers as of a tool that can do the same thing about your infrastructure. If you are having some very hard problems that you cannot use with your current tools, you can transform your problems and introduce new ones, but those new ones will hopefully be easier to solve, and that's why you're going to solve your problems for your infrastructure. It's not like a magic button that you can press and everything is going to be solved. So moving to containers introduces some problems that probably you didn't have before. So, for example, when you start running applications in containers, you don't know where your applications are running. As we said before, in containers, you usually take a cluster, so a bunch of machines, and then you say to the orchestrator, to the software managing that cluster, start running my application 2, 3, 5 times, and that application and the other one. So instead of knowing that, machine 1 and 2 running my web server, machine 3 runs my database, machine 5 to 7 runs my workers, and then go into each one of those machines and troubleshoot and see what's going badly, you can't do it anymore, and now you need other tools in order to understand what's happening in your infrastructure. So containers introduce, as we said, new problems because you don't know what's running. The second big problem that you introduce with containers is that you need a way to network all those containers. So let's say that your container running somewhere in the cluster needs to talk to the database running somewhere else. This container cannot have a static IP, for example, for your database machine as you used to have before, because in this way, this container might change, might stop and start a new one, and this will get a new IP, and the old IP will be invalid. So you need a way to constantly network those containers in a consistent way. This is being done usually with overlay networks, so with networks which work on the software level on top of the actual networking that happens between your virtual machines or your hardware. And these networks have ways and semantics in order to consistently talk between containers. But this is another complex software that you put in your stack, and you have to know how to manage it. Of course, I'm talking about stateful applications, and stateful applications is a completely different beast to tame when you're talking about containers. So stateful applications introduce many different problems, like, for example, you need to synchronize where your container is going to spawn and make sure that the data is moved to the same container, because your database is nothing without the actual data backing it. Also, those containers cannot scale and scale out and in without a problem, because you cannot have like 3 MySQL databases and that's it. You need to coordinate between them. You need to assign roles, for example, masters and followers and all that kind of stuff. Of course, since you don't know what's happening in there, you need new monitoring solutions. So you need solutions to make sure that you understand what's happening in your cluster. You understand which applications are malfunctioning, which are taking more CPU and RAM than expected, which applications are talking to which other application inside the cluster, and if some connection has a problem and is being delayed, for example. This might not be a problem with your application. This might be even a problem with the overlay networks. So you need tools and solutions to make sure that you understand what's happening there. And last but definitely not least, if you have applications that are have super strict security precautions, then you might not want to run those applications inside the containers because you want to separate them in different VMs. Of course, container isolation is very good, but it's not as good as VMs. In the same way that VMs are not as good isolation as having completely different physical hardware running the applications. So if you're running two applications side by side and one does not have very good security because it's like your marketing website that you deployed recently to have a new campaign, and the other one has healthcare data for your people there, and an attacker manages to gain root access control, for example, in the application that is the marketing website, then this attacker might have also access to the other containers running in the same host. So it's really important to understand that you have to separate your applications, and if you have super secure applications that you don't want by any means to being tasked from outside visitors, you have either to separate your clusters into groups, for example, secure applications, marketing applications, whatever, or you have to run those applications in completely different VMs. So it's really important to have this in mind when moving to containers. But enough with all the bad things. Let's tear up a bit and see all the good things that containers bring into the game and why you might want to move into containers. So first of all, your current problems might be even harder to solve than the problems introduced by containers. So let's say that the business needs are changing or the application is changing, and then your current solutions are not good enough, and re-architecting your solutions for the new requirements is not as easy as you thought. And then in this case, you might want to consider containers as an alternative because it's going to solve you some of the problems, introduce some new ones, but those new ones are not as hard as the current ones, so you're fine with it. Also, the architecture of the application might change a lot. Like, for example, you go and you split your application to multiple services. So instead of having like 2 or 3 or 5 applications, now you have 40. And 40 applications are not easy to manage in a one-by-one basis on VMs, and you want to try a new solution. Or you might want to have a lot of helper services running into containers. So all the new services go there, but the old infrastructure continues working as is. So it's not like you have to completely transform your infrastructure into containers. You can just choose and pick the application that makes sense for you. Another problem that we see often with customers that we go for training or consulting is that they have very slow pipelines, and those pipelines are really hard to change because they have many either manual steps or things that, for example, VMs are slow to build, or they don't have these communication layers between developers and operations, and they need a way to go faster and give more responsibility to the actual developers so they can package the applications in a better way. Then this might be a good idea for moving into containers. And of course, the most important thing for developers is that you want to ride the hype. Containers is something new. You want to change it. You want to play with it. I mean, all of us, by the end of the day, want to play with new things. We want to tinker. That's why we are engineers and we want to play with things. So you might want to try containers for something new. So that's completely fair. But given that you consider the implications, then you can move to containers just for play and just for fun. Some of the things that containers really excel is that, first of all, it's really easy to make your deployment pipeline faster. So it's faster to build Docker images, it's faster to transfer those images to a production cluster, and it's faster to roll forward or backward to a different version of your application. Also, it's easy because you can easily describe your high-level architecture as code. So it's really handy because there are many tools, and because there are many tools in the stack that are software-defined, like the networks and that kind of stuff. So it's easy to define all those tools on your code and put this inside the repository. It's really important to have all these definitions inside the GitHub, for example, or the source code repository that you have for your code, because then you can track all those changes and the evolution of your application. Also, by using containers, you have a better bridge between developers and operations, and you give more power to the developers. But beware, because with great power comes great responsibility. So by giving a lot of power to developers, you allow them to make mistakes, and you have to have a pipeline that takes care of it. And you have, for example, good code review. You have some steps that make sure that the application is not crashing, and you have tests, CI, CD, and that kind of stuff. Also, another side effect is that because containers are very cheap and easy to run on your local machine, you can easily replicate this environment between your development, your test or CI, and your production infrastructure. So the same container runs on your developer machine while you're coding and developing your application. The same one goes and tests your applications on your CI, and the same one can be deployed to production, which is a very nice plus when using containers. So some of the questions that you should ask yourself when you want to make an infrastructure switch, and this is one of the processes that we work with customers when they want to do something completely different, is that you have to consider the cost of people for managing all those infrastructures and the cost of managed services. For example, let's say that you are currently on Heroku, which is more expensive than buying virtual machines, for example. And you say, okay, do I want to make the investment and pay more the people and less the actual platform? Because my infrastructure changes. Do I have the people? Do I have the skill set? So it's not like, okay, you know, AWS is cheaper than Heroku, so I'll go to AWS. AWS has a completely different guarantee for you. It says, okay, the machine is going to run. If your application runs, no one cares. If your application wants to scale, then you have to scale the machines. You have to plan for that. Also, another very good factor in those cases is the infrastructure variance. So let's say that you have an application like a food delivery service, for example, that's usually very heavy in the morning where people are ordering coffee, and in the noon and evening when people order food. But it's not as intensive in the night, for example, because usually people sleep in the night. So in that case, you want to make sure that your infrastructure can scale out and scale in dynamically during the day. Or you might have something like an online shop, which is really intensive during Christmas because people like to buy gifts during Christmas, but it's not so intensive during summer. So you have to make sure that all these different cases are handled by your infrastructure. And also, product stage is really important, and you're planning for the next years. So if you're a small company building an MVP and you want to have it yesterday, then maybe it's not a good idea to invest in infrastructure because you want to invest in the code and actually build the product that the end users, that your customers are going to use. But if you're a company which is more stable and you want to plan for the next, 3 to 5 years, maybe you want to buy some VMs, or you want to scale your infrastructure or invest in the team that's going to manage the infrastructure, because in 5 years' time, then this investment is going to pay off. So it's not like an easy choice. It's not like there's always a solution. It's like either VMs or containers, or bare metal or infrastructure as a service, or PaaS or serverless. Every different application has its own needs, and you need to consider all those different options and make sure that the one you choose is the best for you. And the best for you is the infrastructure that's actually best for your people, because the people in the company are the ones that are most affected by the infrastructure. It's not like, you know, I want yesterday a cluster, and you have to make it because you are an ops. No, it's not that easy. And you also have to consider all your business needs, because the people that run the company, the actual developers and the operations, and your end users and customers are the ones that are most important for your business, and these are the ones that have the final say on your infrastructure. Now, before we finish the session, let's play a little game and see if we understood everything that was in the presentation, and hopefully we'll have some time for questions. So go to kahoot.it and then use this code, and hopefully you're going to be presented with a screen for for the game to play. And the winner gets those 3 pins, because I thought of the game today and it was the only thing that I had that wasn't part of the conference. So I'm going to switch. Okay, we have some people coming in. So you go to kahoot.it with your phone. Hopefully the internet is good enough and you use this code to play. And the one with the faster internet will win. Okay, I'll give you 20 more seconds and then we'll start. Oh, too many people. I was afraid that I was going to be alone in this game, but thank you for participating. Okay, 10. Okay, let's start. So all the questions are true, false, and the question is, you moved containers when? So you have to see what says here and answer it true or false. Your boss comes after attending a CXO conference and tells you to move everything to Kubernetes. You go to Kubernetes or not? Okay, answers coming in. Oh, false, okay. Okay, Nemanja is the faster one. Sorry if I'm pronouncing it wrong. You've heard of a great tool that will solve one of your minor problems. You go to containers or not? Answers coming in. Okay. Nemanja, still on the top. Jay is second, but he's very close, or she's very close. Your current architecture is keeping you from shipping new features quickly. Do you go to containers or not? Forty-four answers. Oh, okay, so that was true. Let's go to the next one. Oh, Jay was faster now. True or false? Your customers demand for your product solution to be cloud native. You go to containers or not? You're pretty fast. Maybe you're most from Belgrade and you have 4G, that's why. Oh, okay, so that was not, maybe that was a puzzle question, but the correct one was false. You don't listen to your customers always. Oh, Salix, you have a new first. And the last question, your microservices are small enough, making it cost effective to boot whole VMs for them. You move to containers or not? Okay, that was correct. So you moved to containers. So what was trying to... Oh, okay, let's see who's the winner, sorry. Blagos, sorry. It's you? Congratulations. Okay, so find me afterwards to give you the pins. So the idea of the whole game was to tell you that it's not like random factors that make you choose a different infrastructure. It's actual things that matter to you in your day-to-day basis that do it. So thanks a lot. I'm Antonis. You can find me on Twitter or you can tweet using the hashtag of the conference. And I would be really happy to have a few questions. We have 3.5 minutes. That's great. And also, of course, if we don't have time, I'll be happy to talk with you afterwards. So any questions? Don't see. No questions? One question. So the question is, should we move to containers? And I think the answer is, I don't know. Maybe you know better than me, because it's your specific use case. Sorry if it wasn't the answer you were hoping for. Another one? No questions. But you were pretty good with the game, so maybe you understood everything. That's why you have no questions. Anyway, thanks a lot, guys.
was too warm.
Hello, hello. Okay.
Yeah, I think we can gently start this final session. Hi everyone, welcome back. So yeah, like I said, it's a final session of this year's Heapcon. Do stay after for the closing ceremony. We will have some beautiful rewards to give out by our sponsors. Sumit Gulwani is here from Microsoft. He will be talking about a new paradigm called programming by examples. He's also founder and leader of PROS research and engineering team over at Microsoft. Can you tell us more about the PROS team? What do you guys do over there?
So it's a team that is diverse in two aspects. One is the technical expertise that we have within the team, which ranges from machine learning, programming languages, software engineering, human-computer interaction. And also it's a team that is diverse in roles. So we have not only researchers in the team, but also engineers, program managers, user experience designers. And we also work very closely with customers, whom we also think are part of the team sometimes.
Yeah. It's a brilliant background and brilliant topic to close this conference. Thank you very much, Sumit.
Thanks. Hello, everyone. 10 years ago, I was returning home from a conference in Germany, flying from Frankfurt to Seattle. And there was a lady sitting next to me in the airplane. She was very impressed to know that I have a PhD in computer science and that I work for Microsoft Research. So I ought to help her with the task that she was struggling with. She opens up her laptop, fires up Excel, shows me a column of strings in the form first name space last name, and asks me how can she transform it into a different format, last name comma first name. At that time, I had no idea about the programming model underneath Excel. So I had to excuse myself out of the situation. But after I got back home, I tried to look for a solution to that problem. And it is then that I realized that there were many, many people like the airplane lady who were struggling with simple repetitive tasks like what she was struggling with. And here is how a typical interaction would go on a help forum. An end user would ask the expert to give them a program that can transform this string on the left side of the arrow to the string on the right side. The expert takes a look at this input-output example and sends back a program that can extract the first two characters starting at the fifth one. the end user takes this program and runs it on other inputs that he has and figures out that it does not do the right job on another input that they have in the spreadsheet. So they send a second input-output example pair to the user, or to the expert. So what do you think is the end user trying to accomplish here? Yes, so extract the sequence of characters between the first two occurrences of the underscore. How many of you know how to accomplish this using the APIs that Excel provides? This is one of the simplest programs that would work. The end user takes this program and runs it on their spreadsheet and is happy with the results and sends a thank you note to the expert. This interaction takes place over a course of a few days. And this inspired me to develop a technology that can play the role of the expert on the help forum, reducing this interaction to a few seconds. So let me show you a demo of this flash fill feature that has been in Excel since 2013 onwards. So here I have a collection of numbers. Suppose I want to format them by inserting hyphens and by masking off a few digits, as you see in the second column. If there are hundreds and thousands of rows, then doing it manually would be very cumbersome. A principled way to do this would be to write an Excel formula. But 99% people who use computers, who use spreadsheets, would get stuck because they would not be able to program these kinds of tasks. So now, you can simply provide an example of what you want and press Ctrl-E to fire this feature. So the underlying technology takes a look at this input-output example that you provided, generalizes it into a program, and executes that program to automate the task for you. The Excel team did quite a good job at avoiding the so-called discoverability issue. So suppose you don't know that this feature exists, and you're trying to do a repetitive task. The moment you do the second instance, the system auto-fires. It realizes that you have a repetitive intent in mind, and that you're not trying to create an arbitrary column, but the column that you're trying to create is a derivation of some input column. And you can simply press enter to accept the results. Now in general, it is too good to read the mind of the user from just one example, as this scenario would illustrate. Here I have a bunch of medical billing codes, some of which have a right bracket at the end and some of which don't. Suppose you want to clean the data by adding a right bracket wherever it is missing. So if you give one example, and another way to fire flash fill is to go to the data tab and click flash fill. The system comes up with the simplest generalization, which is to add a right bracket everywhere. Maybe this is what you want, and you are done. Otherwise, you will observe that rows 6 to 10 are incorrect. And you can fix any one of these, which is like giving a second input-output example to the tool. And now the tool can converge to the intent that you have in mind. You can use it to extract different fields from large strings. Even if you're a programmer, thinking about the logic will take a lot of time. And now all that you have to do is to give an example and press Ctrl-E. The tool can synthesize quite complicated scripts, in particular scripts that contain loops. So here I'm iterating over the input string to generate an abbreviation, and one example suffices. So you can do lowercase, you can put periods, you may not have spaces, you can do in reverse order, and it will all mostly work. So flash fill is a very popular feature. There are around 1 million invocations of it in a week. Now, while I have been trying to impress you on the different kinds of tasks that flash fill can handle in the space of string transformations, there are many, many tasks that it cannot handle. For instance, number transformations or date transformations. But the user experience is so inviting that it doesn't prevent people from trying it on tasks that it was never meant for. And then when it does not work, people get disappointed and make fun of this feature. So recently there was a tweet on October 2018, October 2018, where someone made fun of the flash fill feature and said, look, AI is going to take over the world, but this is what Excel auto-populated for me today, where someone gave an example to map DEC to December, and then the system auto-completes JAN to January and OCT to October. In fact, some people even came to the rescue of this feature by saying, this is how months should be named in the first place. But the best thing about this kind of customer feedback is that it tells us about the new domains that we ought to develop these program synthesis capabilities for. And this is what we have done in the new FlashFill++ feature that we have. So now we can automate transformations that are more than string transformations, such as number transformations. Even for a task as simple as rounding of a number, if you have to program this in Excel or C#, you need to remember this format descriptor. In Python or C, it's something else. In Java, yet something else. But again, examples can be a very natural way for you to specify your intent. And from a couple of examples, we can automatically discover these format descriptors and automate the task for the user. Here is another scenario which might be common in data science, where I have a string in the input column, and I would like to extract the red date and map it to the corresponding weekday, and extract the green time and bucketize it into a 3-hour time bucket. Just imagine how much code you will need to have to write in order to map the input to the output. But these kinds of tasks we can now enable with just one example. Now, besides map operations, what else can we enable with programming by examples? How about filter operations? So here is an assignment taken from a popular data science class, where the instructor challenges the students to take this custom text file and extract tabular data out of it, or CSV data out of it. The instructor provides the students a script to build on top of. Now let me show you how a programming by example experience might look like for this scenario. So I've loaded the same file here, and all that I need to do is to give 1 or 2 examples of the various fields that I'm interested in extracting. So let's say I want to extract the championship name, and the moment I provide 2 examples, the system generalizes it into a script and executes it on the data set to extract other instances of this field. In order to extract a different field, I simply change the color of the label. And now 1 example suffices, because my previous interaction is starting to put some structure on the document. Now, this kind of interaction can be used to extract structured data from different kinds of semi-structured documents. Instead of a text file, we can even have a JSON document, or a web page, or even a PDF document. Let me make a similar case for extracting data from semi-structured spreadsheets. So let's say you have a table like this, which you would like to reformat into a more structured form, as you see on the right side. And again, if there are lots of such entries, then doing it manually would be very cumbersome. And writing a one-off script to automate the task may not be very exciting. But this is again a scenario that can be automated from just few examples of rows in the output table. And the reason why this is very significant is because 50% spreadsheets are semi-structured. Think of large financial spreadsheets with lots of subheaders, white spaces, colors, formatting. In fact, some consulting companies hire hundreds of people to manually normalize these kinds of spreadsheets. So let me show you how an experience based upon programming by example might look like for this. So what I have here is the list of top cited authors for the conference Popl 2015. And then a similar list repeats itself for many different editions of this conference. Suppose I want to figure out who is the most cited author across all of these conference editions. So if all of this data was in a proper structured tabular format, then I can write a SQL query, or I can use our programming by natural language technologies to be able to answer these questions. But unfortunately, this data is locked up in a semi-structured format. But no worries, we can use our programming by example technologies to automate this task of extracting structured data out of it. So now I'm telling my tool that I want to create an output table with 3 columns. The names of these columns don't matter. And all that I need to do is to give examples of various entries that should go in this output table. So this is one example of a tuple. And then I will provide another example from down below to make it more representative to the tool as to what I'm trying to do. And now from a couple of examples, the system is able to generalize my intent and extract other such tuples from the spreadsheet. Now let's take a look at how these different technologies work. So at the heart of each of these different program synthesizers that I showed you, string transformations, date transformations, number transformations, extracting tables from log files, extracting tables from web pages, extracting tables from semi-structured documents. Underneath each of these systems, there is a search engine which maps the user-provided examples to a program. And it searches for a program in an underlying programming language. Now, these are not the programs that are in some database, but these are programs that are defined mathematically by an underlying programming language. The challenge with searching for programs in a general purpose programming language is that the programming language is huge and the search won't be scalable. So the first idea that we use is to restrict the search to an underlying domain-specific language, which provides the right set of abstractions to accomplish tasks in that domain. For instance, the domain-specific language underneath flash fill consists of operators like substring, concatenate, regular expressions. Now, searching for programs in this domain-specific language isn't easy either. It's simpler than searching for programs in a general-purpose programming language, but it is still quite challenging. And the Excel team wasn't willing to ship flash fill unless we made the performance of this synthesizer to be under 1 second and more like 0.1 second. So to do that efficient search, we leverage logical reasoning. In fact, properties of the various operators in this domain-specific language to make the search much more efficient. It is very much like a backpropagation over the domain-specific language, where we push the examples down the structure of the grammar using the inverse semantics of the various operators in this language. And then the paths that remain describe the valid set of programs that are consistent with the examples that the user provided. We also use various heuristics to make this search more efficient by guessing the right choices during the search process. But then what you get out of this is not one program, a set of programs, each of which is consistent with the examples that the user provided. So the second aspect inside the underlying engines is that of a program ranker. So we need to rank these programs and then pick the top ranked program for automating the task for the user. So the first version of FlashFill that I developed used to take 3 to 4 examples per scenario. But the Excel team told me that if you don't make it work with one example for most simple tasks, then we cannot really ship this, because otherwise people are going to make fun of this technology like you see this tweet. So we ended up developing an interesting set of techniques to be able to rank these programs based upon various program features. So programs that are smaller, simpler, use fewer constants are more preferred ones. We also use features of the outputs that these programs generate. So let me just show you a demo of how good the ranking scheme inside FlashFill is. So here I have a bunch of names. If I want to extract the first character, I just give one example. What do you think I'm trying to do in this column? first 2 characters, and here it is first 3 characters. So each invocation of Flashfill is independent and doesn't take care of the history. So if you didn't watch me doing these other things, what is your most reasonable guess? What am I trying to do in this column? The first word, right? The first name, and not the first 4 characters. And this is exactly what the system thinks. But if you really want the first 4 characters, you give one more example, and then the system will do it for you. My favorite is this one, where I'm trying to compute initials. And the system is smart enough from just one example to realize that the lowercase f in j.f. is a lowercasing of the capital F in the last name, and not coming from the lowercase f's that are there inside the first name. And then in some cases, it is also important to provide some debuggable experiences to the user and help them identify the various corner cases that exist inside their data set. And this is often made possible by the presence of other inputs that are available on which the user might want to run these programs, and the fact that we have not produced one program but many programs. So for instance, if the system produces, let's say, 2 different programs, which are each of which is highly ranked, we can execute both these programs on the remaining inputs that the user has in parallel. And if they happen to give the same result, it doesn't really matter which program you pick. But if they give different results, that's a signal that there might be some ambiguity or corner cases that can then be surfaced to the user. And then we can even use other clustering kinds of techniques on inputs and outputs to identify such corner cases. So this helps the user to provide more examples, and then the process can be repeated and concluded with getting an intended program in the underlying domain-specific language. So let me show you an experience around this disambiguation utility. So recall this demo where I was trying to extract tabular structure out of a log file. Now let's say I want to extract the scores. So if I give one example, the system gets it wrong in the 3rd record and some other records as well. So I can give one more example and fix it, and it will work. But what if this error was somewhere in the middle of your document, middle of your big document? If you are a programmer and programming this task yourself, you might not even realize that these mistakes have been made, and you might end up computing wrong results. But in this world, we can do better. Here, we are not committing to a specific program. We're actually programming by intent. So we have synthesized multiple programs that we can leverage to figure out where the ambiguities are. So if you go to the disambiguation tab, it actually highlights this 3rd record and asks you, do you want a different choice instead? So I almost want this, but without the leading space. So I'll give one more example. And now the system is able to correctly extract all these scores for me. Next, I'm going to talk about 3 innovations on top of this architecture, where the user is going to specify even less and get something that is even more than what the user gets here. So let's see what less can we specify than examples, and what more can we get than an intended program in the domain-specific language. So there are tasks that people might not even realize are programmable tasks. For instance, you might have a Word document, and you might want to convert all red text into, let's say, green text. Or there might be cases where someone might do a task once, and only after doing it once, when they come across a second instance, then they realize, oh, it's a repetitive task. For instance, you might receive an email with a PDF attachment. Your goal might be to take each line item inside the PDF attachment and put it in your CRM system. But then a week down the line, you receive another such email, and so forth. Now, these are the cases where it will be good to have a system that non-intrusively watches what you're doing. And the moment it figures out a couple of patterns, repetitive patterns, then it can automatically make suggestions for automating other instances of that kind of task. So let me show you a demo of this modeless synthesis capability in the context of repetitive code editing inside your IDE. So here I have some code inside Visual Studio that has different expressions for temperature conversion. So let's say I want to now replace these expressions by a new library routines that I have written for temperature conversions. So I'm converting F to C. And then I go and delete the rest of the expression. Then I'm trying to find where else in my code there are such patterns. Aha, I find one more. Here I'll maybe first delete. And then introduce the operator. And the moment I do this, so look at the bottom. The underlying engine is watching what I'm trying to do, and I could have done that in any kind of order. I could have done other kinds of edits in between. But it will learn from these noisy traces that there are other instances which I need to fix. And if I go to those, it provides me the right suggestion, which I can then accept and get the fix that I intended. So as I mentioned to you, when I worked on flash fill, the Excel team told me that unless I make the system work with one example in many simple cases, they will not ship flash fill. Recently, I was challenged to make this even better. So how much better can you make a system than one example? How about 0 examples? Well, initially, I thought that this was a crazy suggestion. But then when I thought, it made a lot of sense in specific domains. For instance, let's say you want to extract a table out of a web page. And there might be 20 such fields. Now giving 1 to 2 examples of each field is definitely better having to write CSS selectors and understand the structure of the web page. But the tabular structure is immediately clear to a human being, even without any examples. So why can't a machine do that? And it turns out that you can leverage the presence of large number of inputs to be able to accomplish this. So this is very much like unsupervised learning versus supervised learning in machine learning. You might want to, let's say, join 2 different tables on columns that don't exactly match. So instead of using flash fill to convert a column into a different column that matches, even these kinds of transformations can be done with just 0 examples. Maybe sorting or even splitting. So let me show you a demo around splitting of strings. So how many fields do you think are inside each of the strings in this column? 3. Right? You can extract those fields by giving 1 to 2 examples to flash fill. But if human beings can figure out that if the task is to split and there are 3 fields, all that you need to do is to be able to tell the tool to split the column, and the tool will try to understand the structure and give you these splits completely automatically. And then the last innovation relates to getting something more than the intended program in the underlying domain-specific language. How about getting the program in a language of your choice? So one feedback that we heard from data scientists and developers using flash fill is that it's too magical. They would like to have full transparency with the system underneath, because if you want to deploy these synthesized programs on large number of inputs or on streaming data, you would better want to make sure that it is doing exactly what you intended. And this is now what we have been focusing on recently, to generate readable programs in a target language of your choice. And one other big benefit that comes with this is that now you can start integrating these technologies inside your existing workflows, such as IDEs or notebooks. And interestingly, this also has a lot of educational value. So let me show you my last demo, where I will showcase how these technologies can be integrated inside notebooks and be used to produce readable Python code. So the task at hand is to analyze the 911 calls data set. This is the data set that contains details of various emergency calls. And this data set is available in this CSV format, 911.csv. Now the first step in analyzing a data set like this would be to ingest it into a tabular form that I can then visualize and do some analysis over. In Python, this is often done using the popular pandas library. So how many of you here have used this library called pandas in Python? So quite a few of you here. And it specifically is read CSV API. So let me use the read CSV API of pandas to read this 911.csv file. Oops, something went wrong. Does someone know what might be wrong? I was simply trying to read a CSV file using the read CSV API. That's a good idea. Let's take a look at the CSV file. Aha! This is not a pure CSV file. There is some metadata at the top, and then there's a list of column names that I need to properly account for by passing the right set of arguments to the read CSV API. Turns out that this read CSV API has 50 parameters. So I can either go to Stack Overflow or look at Pandas documentation to figure out which of these parameters to use and provide the right arguments to the read CSV API. Instead, let's use program synthesis to the rescue. So one of the domains for which we have developed the program synthesis capabilities for is to ingest semi-structured documents into tabular form. And that capability has been exposed in this Pythonic manner called read, code accelerator, cx code accelerator.read. And I simply pass the name of the file that I'm trying to read. And when I do that, it tries to understand the structure of this file and generates readable Python code for me to incorporate in my workflow. It has figured out that I need to skip 11 rows. It has figured out the list of the column names at the beginning. It has figured out what the delimiter is. It has figured out the right quoting semantics and so forth. So here in this case, maybe I saved a few minutes of a data scientist's time. But this read API is extremely powerful in 2 dimensions. One, it can not only handle CSV files, but also fixed width files, log files, custom text files, web pages, even PDF documents. And secondly, when the underlying AI is not smart enough to automatically generate the program from 0 examples, then it provides an interactive mode where the user can give 1 to 2 examples of the various fields that they want to extract. And then in many of those cases, the system is still able to generate the right parsing code in order to lift the semi-structured document into a tabular form. So now back to this demo. So I can use this code and incorporate it inside my workflow to populate the pandas data frame. And let's look at the data inside the data set. So it has a date column and a time column that corresponds to the timing of the emergency call. Suppose I want to figure out when are 911 calls most common. Is it on Monday mornings or Wednesday afternoons? So to be able to answer this question, I would need to create a new column where I would like to map the corresponding date to the weekday, which is Friday, as I know from my calendar. And I would like to map the corresponding time, 11:11, into the corresponding, maybe let's say a 4-hour bucket to indicate late morning. Now just imagine how much code you will need to write to convert these strings in the date and time column to the new derived column that the data scientist wants. But thanks to the new Flashfill ++ feature, all that I have to do is to give an example of what I want, and the underlying system generalizes the example into a program and runs this program on the data set to give you the output that you want, very much like Flashfill. But even more than Flashfill, it shows you code, readable Python code. This code has a lot of educational value as well. So now I know how to take a string and cast it as a datetime object. I never knew that this %A was the magic sequence of characters that I have to use to take a datetime object and convert it into the corresponding weekday. You can also edit this code. Instead of 4-hour buckets, you can compute 8-hour buckets. And now I can use this code inside my workflow to compute the new column that I was trying to compute. And now all that is left is to plot the frequency counts of these various time buckets. Turns out that if you want to plot them in the implicit order of these buckets, you again have to do complicated data wrangling. And this is where intent can be very easily described using natural language. But while we are working on that capability, I have written this code by hand. And all that you need to do is to execute this to figure out when are 911 calls most common. So that's on Wednesdays, 8 a.m. to 12 p.m. And just imagine how much time it would have taken for you to draw these kinds of insights by having to do data wrangling yourself. But now with just a few clicks and a few keystrokes, you can accomplish this. So it turns out that notebooks are a match made in heaven for these kinds of program synthesis capabilities, because program synthesis is good about generating small fragments of code. And this is what matches the cell-based granularity inside notebooks. Furthermore, program synthesis can generate code in various different target languages using various different kinds of libraries that the user might be familiar with or might not be familiar with, but they would like to generate code in those libraries. And this can address the challenge of polyglot programming or discoverability issues with new SDKs inside notebooks. Furthermore, deployment of successful program synthesis technologies also requires interactivity to resolve the ambiguity in the user's intent. And notebooks are an ideal platform for that kind of interactivity. So let me conclude now. So program synthesis is setting the foundation for the next generation of programming experiences. If you look at the history of programming, we went from punched cards and assembly language to high-level languages and beautiful code editors. The next transition will take programming much closer to human communication, where it will be very multimodal, involving use of examples and natural language. Interestingly, these concepts are already present in today's programming. Test cases are nothing but input-output examples. Comments are nothing but natural language-based specifications. And now in the future, these concepts will become first-class citizens to author code itself. And this will facilitate two kinds of disruptions. One, 100x more programmers, because 99% people today who use computers do not know programming. These are not stupid people, except that programming languages are very much of an artificial barrier for these people to be much more creative in their lives and to accomplish more. Secondly, these very same technologies will improve the productivity of existing developers and data scientists by 10 to 100x in many domains. Because most of the code that we write today is just boilerplate code. It's plumbing code. There is very little algorithmic creativity that goes inside the code that we write. and there's a huge potential for automating that. The underlying technologies beneath program synthesis combine cutting-edge advances in logical reasoning and symbolic reasoning. These are the techniques that became popular in the first wave of AI and are also behind many different static program analysis tools. And machine learning, which is the ongoing revolution in AI. And I believe that much more technical disruption will come if we put these two different styles of techniques together: logical reasoning and statistical techniques in the form of machine learning. So we have been working towards putting together an SDK for developing these program synthesizers. And I believe that use of frameworks like these shall evolve the process of writing new libraries to that of writing new synthesizers for those domains. So I hope you enjoyed this peek into the future of programming, and that some of you will help shape this future by writing these kinds of program synthesizers yourselves. Thank you.
Hi, we're involved in creating convert string in PowerShell, if you know what I mean.
Yes.
And will it evolve as a function? And can it do all the stuff that you showed in Excel?
Yes,
Thank you.
yes. So the convert string utility was shipped by my pros team, and it is based on a much older version of this technology. And we haven't gotten around to refreshing that capability yet. But for those of you who do not know about these two commandlets, convert string and convert from string, these are the capabilities to drive a new column, the flash fill capability, which is inside Excel. We also put it inside PowerShell, where you can, on the command line, give an input-output example, and then get back a pointer to a function, which can execute the intended transformation on other inputs. And the other functionality allows you to extract tabular data from log files or text files. The challenge with putting these experiences the way they have been inside PowerShell is that the usability is not very clean. And we get many emails where people talk about the functionality not working. It is just that they have not been invoking it properly. So there are two innovations that need to be done on that front. One is to improve the usability experience, and the second is to take our last many years of advances and use those instead of these old technologies.
So there are plans to do that, right?
I cannot speak to that right now, but we are very actively working towards this code accelerator experience for notebooks, and hopefully that might be one way for you to programmatically access these technologies. But I cannot speak to when would they be released.
It's a great presentation, Samit. Congratulations, it was very inspiring. So maybe I had a pleasure talking with you before this conference started, before this speech of yours started, and you mentioned outstanding story about empathy. I thought it's really worth it, and you might share it with a broader auditorium if you like. And maybe can you correlate that with this AI technologies and the future of programming? Thank you.
So earlier in the morning, there was this talk on, or this was the keynote yesterday on design thinking. And then I asked a question at the end about how should that shape the experiences inside classrooms for students. And someone can even ask me, should we stop teaching programming to kids now because programs will be automatically generated? So my belief along that dimension is that there are two very important skills to teach to students, one of which is what I will call computational thinking. And this was a term that was coined by Janet Wing. many people in the world do not even precisely understand the meaning of the phrase, if X, then Y. And being able to understand some of this and reason about things in a logical way can play a big role towards creating more peace on the planet. The second thing, which I believe is also quite important, is what I would call teaching empathy. And maybe I would like to coin a term, empathic thinking, if it's not already there. In fact, my biggest life-changing moment came in my career, halfway in my career, after 10 years of a 20-year-long professional career, when I met this airplane lady, which I would think was a good example of being empathetic towards the customer. And that's when I spent 3 months studying health forums, trying to figure out what problem should I solve next, as opposed to 3 weeks that it took me to develop the first version of prototype, the flash fill prototype. So some of my own experiences in empathy, and Satya, by the way, talks about empathy quite a lot, which is very inspirational. And my own inspiration on this topic has come from some of my parenting experiences, and that's what you were mentioning, the story that I can consider describing. So I have a 6-year-old child, and when he was 4 years old, I wanted to teach him his first math theorem. So the theorem that I picked was that when you add 2 odd numbers, it becomes an even number. So the first evening, I tried to use lots of examples on pen and paper. And of course, I'm the by-example guy, so examples come, of course, very naturally to me. But it didn't work. The next evening, I thought, I need to make it much more fun. So I took out many different toys that I had in my house related to numbers and used them instead. But unfortunately, he struggled. And I was also very disappointed. It didn't work again. So before giving up, the next evening, I tried a different experiment. So this time I used neither pen and paper nor toys. I just used words. I told him a story. I told him, look, an odd number is made up of guys that are all paired with each other, except that there is one lonely guy. So when you bring 2 odd numbers together, the 2 lonely guys pair up with each other and become friends. And he immediately got it. So when I asked him, what's odd plus even? He says, with great sadness, it's odd. Why? Because there is no one to pair the lonely guy in the odd number with. When I ask him what's even plus even, he's very happy and say even, because there's no lonely guy to begin with. Then I shared this story with a storytelling instructor, and he begged me to allow him to use this story in the book that he wanted to write next. But he told me one thing about why this story registered with my child, who was 5 years old at the time. He said, kids are very scared of being lonely. So that's why he was completely plugged in when you were explaining him it this way. So I decided to test it out one evening. So it was after dinner. We were about to go to sleep. He was busy on his iPad programming his robots. Sumer, it's time to go to sleep. Let's go up. No response. I raised my voice. Sumer, we need to go to bed now. Can you please turn it off? Still no response. Sumer, I'm going up now, but I'll be lonely on the odd floor up. And then he immediately turns it off, holds my hand, and says, Papa, let's go up. So I get my lessons in empathy from parenting experiences like this, And turns out that small children have a lot of empathy in them. But the trouble is that this ends up getting dust as we grow up. And if we can be more conscious about this skill, then we can interact better with customers, we can interact better with diverse teams, which is the real demand of these times. So sorry, that was a bit of a digression, but
Thank you, Sumit. So we don't have, unfortunately, any more time for questions, but you can always grab Sumit later on our matinee party. Soon we will proceed towards the closing ceremony, so stick around. Now, okay. I have to get hooked up. Okay, just give me a sec.
Thank you, Sumit. So the moment you've all been waiting for, I hope, to see this conference end, like that's the first thing. The second one would be the prize giving, of course. What else? So let's start with 7 Bridges. Do I have 7 Bridges here with me?
Where are you guys?
They are giving away 3 backpacks.
Beautiful.
Right?
If you need a mic, yeah, you have one over there, and yeah, Jovana has another one.
Hey guys, so the first winner is Marko Bjelica.
Turn it on. Marko Bjelica.
Come up.
Okay, so the second one, Ivan Munic. Is Ivan here? Okay.
Study.
Okay, so the third and last one, Branko Bavrlic. Is Branko here? Okay, no worries. We have his contact, so we will.
Yeah, so
send
they
him.
have the contact and they will. Do you want to say something?
No.
No?
Thank
It's
you,
good.
guys.
You all guys know 7 Bridges, I guess. So thank you a lot
Thank
for
you.
supporting the conference.
Since the beginning.
Okay. Do we have Namix here?
Jump on.
I can hold the mic if you'd like.
Yeah.
We have only one prize. It's Bluetooth headphones, and the winner is Ognjen Nikolic.
Of course, it's a volunteer. This happens every year.
It's very interesting that this is by chance, by accident, that Ognjen also won previous
Really?
year also our prize. So Ognjen, you have to do something for us. Thank you.
Thank you. Thank you for
Just
supporting
keep on
Heapcon.
volunteering here. Yeah.
Telesign is next.
Yeah, they will need a little bit of help with their prize.
So our prize is scooter, and the winner is Marko Miladinovic.
Where is Marko Miladinovic?
Maybe he already has a scooter, so.
If he's not here, I will take it.
I will contact him. We have you have his email. Good. Well, that's good for him. Thanks for supporting Heapcon. Lotus Flare, right?
Hey guys, my name is Milan. I am from Lotus Flare. First of all, let me really say what an amazing event this was. You guys and the entire crew and all of you that we got, the chance to chat with and hang out. It has been really great, and thank you really much.
Thank you.
We only have one prize, but it's a good one. And our winner of our coding challenge was Marko Čajić. Congratulations. Here we go.
Are you the guy who bought like the first ticket last year for Heapcon?
Yeah, I bought the blind grade one.
I'm so happy to meet you. This is Nino.
Congratulations. Yeah. Wait for the photo op.
Czuję se sve kada šapućeš. Dobro.
Thank you. We're a bit tired. Sorry about that. So let's see. Namix was here, Telesign was here, SBG was here, Lotus Flower was here, and I guess that's it. Have I missed someone? Yeah, please, go on. There you go.
Thank you. I just want to say hello in front of the Grid Dynamics. We had 2 games and 1 random prize for the buzz. Yeah, thank you for your help.
Yeah, I see you're struggling. Okay.
Yeah. So,
congratulations.
okay, I need to read the names because I cannot memorize it all. DevOps quiz, we have 5 winners, so congratulations, guys. All the prizes you can take at our office at Boulevard Mihaila Pupina, stop 15. We'll inform you about date and time. So, yeah, we want to meet you a little bit better. So the first prize for Blagoje Jovanovic. Is he here? I don't know. The second, you all guys have the same number of points, so you are already the first. Blagoje Jovanovic, Stefan Mihajlovic, Aleksandar Milicevic. We have one colleague from Holland, Jorrit van der Vem, if I'm pronouncing it right. Okay. We prepared the prize for you here because you probably won't be able to join us in the office, so come here. And Dejan Tadic.
Thank you very much. This is your prize. Thank you very much. Thanks. Thank you.
You got the power bank. The second challenge was for the JavaScript developers and named Code Battle. The first prize that Star Wars Drone was for Mihailo Jovkovic. Are you here?
Mihailo.
Yeah, congratulations. The second prize, headphones for Branko Bavrlic. Are you here, Branko? Okay, and the third one for Filip Vitas.
Now I need to say that Filip Vitas probably got like 3 prizes in the last 5 years of organizing these events, so...
Yeah, we have one more prize. Basically, all attendants of this conference were invited to participate. So we have like, I think, around 72 participants. So we pick one, and the prize is voucher for the Buzz store for that New Balance shoes. So can you tell me the name? Yeah, we have the randomizer. We thought we were going to have some screen here. Okay, the number 4. Can you read from the...
So, the winner is...
Nemanja Veljković.
Nemanja Veljković.
Yeah.
Of course.
Hey, congratulations. This is your prize. So that would be it from Grid Dynamics. Thank you, guys.
Thank you.
Grid Dynamics was, for the first time, a sponsor of Heapcon this year. Thank you for being part of the conference. So let's have volunteers up here.
Come on, guys. Give it up, give it up, give it up.
So we actually have two high schoolers. One is right here. Can you? He's 15. So, well, congratulations for being like the first time volunteering at Heapcon. Thanks you for being here. Thank you all for helping us.
Yeah, nothing would work without you, so thank you, yeah.
Yeah. So, shall you say something about matinee?
No.
Please do.
Yeah, I said a couple of times that we have a big party to close this fifth conference in a row, not fifth Heapcon. So please join us. It's Kombang Dvorana, ex-Dom Sindicata. The place is called Lisbon Bar. It's a very nice, cool, jazzy place. We want to celebrate with all of you. So yeah, we don't want to take a lot of your time this evening. I know you're all tired and that you spent a lot of time with us already, but a drink or two is just a good behavior.
Yeah, and that's a matinee, so you can go home in an hour.
Yeah.
And there are free
there
drinks.
will be some music and free drinks.
Yeah. So and we pay the DJ, so let's not don't let us dance ourselves. You know, we don't want to be alone on the dance floor. We would be very, very, very sad.
Until we start to dance, then everyone will leave.
Then everything is cool.
Okay.
Can we have organizers up on the stage?
So-called Heapspace
all
team.
of you.
Come on.
Okay. I would like to especially present Jovana Jovanovic. She's our artist. So I guess that you've seen this big booth, which said you're an artist there. And she made all of these drawings that you could have drag and dropped during these 2 days. But Igor here, he made a web app. So he actually made it possible for you to play a bit with Jovana's art. And you can take it with yourself, so if you already made something, you can just pick it up at her booth. And don't forget that even though you code, your code is actually art. You've seen that in the outer space room. So you can, with all of your knowledge, you can actually help artists in making their work a bit easier, I would say. And you can help them create even more, and they can, of course, help you think more creatively, I would say. I know that you are all creative, but they just have a different kind of angle of looking at all the things. So, Nina, would you present the team from your side, and then stop
Igor.
with Ivana, and I'll continue.
Igor, come on, please. Take the spotlight. Igor is the founder of Heapspace. Yeah. Do you want to say something on the mic? Yeah, please do, please do. I'm on. I mean, it's yeah.
When I was young,
it's only natural.
I'll be quick, yeah. Thank you, everyone. This means really a lot to us, and I hope it means really a lot to you. Thank you.
Okay. Jelena, no, everybody has to say something. Come on, we've been speaking here for 2 days. Come on, Jelena, you.
Told me this before.
Jelena has been responsible for all the content of the notifications and everything else that you saw through Huva app, and she was the brains behind our media strategy. So yeah, would you like to add something to that?
Just want to say thank you.
Yeah, thanks is due. Social media by Milena. It was done perfectly. You know, our stories were dots this small thanks to her and her dedication. And she did a perfect pre-event warm-up for everyone to see Heapcon in the best light possible. Do you want to add something? Please do.
It was super fun. You guys are great, and nothing more.
Okay. Ivana, she was the fresh addition to Heapspace team, but got into her boots very quickly. She led the cat stage, ninja the cat stage. Yeah, sorry, I couldn't miss
Even
ninja.
though she doesn't like cats, please note that.
Yeah, yeah. Even though I'm a ninja. Yeah. But
I get
yeah.
hate from all the cat lovers.
Give it up for the cats and the ninjas. She did a terrific job, although she was a little bit nervous before. Please.
Thank you. I'm so happy to be a part of this event. Thank you all.
Jovana didn't have a chance to speak, so
yeah,
if you'd like to add something.
I just want everybody to say thank you for using the application, for feeling brave to be creative and stuff like that. And once again, if you haven't taken the art you made, it is at the booth and you can take it. Thank you.
So I'll present Stefan. Stefan is also the newest addition to our team. Last year he wrote to us he wanted a ticket for Heapcon, and then he just got it. And this year he became a part of Heapspace. He did something around the website and everything else on the technical side, as well as Nicola, who led the third track, Outer Space, but he went to Moscow, I think, to give another talk there. So let's hear it for both of them. Do you want to add something? Nino has the mic.
Please do. Everyone add something.
Well, thanks for joining in, and I hope to see you next year as well. It was a fantastic experience for me this year by organizing this, so thanks again.
Yep. Okay.
And we have Vesna here.
I'll just sneak in the mic.
Yeah. Vesna was our speakers coordinator, but not only that, she did all sorts of stuff regarding the tickets, regarding the administration. So this whole of a burden is actually on her, and she did an amazing job. Thank you so much for being part of the team.
Thank you. Thank you. Something.
And this guy here, he actually did, I will say, the hardest work, because he was the head of logistics. So they did a lot of carrying and delivering stuff to Dom Omladine so that you can have everything at your disposal at every time. But not only that, Dimitria is our fundraising manager, as well as Ninoslav. We didn't mention that.
Okay, I didn't mention myself.
So, yeah. So all sponsors relations, actually, Dimitria did all of that. So let's hear a round of applause for him.
Thank you, all of you. Thanks to all sponsors coming here, and hope see you next year too.
Yeah.
I already did a short intro, so Ninoslav is with us for several years now. He is a really talented marketer, but he also does business development, and he helped our fundraising efforts. I didn't prepare this. This came
neither
out
did
naturally.
I, so I'm just thinking what to say about you. And who is going to do this? Ivan, where are you?
Let's hear it for you.
Thanks. Yeah, and I also had the pleasure of leading this stage, so thanks to all the audience who came here and listened to our great speakers. Jovana was our project manager, so she did everything. I cannot.
No.
She coordinated the whole thing.
I help you do everything.
Yeah, you coordinated the whole thing. She bombarded us on Slack, on Asana, and you know, those tools are burning now. Those buildings don't exist anymore. So thank you.
Thank you for hanging out with us. I hope to see you at Kombank Dvorana. Thanks to all of the sponsors, to all speakers, and to all of you. I hope to see you next year.
Here's for you guys.
Možemo neku sliku zajedničku.